PPTಗಳೆಲ್ಲ ಒಂದೊಂದು ಶೇಪಲ್ಲಿ ಇದೆ, ಎಲ್ಲ ಒಂದೊಂದೇ ನೋಡ್ಕೊಂಡು ಮಾಡ್ಬೇಕು.
ಇಲ್ಲಾಂದ್ರೆ ನಾವು ಟೆಂಪ್ಲೇಟ್ ಅಲ್ಲಿ ಕೊಟ್ಬಿಟ್ರೆ ಕೀನೋಟ್ ಇದನ್ನ ಯೂಸ್ ಮಾಡಿ ಅಂತ ಕೊಟ್ಬಿಡ್ಬೇಕಷ್ಟೇ ಟೆಂಪ್ಲೇಟ್, ಅವ್ರ ಕಂಟೆಂಟ್ ಹಾಕೊಂಡ್ ಮಾಡಂಗೆ.
ಪ್ರಶಾಂತ್ ಹೆಂಗ್ ಕಳ್ಸಿದಾರೆ ಅಂದ್ರೆ
ಪ್ಲೇನ್
ಅಲ್ಲ ಅವರು
ಮಾಡಿದೆ ಹೆಚ್ಚು. ನಾನು ಅದಕ್ಕೆ ಓಕೆ ಅಂತ ಅಂದೆ. ಮತ್ತೆ ಚೇಂಜಸ್ ಹೇಳಿದ್ರೆ ಇನ್ನ ಕಷ್ಟ ಅವ್ರಿಗೆ.
ಎಲ್ಲ ಗೊತ್ತು 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 ಅಂತಾರೆ, ಅದ್ ಏನ್ ಮಾಡ್ತಾರೆ ಕೊನೆಗೆ ಔಟ್ಕಮ್ ಅಲ್ಲಿ ಏನಿದ್ರಲ್ಲ ಗೊತ್ತು 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 ಅನ್ನೋದು ಹೇಳ್ತಾರೆ.
ಪ್ರೆಸೆಂಟೇಶನ್ ಪ್ರಾಬ್ಲಮ್ ಇದೆ. ವಿವೇಕ್ ಕಾಲ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಹಲೋ ಸರ್. ಹಾಂ ಸರ್, ಲೈವ್? ಯಾ ಎಸ್, ಯಾ, ಥ್ಯಾಂಕ್ ಯು. Now we are like adding the panel members and all. So we have started. No, 8:30 participants will start. 8:45 we will start the session. That's how it is planned. Yeah. Okay. ಸರ್ ಲೈವ್ ಆಗಿದೆ. ಅಲ್ಲಿ ಕಾಪಿ ಸ್ಟ್ರೀಮಿಂಗ್ ಲಿಂಕ್ ಅಂತ ಒಂದು ಆಪ್ಷನ್ ಇದೆಯಲ್ಲ ಮೋರಲ್ಲಿ, ಅದನ್ನ ಕಾಪಿ ಮಾಡಿ ಇಲ್ಲಿ ಚಾಟ್ ಪೇಸ್ಟ್ ಮಾಡಿ ಸರ್, ನಂಬರ್. ಇವ್ರು ಯಾವ ಲಾಗಿನ್ ಅಲ್ಲಿ ಇದ್ದಾರೆ? ಲೈವ್ ಗೊತ್ತಾಗ್ತಿದೆಯಲ್ಲ ಇವ್ರಿಗೆ, ಲೈವ್ ಆಗಿದೆ ಅಂತ ಇದ್ದಾರೆ.
ಅವ್ರಿಗೆ ಮೆಸೇಜ್ ಹೋಗುತ್ತೆ.
ಓಕೆ. ಸಿಕ್ತು ಲಿಂಕ್.
ಇದಕ್ಕೆ ಹಾಕ್ಬಿಡಿ ಮೇಡಮ್, ಗ್ರೂಪ್ಗೆ.
ಆಗ್ತೀನಿ.
Hi, this is Kapil. I'm from SCTJU. So I've been part of the batch 2011 and I have done my computer science engineering in the Kanakpura campus. And with respect to my journey, the college journey has been something which is very memorable for me. And regarding my background, I have started my career with Thomson Reuters as an intern, then moved to Cognizant. Worked there for one year, and then I've moved to Unbox, been there for 2 years. So as a developer, overall total experience of 3.5 years into IT as a developer. Now currently I'm having my own startup which is called as Revampin, and I'm the founder CEO for that. And it's been there into the market from past 2 years. We have been doing really well, and this is with respect to my professional experience. So life after graduation has been like very challenging for me. A lot of experience, a lot of learning, and we were facing a lot of challenges with respect to skills, with respect to opportunities, with respect to finances, right? So a lot of challenges were there in the journey, and in college we were there in the comfort zone, of like the environment where we have a lot of friends, and we have studies, academics, we have sports. So a lot of things were there, and it was all comfortable. But once we get out of college, and the life completely changes, and it's been full of wonderful learning and experience for me. It has been on a positive end. Coming to JAIN University, I was into sports, and the first thing which caught my eye was the campus. And just by looking at the campus, I wanted to be there.
ಆಡಿಯೋ ನಿಲ್ತಲ್ಲ, ನೀವೇ ನಿಲ್ಸಿದ್ರಾ?
कहा था।
Hi, this is Kapil. I'm from SCTJU. So I've been part of the batch 2011 and I have done my computer science engineering in the Kanakpura campus. And with respect to my journey, the college journey has been something which is very memorable for me. Regarding my background, I have started my career with Thomson Reuters as an intern, then moved to Cognizant. Worked there for one year, and then I've moved to Unbox, been there for 2 years. So as a developer, so overall total experience of 3.5 years into IT as a developer. Now currently I'm having my own startup which is called as Revampin, and I'm the founder CEO for that. It's been there into the market from past 2 years. We have been doing really well, and this is with respect to my professional experience. So life after graduation has been like very challenging for me. A lot of experience, a lot of learning, and we were facing a lot of challenges with respect to skills, with respect to opportunities, with respect to finances, right? So lot of challenges were there in the journey, and in college we were there in the comfort zone, like the environment where we have a lot of friends, and we have studies, academics, we have sports. So a lot of things were there, and it was all comfortable. But once we get out of college, and the life completely changes, and it's been full of wonderful learning and experience for me. It has been on a positive end. Coming to JAIN University, I was into sports, and the first thing which caught my eye was the campus. Just by looking at the campus, I wanted to be there. It provides a lot of wonderful facilities, and it was a very great experience for me. Like the 4 years I was there in hostel, and the rooms were really nice, and these are the basic things somebody who just passed out 12th who comes and wants to get into any college looks at. With respect to computer science, I've been always fond of computer science, and that is the reason I chose, because it is my passion. I want to program, I want to code, and that is the reason why I wanted to get into computer science. Every day after the college, I was there in hostel, so it is a different kind of experience that we have, all the hostelites. So after the college, we used to have snacks, then we used to run to the ground, practice every day, right? So 3 to 4 hours we used to be there on the field, and this is the experience which definitely we can't get after passing out from college. And every day was a memory for me, and we had a lot of fests. We had conducted and organized a lot of fests. We have won tournaments, with respect to hostel, like all of your best friends are around, and you will have fun every day, and that is something which is very much memorable for me. There are a lot of teachers who would be.
Good morning, sir. Good morning, Samiran sir.
Good morning. Can you hear me?
Yes, sir. Yes, sir. Yes, sir.
Is it clear?
Yes, sir. It's sir.
Okay, fine.
So we'll start after 8:45.
Yeah, it's okay. The audio is clear, right? Because last time the audio was not very clear.
Yeah, audio is clear.
Okay, fine, sir.
Very polite to you. A lot of teachers would be rude to you, but at the end of the day, every teacher has plays a very important role in your life. Whether you like any particular teacher or not, that is something which doesn't matter to me, but I feel every teacher is important, and they will play a very important role, and I have taken a lot of learnings from each and every person. Now it might not just be the subject that they are going to teach. It can also be a lot of learning in terms of life, in terms of personality, in terms of facing the challenges, and a lot of learning in that way as well. So I can say that every teacher has contributed to my life, and I want to thank all of them. Currently I'm not in job. I have my own startup, and it feels wonderful because like it is basically your passion that you're trying to put it out, and you're trying to work towards it. So how much ever effort I put, I don't feel like I'm working, and because I'm very much passionate about it. But when I was there, part of corporate, the kind of experience that I have got working in different companies, it was something which is really nice, and I would definitely urge all the students basically once you get into corporate. So it is not just the skills that you learn, but you should also try and learn how businesses run, how the market is booming, how the industry runs, and you have to try and get an overall or holistic kind of learning once you get into your job. Right, so that would be my suggestion. Basically, what we learn in college is something you would be just aware of the concept, right? So I'll just take an example of computer science. So assume there is a subject called as data structures. So you would just be aware of what is a data structure and how does it work. That's all. But what happens once you get into a job or work is the company will start expecting you to solve a problem by implementing those concepts that you learn in college. So this is basically something called as a skill gap that every student who passes out faces, and anyone who gets into a job. So this is a challenge definitely that people have to overcome. Now what is there in job is basically you would be implementing these concepts and trying to solve real life problems, right? Implementing those. And this is where it completely is different, and this kind of learning is very much needed right from your college. So try and get into some opportunities, do some internships, and try and do some freelance projects, right? This will help you bridge the skill gap. Revampin is the startup name, and we have been there in the market past 2 years. And the first event that we have done was in 2015 November. That was done in JAIN University, our campus, SCT-JU campus. Now, how did we get this idea, and what is this idea? I'll just brief about that. So I started right from my end of third year as a freelancer. I was doing a couple of projects for different small scale businesses. I was building video brochures for them. I was building websites for them. I was doing some digital marketing. Now this gave me an experience into the world of business, right? How to talk to clients, how to interact with people, and how to deliver, how do you need to serve your customer. So a lot of experience into business, and this was one learning. And the second most important thing which helped us get into this idea was my final year project. So my final year project was into algorithmic trading. So automation of stock market trading is what I was into. Now this is a very vast field, and it is a booming field as well. So this gave me an opportunity to learn a lot more into the financial education segment. Now business experience clubbed with investments or financial education segment, these two these two are very important for any individual, because anyone who makes money should know how to manage his money, and to make money you need to understand businesses, right? So this kind of education I felt was very much useful for me, because it was helping me become better in terms of my personality. It was also helping me in terms of gaining a lot of skills, which also helped me crack a lot of interviews as well. And this, like my personal record has been every interview that I've attended, I was able to crack it. And this has been my personal achievement. And this was only possible because of the exposure that I got in terms of business and investments, because it made me a better person. Now these two skills I felt was the most important ones that every student should be aware of, and that made us start Revampin, and we are into the segment of financial education clubbed with entrepreneurship, and a new segment that we have launched is also into self-healing, because we believe in a formula that life equals to health plus wealth. So both go on together, and you need both of them to become successful in life. So this is the idea, and we have been doing courses and workshops into financial education segment. We have been training a lot of people into stock market investments. We have been training a lot of students into entrepreneurship and business related ideas. So we help them convert their idea into a prototype and start making revenue out of there. So currently we are running 2 startups and this has been my greatest achievement. All the people who are part of Revamp and Thrive, they are from JAIN University, right? And like we have been together right from the college time, and we have been working together. We have been facing challenges together. And the faculty, the best part is the faculty of JAIN University are still helping us out, right? People who taught us different subjects, right? So they are basically our mentors currently as well, part of Revamp and Thrive. They have been guiding us, they have been mentoring us, they have been teaching us a lot of things, and they are basically the go-to persons that we have. And with respect to other achievements, we have won tournaments, part of the college cricket team, and apart from that, I've been a trained mountaineer, and many other things, like small things, but the greatest achievement has been these 2 startups, Revamp and Thrive. I am proud to be a Jainite.
School of Computer Science and Engineering, we have been offered with the options to choose the domains which we are interested in. Being specific about my domain, cloud computing is current trend in the industry.
It offers an eclectic mix of educational as well as co-curricular activities. The facilities provided by the college, such as AC rooms, projectors and online learning materials on Kraken, help make the learning environment here an ideal one.
The School of Engineering and Technology has a vibrant campus offering us top-notch sports, cultural and placement facilities. Unlike other engineering courses, our specialization offers us vast hands-on experience and in-depth learning in latest and emerging technologies.
The BTech in Mobile Application Cloud Technology has started in the year 2016. And right now the candidates who have enrolled in 2016 are in the final year of their engineering. Currently in the phase 1 of their placement cycle, we have had around 60% of the candidates placed.
We follow an application-based learning program where projects are encouraged and industry experience is imparted through various workshops and seminars.
School of Computer Science and Engineering have been organized many technical seminars by VMware certified professionals and other industry experts to improve our expertise.
We are provided with the training for certification courses like Amazon Web Services, Google Web Specialist and Certified Ethical Hacking. The labs are equipped with Apple computers and high-speed LAN connection to ease our practical learning.
The curriculum for mobile application and cloud technology includes the following courses like iOS application development, Android application development, cross-platform app development and web application development, which every application developer engineer has to know at his fingertips.
With the best faculties and lab experiences curated perfectly with specific outcomes in the field of cloud technology and mobile application with subjects like Android, mobile architecture, iOS, RDBMS, etc.
Cultural and sports facilities are outstanding. They motivate us to take part and explore the inner talent in us. Infinity is the main techno-cultural fest which invites diverse cultures to have an exposure.
We have a dedicated placement team with the main aim of providing the best opportunities to the students.
Many companies such as Capgemini, Infosys and TCS and many companies from Japan have visited our campus and picked the best of students.
Being part of cultural club and sports team is always a memorable part of one's life, alongside having expertise in academics.
With the students from different countries, it's always been a wide range of cultural diversity and share of knowledge.
We have been accommodated in the hostel provided by the college with 2 and 4 sharing room services. Also a common eating place called the mess with wide variety of food which cater to the students coming from all the states of India and around the globe.
I'm Neetu Subramaniam. I've just completed my BCom from Presidency College and I look forward to do my MBA here in JAIN.
I'm Pooja Rian. I've studied my BBA in Dayanand Sagar Business Academy.
My name is Karan Agrawal and I'm basically from Gujarat, Surat, and I'm currently pursuing my BBA and I'm here for the Master's MBA program.
My name is Jonathan. I am from Mangalore.
While going through the net, I came to know that JAIN University
Deepa? sir.
Hello.
Hello, Prashant. Prashant, sir.
Yes, yes.
Is it Prashant? Okay, fine. Am I audible, Prashant, sir?
Yes, it is audible. What about my voice? Is it okay?
This is fine.
I am from Afghanistan. I am studying in JAIN University Computer Science Engineering. I came here 2 months before when I got SII scholarship. I was graduated from Lycée Istiqlal High School in Afghanistan. First of all, I want to become independent. I want to see how things goes in India. And I like to study computer science. As you know better that Bangalore is the city of computer science. For that I prefer India. And India develop our minds. Not we don't study just like books, or that we are studying in practical. We are studying in outside in big companies. We are working with them. For that reasons I prefer India. As I had searched best college in India, I found JAIN University among one of the best university in India. And JAIN University is good in ranking, and the JAIN University degree is valuable in all countries like USA, UK, London. In every countries we can get job in very big companies. Teachers are friendly and supportive too, and they are always ready for helping us. The environment system in JAIN University is so good. We are international students because they provide, like we are in like Indian bias. We can go every place, we can speak with everyone, and we are so safe in this country. I am so happy that today I am in India. I like computer science. Today I am studying my computer science in Bangalore in JAIN University. JAIN University, I like everything. Like I came 2 months before in JAIN University. Every day they are provide us bus. We can study until night in library. We can take so many books from library. We have so many labs like physics lab, chemistry lab, programming lab. In JAIN University, everything is good for us, and they provide for us laundry. They just want to we study. We are not working in hostel. They provide for us Afghani food in hostel. For every countries they provide their food. For that I am so happy in JAIN University. If you want to be successful in life and looking for the right exposure to brush up your skills, and if you want to be powerful, then try JAIN University.
So can we start? Virtually? Can we start, sir?
Deepa ma'am.
Deepa ma'am.
I will check. I think she's there. On call.
As host, madam is there, sir.
Host ನಾನಿದ್ದೀನಿ.
Okay.
Co-host ಅಲ್ಲಿದ್ದಾರೆ.
Co-host ಇನ್ನೊಂದಿದೆ ಸರ್. ನಂದೊಂದು co-host ಇದೆ ಸರ್.
Okay.
अच्छा ठीक है तो बात करें
Hello. Very good morning, one and all. Welcome to this workshop on deep learning. So now I call Rakshali.
Hello.
Over to you, Rakshali.
On behalf of the Department of Computer Science and Engineering, Information Science and Engineering, Computer Society of India Region 5, I heartily welcome to all the participants and panel members for this workshop on deep learning. I welcome our beloved HOD, Department of Computer Science and Engineering, Dr. Narayan Swamy sir, to this workshop. Now, I request our beloved HOD in charge, Department of Information Science and Engineering, Professor Arun N. sir, to welcome the gathering. Over to you, sir.
Good morning, one and all. Present over there for the one-day workshop on deep learning in association with Computer Science, Computer Society of India, and Department of CSE and Department of ISE. A warm welcome to all. I would like to first thank our management and our chairman for providing a platform to perform this kind of workshops very often through this during this pandemic situation. I'd like to thank Dr. Hariprasad, our beloved director, for constant support towards encouraging towards doing workshops or doing any sort of seminars and all. I would like to thank our beloved Dean, Dr. Kuldeep Sharma sir, who is constantly giving motivation to perform these kinds of workshops and technical sessions. And I also thank Dr. Narayan Swamy sir and all the faculty members who are present over here for the session, who are giving a constant support. And I welcome all the students for the day to utilize or to learn something on deep learning and utilize the session to a core. So thank you.
Thank you, Arun sir.
Thank you, sir. Now I welcome respected Dean, School of Computer Science and Engineering, Dr. Kuldeep Sharma sir, to this workshop in his absentia. Now I request Honorable Director, Faculty of Engineering and Technology, JAIN, deemed to be University, Dr. Hariprasad SA sir, to this workshop in his absentia. Now, I request respected Dean, students, Faculty of Engineering and Technology, JAIN deemed to be University, Professor Samiran Bhattacharya sir, to address the gathering. Over to you, sir.
Sir, you have to unmute. Samiran sir.
Very good morning to Dr. Narayan Swamy sir, my dear colleagues and my dear students. It's a great privilege to address all of you in this inaugural session of workshop on deep learning in association with the Computer Society of India. CSI student chapter at FET JAIN University has the membership of CSI from 2016. We have conducted several workshops and seminars in cloud technology, Oracle Cloud Platform, etc. Coming to deep learning, The first thing which comes to our mind is, what is deep learning, which has brought such a revolution in our lives? Basically, deep learning is itself a subject of machine learning. But in this case, the machine learns in a way in which humans are supposed to learn. Today, you all will be getting a great insight in this fundamentals of deep learning and its application in real-time systems. I don't want to take much of your time, but today when the entire world is caught in the midst of fear and insecurity, I congratulate all of you to take your valuable time and register for this program. Before finishing, I would like to add a small joke from Three Idiots, Flynn. Make your girlfriend and your wife the same person. If your love is photography and you marry computer science, life will be utter disaster. So let your love and wife be deep learning for today. Thanks and best of luck to all of you.
Thank you, sir. Now I call Dr. Saravanan C. Sir, Assistant Professor, Department of CSE, to give glimpse about the department. Over to you, sir.
Thank you. I welcome all the participants to this one-day hands-on workshop on deep learning. On behalf of Computer Science and Engineering and the Department of Information Science and Engineering, I would like to give on the department. First, I would like to start with the vision of the department: to emerge as a model center for education and research in the area of computer science and engineering through knowledge acquisition, dissemination, and generation to meet social demands. So our goal of our vision is to become as a research center across the globe. So to accomplish this vision, we have framed 4 missions. The first one is to impart the quality education in cutting-edge technologies or kind of new technologies and teaching learning ambience in computer science and engineering. So we are following a unique pedagogy method to instill good kind of knowledge into the students community. And the second part is that to establish a center of excellence in collaboration with industries, research laboratories, and other agencies to meet the changing needs of society. So to meet the social needs or the industry needs, we have established several laboratories which is useful for this community. And the third part of the mission is to provide an environment conducive to develop innovation, team spirit, and entrepreneurship. So we are providing a good environment so that the student will come out with a good idea or a good novelty, and also we are inculcating entrepreneurship skills so that it will meet the industrial needs when they complete their and the last part of the mission is to practice and promote high standards of professional ethics and transparency so that they will follow some moral values in the society. 3 programs under the Department of CSE. The first is a Doctorate of Philosophy, Computer Science and Engineering, and postgraduate in Computer Science and Engineering, and undergraduate in Computer Science and Engineering. And coming to the thrust area so that it will meet the current trend, what actually the industries or companies requires. So we have classified this domain as 4 parts or 4 areas. What we call as first one is data engineering, which is headed by Dr. Narayanaswamy Ramaya, Professor at Department of CSE. And we have identified another trust area called the network technologies, which is headed by Dr. Vigeshwaran, Professor, Department of CSE. And the important one, the trust area now it is in demand is intelligence system, which is headed by Dr. Ganapati Panda, a visiting professor at Department of CSE. And finally, software engineering, which is headed by Dr. Jayanti Kannan, Professor, Department of CSE. So I'm sure that when the students come out of the program, they will be familiar in any one of the, so that it will be useful for their future or career. And if we focus on project learning, to come up with the project based learning, we have established several laboratories or field development program. So I have listed some of the things. The first one is database laboratory, which is associated with Oracle Corporation, and also have an application development laboratory. And in this application development we have iOS application, and we have an exclusive high performance computing laboratory, which is enabled with NVIDIA based GPU, where high performance networks or high performance computing are done under this laboratory. And we also have an exclusive open source computing laboratory, where all the big data analytics using done under this laboratory, parallel with the artificial intelligence as well as machine learning. And we have an exclusive network laboratory associated with Cisco Network Academy. So here the students certified with network engineering. And we also have an embedded system laboratory, or we call it as an Internet of Things laboratory. And finally, we have a Linux laboratory, which is exclusively associated with Red Hat Academy. And we have some of the laboratories like the software engineering laboratory, project laboratory, and research laboratory. And we have signed MOUs with companies across the globe. I have listed out some of the companies. The first is iNurture Education Solution Private Limited, under the industry of iNurture Education Solution, which is signed during 2013 with a bond of 10 years. And also we have signed a Micro Focus, which is of 3 years, and Cisco system. So what we call a Cisco Network Academy, we have exclusively signed with the Cisco company with a lifetime bond MOU. And also we have several chapters like ICT Academy and IEEE Student Branch, Society of India, ICT Academy Jaipur chapter, EICT Academy Jaipur chapter of 3 years and 1 year. And also we have having 1 year of bond, and we have exclusively connected with Infosys company, what we call as MOS, Infosys Campus Connect. Of everywhere we will enable with the company. And coming to the publication analysis of the department, this chart shows clearly how far we are in the research. So the research publication shows, like in the current academic year, it comes around 45 publication. In addition to this, we are also concentrating on UG as well as publication, UG and PG publication. In addition to that, PG publications are done all in the SCSE as well as Scopus indexed journals. And we have I have listed out some of the research grants which is funded externally as well as internally. So first three is the research grant of external. First one is evaluation of LNT for social soil moisture application, which is funded by ISRO of the duration of 3 years, which is headed by Dr. P. Pradeepa, is a principal coordinator, and Ms. T.P. Deepa as the co-coordinator. And also we have a high performance computing laboratory, which is with GPU. So this is granted by the funding agency NVIDIA of 1 year, which is headed by Ms. T.P. Deepa. And also we have funded with DST NIMAT project, where we are running a different entrepreneurial awareness camp to the students. So this is for 1 year and it's headed by Dr. G. Kumaraswamy. And also, in addition to the external, our management has provided an opportunity to do a project internally as well. So that we call it as an internal research grants. The first one is developing a secure IoT-based remote patient monitoring system with predictive diagnostics using machine learning approaches, by Dr. G. Kumarasamy as a principal coordinator. And also the other internal project is Smart Village Using Technology, which is of 3 years, which is headed by Dr. Narayanasamy Ramaiah, head of the Department of CSE, as a principal investigator, and a co-investigator as Professor Sahana Shetty. And you know, all in this pandemic situation, we are all get connected through tools. So we have listed out 3 ICT enabled tools like Zoom platform, where we are connecting with the students. All online learning or teaching learning pedagogy is followed in this platform. In addition to that, we are also connected with Google Classroom, as well as for CoLab, which is a laboratory equipment. We all are aware of that. And also we have Cisco WebEx meeting. We are also connecting in this platform also. And we have an exclusive students club. Okay, under the students club, we have forum, where students come up there with their new idea. They will play a leadership role and they will in free activities and deliver the lecture or some kind of any program. So the mission of Enigma is to bring like-minded, enthusiast people together to share their ideas for development, mutual contribution. And it also provides opportunity for students to pursue their personal and professional goals under the club. To enhance their skills, students are encouraged to participate in activities that allow them to develop leadership and organizational skills apart from managerial activities. So under this Enigma Club, I have listed out 2 events. One is called tutorial, that is conducted in department for all the students community, and also we have a graphical user interface as well as a recent technology workshop. So you can find out or check out the Enigma profile in the LinkedIn group. And coming to the IGNON forum, this forum is mainly to organize, or students will take their leadership role, and where they will come up with new ideas, participate in various events to give the leadership skills. To coordinate all these clubs or forums, we have a board of members. The president is Mr. Sanjeevan Chakrabarti, and the vice president Mr. Aniket Mehta, and joint secretary Mr. and treasurer as Mr. Param. Head of this board, we have mentors like Dr. Kuldeep Sharma, a mentor, and also Dr. Narayanasamy Ramaiah, mentor. And to coordinate this kind of activities, we have Professor Sahana Shetty as a faculty coordinator. So coming to the placements, so the highlight of university, package of 3 lakhs per annum, and every company is offering opportunity to the students. We have an average salary of 7 lakh per annum, as well as we have a placement percentage as 98.5%. Almost we are nearing the ideal goal 100%. And around among the 200 plus companies, 150 plus companies are offering more than 10 lakh per annum. So this is the highlight of our university. And the placement percentage academic year wise. So you can, this shows that the current academic year 2019-2020, a good percentage of nearing about 100, and we are also offering a consistent placement to the students. Thank you one and all for listening in patience to this glimpse on Department of Computer Science Engineering and Information Science and Engineering. And I would like to thank for this opportunity given by our management, directors, dean sir, of Information Science Engineering, and all of the faculties. Say thank you, and I hope this session will be very useful for all of you. Thank you. Over to you, MC.
Thank you, sir. Now I call Professor Harish Naik, sir, CSI Coordinator, Department of CSE, to give CSI walkthrough. Over to you, sir.
Thank you, Rakshali. Good morning, one and all present here. So welcome to the one-day workshop on Introduction to Cloud Computing. Sorry, Introduction to Deep Learning. So in continuation with the department glimpse, I am here to continue with the CSI walkthrough. So here we are glad to inform you that our university, JAIN deemed to be university, has a professional body membership with the Computer Society of India. So in Computer Society of India has a professional body which is formed in the year 1945 to 1964 to 65. So CSI has signed a MOU with the spreading IT awareness throughout the country, so that helpful to the students in IT qualification. And CSI has the oldest and largest organization of IT professional India, and that is having 25,000 members and 63 chapters and over 185 student branches throughout the country. So we have a professional membership with CSI from the year 2016 till date, and the objective is to meet the mission and the societal activities of the institution. We have also signed MOU with the IEEE student branch under the leadership of Dr. Kuldeep Sharma sir, Dean CSE. From the IEEE student branch, we have organized a JU hackathon, so which was conducted on July 16 to 18, 2019. So it was an initiative to aim students across the nation for encouraging them to create the creating the creativity potential and thus society with the innovation creations. So coming into the CSI student branch activities, so from the past year we have organized many workshops, conferences under the association with CSI. So recently we have conducted a workshop on cloud technology, which was held on 23rd Feb 2019, and a seminar on Oracle Cloud has been conducted, so 18th of October 2019. And this year we have started with the introduction with the deep learning. Still many workshops and the conferences we have planned in this year. So coming into the CSI activities, the performance of the CSI activities, so we are increasing the workshops or the conferences and the events year by year. So since we have started from 2016, so till it was increasing the number of workshops and the conferences. So coming into the benefits of membership with the CSI. So coming into the institutional membership benefits, it will recognize the accreditation bodies like NAC, NBA for association with a professional organization. So it grants a fee nominee membership to 3 faculty members. So they will grant a free membership nominees to the 3 faculty members, and they will be giving access to their portal by using the login privileges which is provided from the CSI, and they will be providing to the faculty members 4 copies of CSI communication every month, so that in turn that will be those CSI communication copies will be shared to the students. Coming into the benefits and advantages of CSI student members, so in terms of recognition, students, if the students have registered the membership with CSI, they will be getting the CSI membership identity card, and they will be getting the appreciation letter or certificate for performance excellence. So whenever we conduct workshops, conferences, students will be getting the appreciation letter for coordinating or attending the events. And CSI can also provide industry recognized CSI certification opportunities. Means the CSI will be having the MOEs with some industries also, so that can also be, the students can also be participate in such events and they can be getting the certification. So coming into the knowledge enhancement, so students can access the knowledge portal of CSI through login ID and the password which will be given from the CSI, and they can improve their technology updates through the conferences, seminars, tutorials and the workshops which has been organized in association with CSI, and also a forum of activities like paper presentation, quiz competitions and exhibitions. So these events also will be organized in association with CSI throughout the nation, so the student members can get the concessional rates of attending the events. Coming into the CSI publication, so CSI communication will be released every month. A magazine will be released from the CSI communication. The soft copy will be shared to the students so that they can knowledge themselves whatever the research and the technology which is running currently, they can knowledge themselves. And coming into the next advantage, eligibility to publish articles in CSI communication journal and WizKid. So they can be eligible to publish an article in the CSI communication by contacting to the coordinators, and journal and the WizKid, like some quizzes they can participate and they can publish the articles. Coming into the next advantage, participation in joint events of CSI seminars, workshops and conferences. So students can also participate in CSI related, whatever, wherever the institutions will be conducting CSI seminars, workshops and the conferences, either will be in the free of cost or with the concessional rates. So these are the advantages of the CSI student members. Thank you, one and all. So I thank all support from the HOD sir, director sir and the dean sir. So thank you, one and all.
Thank you, sir. Now I welcome Madhumala RP ma'am, CSI coordinator, ISE and Deep Learning Workshop coordinator, Professor Deepa TP ma'am to this workshop. Now I introduce resource persons of the day, R. Rishabh Jain and Abhishek Mohanty. R. Rishabh Jain is student of CSE department of JAIN University who is passionate about programming and has worked on projects involving app and web development. He has also co-authored a paper on the simplex method published in IJIRST. Along with other interests, he is also very passionate about deep learning and is currently working on Stanford CAR dataset. Abhishek Mohanty is from the ISE department of JAIN University, is an avid deep learning enthusiast with a passion for the domains of natural learning processing and the ethics of artificial intelligence in the modern world. He is currently working on text generation, Q&A bots, and machine translation, and has also dived into machine vision. He loves to play games that act as challenges. In common, they worked on several Kaggle datasets involving prediction and association based problems, achieving quite good levels of accuracy. Now, I call R. Rishabh Jain to take over the sessions. Over to you, Rishabh.
Thank you, Rakshali, for that amazing introduction. And without further ado, I'll be sharing my screen for the presentation. I hope everyone can see my screen.
Yes, yes.
Hello, everyone. My name is R. Rishabh Jain, and I, along with my friend Abhishek Mohanty, are on introduction to deep learning. We, at the end of this webinar, get the key fundamentals about deep learning, which would help you start your journey or dive more into deep learning. First, let me tell you what will you be actually learning in this whole webinar. First will be the fundamentals, where I would be telling about what are the key knowledge requirements that are needed before you get into deep learning. Mostly the general knowledge or a bit about ML and DL. Then there'll be the neural learning, where Abhishek will be talking about what is a perceptron or how a neuron works. Going deep, where we introduce about hidden layers and optimization techniques. Then introduction to introducing backpropagation, where we tell you how actually a model learns, a deep learning model learns properly. Lastly, putting it all together, that would be, we'll see small Python snippets where we write our own small deep learning models, and not huge, very small, and run it for small inputs and outputs. Before we start, I would like to say, what do you need before deep learning? The basic fundamental is, like, you need thought process everywhere, but uh, in deep learning you need more. The thought process and logical skills are a bit different from the way you do, because here you will be interpreting data rather than just seeing numbers, and the data could be text, images. You'll have to clean them, you'll have to see what kind of data they are. Then you need to be curious, because when you're curious, you ask a lot of questions related to the problem. Hello, is my voice clear now?
Yes, Richard, we can continue.
Because I saw a lot of messages that the voice is not clear.
Messages will take care, you can continue.
Okay. So as I was saying, you have to be a lot of curious about the problem, because when you ask a lot of questions, you'll be able to answer small sub-components of the problem, which help you understand what the problem is and what approach you can take for it. And lastly, yes, you need programming knowledge. And here I would like to emphasize a very common mistake that probably a lot of newbie programmers do, that the day they learn to write Hello World in C, Python or Java or any other language, they just go ahead and jump onto AI and ML, as you can see in the meme there. But I would suggest not to do that, as it is very important to have good fundamental knowledge even in programming, like hoops, data structures, and algorithms, as it helps you write cleaner codes and better codes while you're actually creating an AI or ML. Because again, that AI and ML also has a good amount of programming, and you would need to have better understanding about what you're writing before you are able to move forward. And the basic fundamentals of programming help you do that. They help you understand the way you can approach it. Before I go into talk about deep learning, I would like to like us to take a step back uh, and see what actually machine learning is. Let me take this as an example. Let me explain this as an example. I hope all of you have used Amazon or Flipkart once at least. Now you would have thought of buying a product X. Some product X. Let's take it gaming mouse for now. When you go on buying the product X, and before you clear up your cart, you see that the Flipkart or Amazon would actually recommend you to buy a gaming mouse pad. Now, this is not some person sitting there, a customer support sitting there in an office sending this message to you. It's actually a machine learning algorithm which tells the website to show this. Here, what the machine learning algorithm saw is there might have been 100 customers before you, which would have bought the gaming mouse and also this gaming pad. So the algorithm understood that, okay, this is a pattern, that whoever bought this, it helped them to buy this also, and it recommends you for the same. So in a simple terms, machine learning algorithms are those which understand a pattern and do something for which they're not explicitly programmed for. We don't have to tell them, we just have to give them the data, they understand the pattern. You could say machine learnings are like the phrase monkey see, monkey do. They only learn what we teach it. It's again, here take an example of a small kid, 1 or 2 year old kid. They always imitate the actions that we adults do, right? I mean, initially they do not understand much. They do not see. They're not able to interpret the world as much as we do. But at first, they can easily imitate what actions we do, but not even at the first go. We might have to show them 10 times, and then they might start imitating, like making faces or something of that. So machine learning algorithm is like that small baby. It initially does not know what it's supposed to do unless we give it data. When we give it data, we try to correct it so that it gets better predictions next time. So your correct data is very essential, because if you want it to learn about like the recommendation systems about the customers buying a gaming mouse and a pad, and if you give it details about all the plants in the world, then how will it even understand about the relation between the mouse and the pad? The correct data is essential with the right amount of features. Irrelevant features or inaccurate features will not give you any proper learning model at all. And if the data is also not clean, I mean, like if you have a lot of discrepancies, uh, maybe that the data is invalid or something like that in the particular feature, then again the machine learning does not learn very well. If and again, one more thing here is, if you give wrong data, as I mentioned earlier, if you give a wrong data, the machine learning model will be learning wrong stuff only, not the one which you require. Just a sec. Okay, then let's see more examples of machine learning. There is object detection, which we see every day using our cameras, like the face recognition in there, or Google Lens, where we see that, okay, they find out what an object is, where the object is, or is the recommendation systems like Amazon that are the mainly used streaming sites right now during this lockdown, like Netflix, Prime Video, and Hotstar, which again recommend you about shows which you have been watching or you have previously watched. Okay, and then today machine learning is so widely used that it's probably a product. Every product that you use has a concept behind it of machine learning. Probably you are exposed to at least one product of machine learning every single day. Not a day goes by that you wouldn't be in contact with something that uses machine learning in the cloud and gives you an output or a prediction or something like that. Why did we actually talk about machine learning in the last few slides? Now, what was the need? The main topic was deep learning, right? But it was because there is a very significant relationship between deep learning and machine learning. As you can see in the image, deep learning is just a subset of machine learning. Now, normally you would see people loosely using the word artificial intelligence for everything that involves machine learning or deep learning, but there are some differences between it, a very subtle difference actually. Now, you so far understood what machine learning is. Now let's look at what deep learning means. Deep learning, when I say it as a subset of machine learning, it does what machine learning does, but uses a different toolbox like artificial neural networks, which is like our brain, to imitate and learn how we learn. So that is where deep learning differs from machine learning. Now here, the methodology, the approach changes over the normal machine learning algorithms. Now, artificial intelligence is again where it's an intelligent system, as we all know, but it overlaps with machine learning and deep learning, but not everything that you do in deep learning and machine learning is artificial intelligence. Some things are just normal predictive analysis. Probably, again, given the standard example of recommendation system, it is not actually artificial intelligence. It's just a standard pattern which was recognized. It's a correlation between set of features and people, which determine the further correlation between new set of people. Now, again, but what all can deep learning do? So, see, today anything that involves images, text, or maybe audio involves deep learning model in the background, because machine learning models are not so accurate when it comes to those kind of data. They are very weak. Now, deep learning models are very strong in that because they imitate our brain. So it is like our brain, it is learning what the way we learn. So when we give it an image of a cat or a dog, it recognizes that this is a cat, this is a dog. Or Alexa, Siri, you would have seen that they recognize our voice and produces a text. Then there is software like Adobe Scan, Cam Scanner, which recognize a document or text in the document. And lastly, there is self-driving car, which is a very niche technology today, which understands the surrounding of itself and determines actions like how we would when we are driving a car. So apart from these four, there are a lot many, like the chatbots we use or the medical industry uses a lot, and many more. You could find anything on the internet, anything and almost anything that uses images or text uses deep learning in the background. Now, that again, first we have to understand is how many types of machine learning are there. Like every learning is different. How every one of us learn at a different pace or learn using a different method. Each machine learning model learns differently and in a different way. So the mainly two types. There are other types too, but mainly we'll be focusing on two types for a brief introduction to it. That is supervised learning and unsupervised learning. As the title suggests of supervised learning, there is a supervisor and there is some supervision. So here we could say that we are the teacher, and the machine learning model, we give it some data to learn. Now, every time the model predicts something wrong, we correct it. Now, we correct that data and we ask it to do some changes so that the next time it predicts it right. Now, we do not want wrong predictions here. Here we have some X input and we know that there's some Y input for initial data. So now if we give some new data, it should predict some output Y. So this is where we either have an output available or a label, or we can assign it some value for each input. But unsupervised, there is no supervisor. I mean, we cannot supervise it as we do not know what the output Y is. The main reason for using unsupervised is for finding or understanding the underlying insights of the data, or then the relations between the features, so that we can see that okay, this input has these relations between it, or these features determine a lot more about these input points than the other ones. So finding data insights is also a key point in a type of learning. Just give me a minute, I'll be right back. Oh, yeah, sorry. So now let's see more about supervised learning. Now, supervised learning are mainly classified into regression and classification. Let's understand regression with a very standard, uh, very standard example like housing prices. Now, housing prices is like I give you data for the previous 1,000 houses, and I tell you that I give you features like the number of square feet it has, or the number of rooms it has, the kind of furniture it will have, and all. And I also give you the price for it. Now, for the 1,000 houses, you see the price, and then you can determine a relationship that what would actually increase the price or what would decrease the price in a certain way. So now if I give you a new house, 1001th house, which is not in the previous 1000 houses, you will be able to now determine that, okay, with these features of this house, the price range should probably be this, or the price would be this. So here in regression, we divide it by a particular numerical number. So we are predicting a number in regression. Now for classification, let's take the example of socks itself. Here, I give you 100 socks. The socks could be of colors red, green, or blue. Now you are asked to divide them, or divide them into classes. Or rather, if you want, we can take another example of vehicles itself. Now each vehicle, we put them in a single class or type of vehicle, like either it can be a four-wheeler, two-wheeler, or it can be a truck, SUV, sedan, or any other kind of vehicle that we see. So now this is, again, we are classifying it into classes, like each class is a kind of vehicle, and we can also call it as a category. So here we are predicting a category or which class will a certain input belong to. Now, unsupervised learning, there are three types: clustering, association, and dimension reduction. Let's take it all one by one. Now, for clustering, the simplest example I could give is that I put 1,000 people in front of you, and for the sake of example, I give you that what each person, every person, what are the shows that they like. So now, probably the first approach for you would be, you will find the similarities between shows and group those people. We'll probably put all the people who like the genre action into one group, and the adventure in another, or fiction in the other, and those, like, you group them by similarities. So when you divide by similarities, that is what we call clustering. Now, moving on to association, you know what association means. I have given a few examples before. It is like recommendation system would be a pretty good example for it, because it's a sequence. We find an association between two values, between a product X and a product Y. What is the association? So if you see a product X, you might buy a product Y. And like this, you might see that if you buy a product Y, you buy a product Z too. So that is an association, or a relation between the products, and that's where you determine what recommend actually you can do. Lastly, we can see dimension reduction, or in other words, should I say, generalization. Now, generalization, let's take a example of my closet. Let's say my closet has 4 different types of clothing: t-shirts, shirts, jeans, and pants. Now I have 4 different groups here. I would like to group them into 2, probably reduce the dimension from 4 to 2. So there could be a pattern that notices that in the previous, or in the history, that whenever I've worn jeans, I've always worn a t-shirt with it. And whenever I've worn a pant, I've always worn a shirt with it. So now there is a hidden dependency, or there is a relation between the pant and shirts, and t-shirts and jeans. So by using dimension reduction, we find underlying insights of data and which features correlate with each other strongly over than the others. Now, with this, I would want to tell more about deep learning. Now, deep learning has been coming up lately in the past few years, or decade, I could say, in the last decade or so, that machine learning and deep learning has seen more of its applications in the world, and it's been coming up. But has it actually existed with only 10 years ago? You would be surprised to hear that the first artificial intelligence academic establishment was in 1955. So it's been there since 1950s, more than 60 decades. But why did it take so long for it to come up? Like, why just now? Why wasn't it there before? Well, you see, these applications need a lot of data to understand the pattern. The input has to be huge. Like, I would say that for even for classifying a cat or a dog, that for that image also we would probably require 8,000 images of cat and 8,000 images of dog. It wasn't available in 1960. Not even in it probably started after the dot-com burst in the year 2000. So after the dot-com burst, there was the internet just blew off. There's everything everywhere. Now, the very simple example for getting the required data would be, let's take a recent example of Facebook. When it released the hashtag 10 years challenge. So that time, a lot of people, maybe billion people, would have posted the images of 10 years ago and now, how their face changed or how their body changed. So probably Facebook could create a deep learning model which takes in and could understands how the face changes over the year, and probably could actually try to show what a person would like after 10 years for someone it has not never seen. Maybe how a baby would look like after 10 years. So now that kind of data will help deep learning model learn. Having only 10 images or 12 images was not ever enough. You needed thousands, sometimes even millions of data to create a deep learning model very good. No, that is what this very much more like renowned companies like DeepMind, OpenAI, Facebook Artificial Intelligence work on. They have a lot of data, and these companies work so much mainly only on deep learning models because to create better, because they try to perceive the world the way we perceive it. They try to make deep learning models which imitate eyes or maybe ears or some or the same sort. A very interesting fact would be that normally for deep learning models to perform addition, multiplication, understanding how addition and multiplication work has happened before. But last year, Facebook released, or like two people in Facebook released a deep learning model which was able to perform advanced mathematical computations like differentiation and bit more trigonometry ones, and could solve them much faster than the what greatest mathematicians or even the powerful mathematical packages that we had before would take a lot of time into. Now, with this kind of discovery, like creating a model which does this, it opened fields to a lot new places. Like now, solving physics problems or chemistry problems using these models will make it much more easier, much more better, because you just solve very critical problem in mathematics, that is solving trigonometry or differentiation. You do this leads to a lot of subfields where they use this mainly. Now a deep learning model could probably solve that, or it could help a scientist solve that. Now, again, there's another reason why recently only have these models or machine learning algorithms come up. That would be the CPUs and the GPUs. The processing power was very expensive before and very limited. Like it just wasn't enough. There was not enough cores or enough powerful CPUs. You would probably need only supercomputers, which only very few companies or organizations could afford with a lot of funding. But now you can see that CPUs are very fast. I mean, they are faster than I guess the computers 30 years ago. My laptop could be faster than that, 10 times faster than that computer. It is 10 times faster than that computer. I could do a lot of operations. And with CPU, again, the deep learning models do not work very fast because CPU, as we all know, each core still takes, even if it has a lot of cores, each core still takes only one input at a time, or it does only one instruction at a time. But then GPUs came along. Well, it was mainly because of gaming that GPUs came into existence. And because of that, well, the deep learning models can be trained faster because GPU take multiple inputs at the same time. So with GPUs, you could probably train the deep learning model faster. And as you see today, probably years ago, it would take a year to create a new GPU. But now probably in 1 year, they bring out 3 different versions of the same GPU, like RTX 2080 Ti, RTX 2080, and both together, or sometimes anything else, maybe a RTX and a GTX version. So this opens a whole new field that common engineers could actually work on deep learning model without requiring huge amount of resources. In this part, I would also want to answer a few responses which we got in the form where they asked about industry examples. Now, there are a lot of industry examples that I could give. Everything that you use on your phone and uses a deep learning model in the background is an industry example. But I would want you to know that mainly I personally classify industry examples into two types. One where the error is agreeable to certain extent, where another place where error is not at all agreeable. I mean, to make this much more clearer, let's say where a place where error is agreeable would probably be your Google Assistant. Now, if it misheards yourself, like when you say have and it heard has, not a problem. I could probably re-say it again, or I could type it. That's not an issue at all. But a place where error is not agreeable is medical industry, and I would say self-driving car too. So you're in. I said when I talk about self-driving car, let's take a very recent incident happened. Probably I don't know if you know all this. The recently accident happened in Taiwan with a Tesla car. Tesla car rammed into a overturned truck. No, on a highway. So the situation was like this: that the truck overturned, it fell, and the top of the truck, which was white in color, was facing the Tesla car. So now, when the Tesla car was moving towards it, it didn't actually recognize that, okay, that's the top of the truck. Rather, it was probably misclassified as the sky or probably the clouds which are being seen because of the reflection. I mean, we do see clouds, which are sometimes we do see sky that it's completely white. So it was probably misclassified into that, and that's why the car rammed into it. Now, this wasn't the first time that happened. Similar kind of incident happened years ago when the car rammed into a truck which had a shiny coating container. So it again saw the reflection of the container as the sky itself, and it rammed into it again. So now that luckily nothing happened to the passengers. That was because of Tesla's security system. But here you see that small kind of error that it created that could be very small. It would probably be 1 in a million cases. It was still a problem. I mean, you can't just simply tell, okay, our safety systems are really good, and safety systems are really good, and this can be you can ram into any place. You can't just say that. And let's move on from self-driving car to medical analysis. Now, say you create a medical analysis for detecting cancer, and you have 98% accuracy. That is pretty good. That means out of every 100 cases, only 2 of them you would misclassify as wrong, or you would wrongly classify them. But that is still a lot in the medical industry because you are risking lives of 2 people. I mean, even if it sounds the number small, when you take 10,000 patients, that is, say, 2% of 10,000 patients is 200 people. You're risking life of 200 people here. So here, I would say, rather than finding new problems, probably we could make the previous one better. I mean, if someone could find a way to teach a self-driving model that, okay, this is a top, this is a reflection, and this is not a reflection, then that would drastically reduce the small errors which we have. When we reduce that, we make better models, we make better learning. And that is where a lot of industry is focusing on right now. You can always create new models. You can always try to solve new problems with less accuracy. But solving the previous problems with higher accuracy is much more important today, because that would open up the world to a lot of possibilities. Now, with this, I end my session on the fundamentals. So if any of you have any questions, I would be more than happy to answer them. Okay, I see one. Why CNN is mostly used for image task and why not for other tasks? Okay, uh, Akib, CNN is not, we will not be focusing on CNN as part of this webinar, as many of the people here would be like probably just introducing to the like space of deep learning right now. So talking about CNN would be very difficult. What is tell about deep learning and agriculture? Okay, deep learning could be used in agriculture too. I mean, today we would want to know, we would want better weather predictions to know when would be the right time to use like say when would be the right time to grow certain plant in the certain area, what would be the right amount of water to give so that we do not overflood the ground or have give even less amount of water. Now we would want to optimize that situation. You could probably automate all this stuff, and to automate you would need the right amount of solution, like how much should I give. Now rather than asking 10 farmers to intuitively do it, why don't we just have data of the previous, why don't we just use their experience to teach a deep learning model of what to do, what would be the right amount, rather than taking a guess. Okay, deep learning and CNN are same. Now deep learning is CNN is a subset or a concept in deep learning to be used. So for those who don't know what CNN is this type of a neural network application of deep learning in disease detection. So as a lot of people today use deep learning for detecting cancer, recently people have been using deep learning to detect COVID-19 using X-ray scans of lung. So there is a lot. You can use X-ray scans and understand what all you can do with it. Like there's a lot to answer with the disease detection in there. The medical field is open to any and all kind of deep learning models that would help them get much more accurate predictions than before. Like say, you could probably save a lot of lives. I mean, if rather than waiting or what a human eye could not perceive for a cancer until it's in stage 2, when it's very small, very negligible in stage 1, if you predict that in stage 1 itself, you could probably save a life, and that matters a lot today in medical industry. One every life matters a lot. Then are we getting PPT of the session? Yes, you will get PPT of the session. Any particular algorithm for cardiovascular disease detection? Okay. Yeah, in deep learning, actually, there is no right or wrong. Like there's no right way or approach for it. I mean, it's normally, I would say, it's a lot of trial and error here. Like I mean, you could just probably want to try using a certain model X, see how well does it does. If it does not do well, you probably do use another model, and there's a lot of hyper tuning involved. Uh, okay, do not worry about the e-certificate, please. When you give the quiz, you will be able to get it. The recorded, you could for the recorded session, you can go and check it on YouTube live stream. It's given. So what is best recommended programming language for DL? That is, people today mainly use like have been extensively using Python for deep learning, which I'll be showing here in this session. But they also have started using Julia, which was specifically made for this kind, and it's much more faster than Python. That is what they say, but I'm not personally tried Julia, but I've read a lot about it and heard that Julia has been making big, or even Golang, Google's own language. Golang has also been making a big in the industry with its fast computations and all. To use deep learning, GPU is required, or it will work on hyper. GPU, it will work on high performance CPU, but when you use on your own system, GPU is preferred as it would be better. People normally buy RTX or a GTX to perform GPU computations, But before you buy anyone, just check it with the NVIDIA docs, which of these actually support deep learning models. Uh, how deep learning is used in biomedical field. Okay, this is very similar to like how medical field uses it. What is Boltzmann machine? This is out of the scope of this webinar. So if you want answer to this, you could probably contact me or Abhishek. We'll share the email ID at the end of the session. If we change the data and use any of the DL models, will it be considered? I won't talk about research perspective more, as it varies a lot. But if keeping the same model, changing the data, I wouldn't personally think it as a research aspect, because it'll just be data augmentation. If you're actually tackling a new problem, which is using a completely entire new set of data, would be different. Again, auto ML is out of the scope of this webinar, so please contact us later so that we can answer you. Is it possible that if we have low data for deep learning, it is possible to train it, but the predictions could probably be way off. I mean, it could be very wrong. So more data is sometimes very good. At the end of this hands-on session, you'll probably see what I mean by it, when we like how low data would really affect. How do face recognition works? Again, out of the scope of this webinar, please contact us later on, so that we'll be more than happy to help you regarding that. How do you think that deep learning is? Do you think that deep learning is always better than traditional models like this? So in deep learning also, you can implement models for regression and classification. I will also show you during the hands-on session what I mean by that. For now, let's leave that aside. Is deep learning related to IoT? In IoT, you could use deep learning. In IoT, you could use deep learning for a lot of applications. Is it possible to use deep learning for biometric? Okay, this is transformation. There are applications of deep learning in aviation industry. I guess autopilot is also a good example for it. I mean, you could have actually completely autonomous flight. I'm sorry, I just got disconnected. Abhishek, you can start with neural learning.
Okay, I'll just share my screen. Okay, I hope my voice is audible.
It's your audible, Abhishek.
Thank you, Rishabh. It was a wonderful demonstration of how machine learning really is. So now, before I dive deep into neural networks and by definition deep learning, just like to welcome you all and would like to say stay safe from the pandemic that's going on. So without further ado, let's get started.
So, in learning, we have something called a neural network. But what is it really? The neural network is composed of simple blocks called neurons. These neurons are simple building blocks that comprise of the entire network. Now, when you hear the word neurons, you'll automatically recognize the word as something that is in our brains as well, the human brain. Neurons have the ability to transfer information, and this, it is how we think. Deep learning uses the exact same concept. When people thought, okay, how do humans learn and can we mimic that learning? We use the same concept in deep learning, hence the word deep, since it comes from our very own roots of the human brain. But diverging from the biological aspects of it, in practical implementation of deep learning, we shall simply see how a neuron is just a mathematical function. What it does, in very simple terms, is takes inputs, performs a computation on them, performs some computation, multiplication, addition, whatever it may be, and then gives an output. So now we spoke about ML and deep learning, neural networks. Why is it so highly used? How come the world has suddenly seen such a big growth in neural networks? Well, as Rishabh said, neural networks are really good at understanding complex relations. By that definition, I mean that in cases when simple machine learning algorithms cannot accurately predict or determine the outputs we want, we use neural networks since they have more computation power and can easily fake the work of ML algorithms such as decision trees and ensemble methods. One thing to note here is that with the advancement, as Rishabh spoke, of the hardware as well as software, the most important thing that has gained an advantage in the use of neural network is the abundance of data. There's a professor called Andrew Ng of Stanford. He's a very renowned personality and eminent personality in the field of deep learning. He gave a very beautiful annotation that states that if deep learning is a rocket, then the fuel which powers it is all the data. Meaning, the more and more data you feed a neural network, the higher chances there are of it perform near 100% accuracy. It might not be ideal, but we certainly try to achieve 100% accuracy wherever we go. After all we would want is to be a perfect bot or a system that can make the perfect predictions over and over. So, as Rishabh mentioned, that networks can be used everywhere. Well, he was not wrong. It can be used in medical and disease diagnosis. It can be used in chemical formulations. The ecosystem evaluation in this world where global warming has been increasing, the tides have been rising, and the orbits have been shifting. All these phenomena, we can collect data from it and evaluate what changes have been, and therefore predict what changes are to come so that we are better prepared for it. We already know, some of us may already know how deep learning is used for images, classification, generating text, all these chatbots who speak, understanding machine vision, which is essentially using cameras and live feeds to understand vision, just as a normal human would. So now, let's consider what is called a perceptron. Like we said, neurons or perceptrons are simply the building blocks of the inputs and the outputs that are fed into the neural networks. Here we can see the same concept again, that a few inputs that are termed X's are fed into a perceptron or a node with some certain weights assigned to them. We'll come to the weights shortly. But from here, all you need to know is a perceptron is a binary classifier, meaning it takes some inputs and predicts either of two classes. It could be 0 or 1, or it could be yes or no. So now let's come into the structure or the components of a neuron. There's obviously the inputs, which we represent through X. There could be, say, n number of inputs, so we consider n number of inputs. As X is the input, we consider Y to be the representation for the output. Now, the inputs are fed to the node via weights. These are simply the connections between the inputs and the node. They simply understand or tell the node how to take the inputs. It could be representative of a singular value or multiple values, as we'll see. For now, all we need to understand is that inputs are multiplied as a signal of their connection to the network. There's also something called the bias term, which we add in order to improve our efficiency. It's just a constant term that we just arbitrarily throw in order to hope that a well-maintained standard across all inputs are maintained. Finally, there's something called an activation function. This term might seem a little tough to grasp, but in reality, it is very simple. All it does is it takes the output which is being generated and transforms them into a particular range. We'll see how. Here is the actual perceptron structure. There's a constant which is also called the bias. It's simply set as a constant value of 1. You can see the inputs x1 through xn. These are the multiple n inputs that we feed to the node. The inputs are fed as multiplied summations of weights, which are represented by W. Also, since there are n inputs, there obviously by default will be n different weights for each of the input. Simply, they just determine how strong the connection of one input will be as compared to the others. All of these multiplication values will be summed together. They all will be added. They'll all be combined together in order to provide the computation. And finally, the step, which is the activation function, will transform the output. Now, what do I mean by transform? Well, as you may imagine, the summation could be a very big value, which could either be a singular value or it could be a continuous set of values. Now, we want a prediction to be static, or in other terms, we want it to be precise in its term. So what we do is simply we take the output and then we set it within a range. For example, we can say that if the output is positive, then we should let it stay positive. But otherwise, if the output we are receiving is negative, then it should be transformed into 0, since we don't want a negative value as our output. That's just a simple logic. And trust me, activation functions have a lot more depth, but they're really not hard to understand. And for more details, you can always contact us. But for now, let's just keep it as simple as possible and just think of it as a logic to convert the output into values that are readable by human beings. So now, putting all those perceptron nodes together, we build a simple neural network. So here you can see there are different nodes and for different layers. We'll talk about the layers in the next slide. But for now, you can see that there are some input nodes, there are some output nodes. Excuse me. Sorry. Yeah. So we can see there are input nodes, the hidden nodes, which are the intermediate nodes that provide the computation, as we saw earlier. And the output nodes are simply the nodes that take those computations, those values we calculated, and give the output. iterate the same thing in a different manner here so that you really understand what the hidden layers are in specific. Going back, we'll repeat. The input layer is the initial layer that feeds in input for a neural network to take. The hidden layers are the layers in between the outputs and the input layers. Hello? Yeah. The input layers take these inputs and they feed it into the hidden layers. These layers are where all the magic of the neural network happens. They take in the inputs, they provide the computations, and then they send it over to what is the final layer, as the output layer. Now, from the previous this image, you can see there's only one hidden layer here, but that doesn't have to be the case. There can be multiple different hidden layers. Now, why do we stack these hidden layers together? Well, the specialty of neural networks, as I've mentioned, is that they can take in complex data. So the more the complex data, it's obvious that more the number of computations has to be applied in order to gain some sense for the network to understand what it really is. So hence, the more number of layers, essentially, the more insight the neural network can understand from the inputs as more and more computations are being performed. Also in this image, you can see that all the input layers are connected to all the nodes of the first hidden layer. Similarly, each node of the first hidden layer is connected to each of the hidden layer nodes of the second layer. The same can be said for the third layer. This structure, when every node is connected to the next corresponding layer nodes, is called a fully connected neural network and is the most standard neural network structure that we all use in our applications. There are other features and variants of neural networks, but this is the basic vanilla neural network structure that is the base for all that advanced variants of the neural networks. So before we move on to how the neural network really understands, I can pause here if you have any questions to ask about the structure or the hidden layers, if there are any. If there are no doubts, I'll continue. Yeah, I see a question. What is the purpose of the hidden layer? The hidden layer is where all the computations take place. Those are, you can consider those as the nodes that do all the work. The inputs just take the inputs. The output layers just provide the output, probably to the next layer. The hidden layers is where all the multiplication, all the computations, the multiplications, the additions, the summations, all of the work actually that a neural network does is occurring in those hidden layers. That's why we call it hidden, since they are not visible to us. The neural network, if we train it correctly, does all the computations for us, and we don't need to look at it in specific. That's why the hidden layer is so important, because essentially most of the work is done in the hidden layers. I hope the question is how to decide the size of the layers. Well, that depends upon your data. If you have normal or simple data, then maximum 2 layers or even 1 layer is just decent enough to get you approximately a 90% accuracy. But if you have really complex data that you make no sense of when you look at it, then you have to think of it in the same way that a neural network won't understand it either. So the decision of the layers depends upon how complex the data is and how deep you want the neural network to understand. What does convolution? neural networks are a variant of the neural network. If time permits, we'll see what it is at the end. For now, I'll just continue. You told fully connect, other connect network. The reason I mentioned a fully connected network is to just emphasize on how networks are connected. There are no other names given because a fully connected neural network has such emphasis that it was just given the things. So it's just a simple way to explain that topic. It's not nothing very explanatory. It's just that a network is fully connected. I don't think there are any other name given in specific. Okay, I'll just check in the Q&A section. Can you explain what bias is? A bias is just a constant added to the summation. Now, if you've dived into any larger mathematics, just let's say, for example, there are 100 inputs. So if n is 100, so there are 100 inputs. They're all being multiplied by their respective weights. It's not common. Each input has their own set of weights with which it is multiplied and summation is provided. Now you can imagine that it takes a lot of time, or even if it's not taking a lot of time, it is very computationally expensive, meaning that a lot of computations have to be done. So in order to keep the computation standard and make sure it does not go out of the scope of what we are trying to compute, we keep in a constant term. This constant term keeps those computations in check so that we don't dive further more and fall over those computations. How to use neural network in biofundamentals? I'll assume by biofundamentals, you're speaking about in terms of biology and biochemical, geological fields. There are different ways in which you can use. Essentially, any field that works with data is a place where neural network can find its home. All neural network does is make sense of data, and that's the simplest way you can think about it. So in any way, biology, you have a lot of data, and there are different ways in which neural networks can work. How this hidden layer works in the background. We'll dive more into how the computations are done. So worry not about that. We'll see, surely. How processing is done if multiple hidden layers are used? Where is the activation function? Okay. The processing is done in each of the hidden layer nodes. If there is one hidden layer and there are suppose 4 nodes, then each of the 4 nodes computes its own value of the computation with respect to the inputs it is getting from the previous layers. And the activation function is applied on the node itself. In the perceptron, it is just added as a logic. It's just applied just before the output so that the output is transformed, and it's not applied before that in order to not disturb the computations in its normal order. How many hidden layers can be used for images regarding cancer detection? Well, it depends. Cancer, if you are having data that has MRI images, then you'll have to just experiment with it. And that's a great way of understanding how hidden layers impact neural networks. You can start off with 3 and you'll see that it's not giving you as much accuracy as you like. But maybe if you add in 2 more with several tuning of parameters, as we'll see later, and how to optimize the error, as we'll again see later, you'll understand how these hidden layers work. As for that, you'll just have to give it a try, I guess, as an experiment, if you will. Is it better to increase hidden layer to get high performance? This is actually a really good question, and it's being discussed by professionals all over the world right now, because we, like I mentioned, hidden layers improve the complexity understanding of the data. So it makes sense to say, right, that you just throw in a more 4-5 hidden layers and then you will see high performance. Unfortunately, that is not always the case. It may be for, you know, the simple data that we all might have access through to the internet, sure. Again, a better way to understand that would be just to give it a shot. But it also is that always increasing hidden layers may provide more and more complexity up to the point where it is not actually needed. And so it becomes really tough to debug that as well, in case the neural network doesn't perform the way we want it to. So it's not always the case. I'd say generally, yes, but in generic terms, I'd say it depends. How many hidden layers can be used between input-output layer? The answer is as many as you want. It just depends on the exact number of layers that can get you the desired prediction accuracy you want. How do you determine the number of layers? I think I hope I have answered the questions of hidden layers. It's just a trial and error way where, as we'll see, different types of neural network structures work for different specific problems, and there's no one specific solution to all. So it just depends on the question or the problem you're trying to solve. How to fix weight for the hidden layers? That too. We'll be diving more into how to fix the weights and all that happens in the further steps. But for now, I'll just say that you can set it randomly as you want. You can even set all the weights to 0, and we'll see how we adjust the weights as we go further. How many should be the number of hidden layer neurons? Well, similar to how many layers there are, you also depend, the number of nodes depends on how many computations you want it to do. So just as it depends how many layers there will be, the same can be said for how many number of nodes will be in the individual layer. That specifically is up to the question or the problem you're trying to solve. Sequential and models and functional models. This again, we won't be tackling much. This is just the introduction, and higher advanced topics will probably be overwhelming for the ones who've just come in with minimal prior information or knowledge about this. So I'm sure we can help you out if you reach out to us. And for those asking, our emails will be given at the end, mine and Rishabh's as well. How do we choose the activation function? Can we choose different activation functions for different layers? Yeah, this is also a really good question. Activation functions differ. So like I mentioned an example as the 0 for negative and 1 for positive, there also can be a logic applied where you just transform all the values between the ranges of -1 and 1, or even 0 and 1. So there, it depends on what you're trying to accomplish. If you just predict between two classes, either yes or no, or maybe 1 or 0, or yes or no, then you can choose the activation function that I 0. For example, if you're trying to predict the prices of houses, trucks, or sorry, vehicles, or anything, stock market predictions, whatever those may be, you can convert those into a range between 0 and 1, so that you have within a range the approximate values of the outputs you want. Also, for different layers, we can choose different activations. It all again depends on what problem we're trying to tackle. For example, different activation functions are required for in problems where we are dealing with images that we do not know what to do with. So we try to take in as many features as possible. So in that case, we use different activation for different layers. So yes, in essence, we can choose different activation functions. However, we must be careful that the activation functions do not change the essence of the computations that occur, since it will disrupt the entire neural network and the product or the output will be abysmal. There are a few more questions in the chat. May I see? Okay. Yeah. Can we have different activations? Yeah. Okay. So if there are, I hope I have answered a few questions that you may have on hidden layers. There were some really good questions, and I am really enjoying the way this interaction is going, and I hope the same interaction stays, because now we'll go into how to actually fix those weights and how to understand what the neural network actually does beneath the surface of what we actually see. So without further ado, let's get rid. So, okay, before that, I have a few, another question. Is the size of for now, we'll just say that data is everything. It depends, again, how well the data is fed into the network, what is the size, and if we have set the network in a proper order, or need to resize the image in order for the neural network to actually take it in as the input. Okay, so I'll move further. So now in a neural network, as we say, inputs come in, outputs go out, and it happens for the network's essence over and over again. So now we start with the training phase, which is essentially that we feed in information to the network within the input networks. The hidden layers are then triggered. They take those inputs along with the way as we established over and over again, since it's the most fundamental operation that occurs in a neural network. With input fed to the hidden layers, the same computation occurs over and over with different forms until we get an output. So now, when we have received an output, how exactly do we figure out if the prediction is correct or not? Well, that's just simple. In most cases, we already have the image labels, which is the actual value. Or I just gave an example of image. It could be any type of data, numerical, textual, categorical, whatever it is. So we often have the actual values of the outputs we are trying to predict. We just cross-check those results. In essence, we see how off the neural network was in prediction by telling it that the actual value was this, and you predicted that. And this and that could be as far as off as the two poles of the earth, or it could be basically the same. So now we'll see what error really is. So now the error was basically the difference between the predicted value and the actual value that we receive from the neural network. The actual values is that we already have it. Just a second. Yeah, sorry about that. So now, since the error is calculated based on the difference between what we received and what we actually want to receive, the problem becomes how to optimize it, how to make the neural network understand the difference and correct itself. The problem here is, since hidden layers are hidden from us, so we cannot explicitly tell the neural network to change its weights in a certain position manually. That is a lot of time and effort taken by us, as well as the fact that neural networks are trained to do the work that humans find time consuming and intimidating. If we just do that ourselves, that would be to train a neural network to do the predictions for us. So the problem of adjusting the error and therefore adjusting the weights so that the inputs are understood properly, it becomes a problem of optimizing the error. Hence, we come into the topic of gradient descent. Now, this is a important topic to understand, and I try to go as slow and as in depth as possible in order to explain it to you. Note, gradient descent has a lot of intricacies, and I'll try to explain it to you in as simpler way as possible, so that when you dive more on your own into gradient descent and you see all those big terms and big formulations, you'll at least be able to understand the importance of it, at least, as well as maybe how it actually works. So let's get down into the gradient descent, which is basically the most commonly utilized optimization technique in machine learning and deep learning, which is implemented in the process of training the neural network. So what is gradient descent? We'll break down those two words into separate entities, and we'll try to tackle those when we know the base understanding of those topics. So what is a gradient? For now, ignoring all the mathematical terms, we just simply can say that it is with respect to change in error, the change in weight. Therefore, what we're trying to do is when we change the error, we try to change the weights. The change in weights will ultimately reduce the error or maybe even increase, which we do not want. But what we want to do is change the weights in such a manner that the error is reduced. The gradient is a term that simply signifies that. As you can see from the quote, a gradient simply measures how much the output of a function of the problem you're trying to solve. That changes when you change the inputs, and by definition, its weights a little bit. For those who are well understood with derivatives, you'll be able to realize that a gradient can also be depicted as a derivative of the cost function. Now, the cost function here is nothing but the error. It's just a high-level term used to determine the error so that we can represent the error as a function or a problem that we're trying to solve. It's nothing much and it's nothing really complicated. It's just deeper words used in the field of deep learning. You must be thinking, why such an arbitrary image? Well, in order to understand gradient descent, let me give you a well-known instance on an example. Suppose you are on top of a cliff or a mountain and you want to reach the bottommost point. Now, if you do not know where the bottommost point is, what you'd intuitively do is take small steps, evaluate your position, and then take those steps again until you reach the lowest point. Gradient descent is just simply doing exactly that. Suppose, for example, the furthermost, so here you can see this outermost circle. For example, let it be the point of the highest cliff, and x0 is the point you're actually at. So now if you want to reach this smallest circle, you'll try to take smaller steps in order to achieve the position you want to go at. So now simply you take a step from x0 or 0 to x1, where you stand and evaluate at what direction and what big a step you need to take. So you think, okay, you now need to take smaller step. So you take a smaller step than compared to the one you took before. Again, you see that you're not quite at the position you want to be at. So you take another smaller step, and then you repeat the same process again and again, taking very small steps in order to get to this point. So now, why did we talk about getting to a lowest point? Well, the optimization technique tries to bring us to the lowest point which signifies the lowest error. In simple words, we can say is we achieve a good prediction accuracy when our error is the lowest. It makes sense in the way, if you look at it in this way, as if the error is as low as possible, then you can also see that your prediction is getting really well as well, really good as well. So now we spoke about how to take different steps, right? So now you can understand from gradient the following, and I'll try to explain it as simply as I can, that the gradient is a vector. And what do you mean by vector? In physics, it simply says that it is something that has both direction and magnitude. And we need that specifically in order to understand where we're trying to go. Since we're trying to get to the real bottom part of the slope that we're trying to achieve at, we not only have to see in which direction do we want to go in, but also in what dimension or in what magnitude do we want to take our steps in. Basically stating that we don't want to take large steps so that we fall off, or take very small steps so that it takes a lot of time for us to reach. Hence comes in the learning rate. The gradient descent algorithm simply multiplies the gradient that we evaluate for us to take the steps in by a very arbitrary but set learning rate in order to get to the next point. When we get to the next point, we again calculate the gradient, we check the learning rate, and we then take the steps accordingly. However, here is where things get a little tricky, because having larger learning rates than required or even smaller can have really big problems that may result to the same thing. When big learning rate is taken, we might almost never come to the minimum that we want to achieve. As you can see here, with big learning rates, if we take really larger steps, the function can overshoot, which means that we might just keep on going higher and higher instead of lower. Meanwhile, if we take small learning rates, it'll come down eventually, but that eventually will be a really big amount of time. And we do not have that much of time in order to train a model. We wouldn't like a model to be training for 2 or 3 days continuously. And that is the problem that small learning rates will definitely create for us. So now, again, reiterating my point, the gradient descent needs to get to the local optimum, which is the minimum where the error is not increasing and has decreased to an acceptable point. This is where also that we get our prediction accuracy to be really well as well. Here is the point we wish to achieve our neural networks to be at. Again, as you may read here, learning rate is really important since it sets the tone of the learning process of the neural networks. Basically, it just simply symbolizes how fast or how slow a neural network will learn based on the given inputs and the way we change the output. So now we've spoken about what the error is and what we've tried to achieve with the difference in error. So now let's come down to the really tricky part of how exactly do we trigger the error in order to alter the weights in order again to change the way a neural network learns. Here's how the algorithm works. So like I mentioned, instead of climbing up a hill, we think of going down because our goal through gradient descent is to minimize the function. What is the function? Simply the cost function, which is nothing again, but just the error represented as a problem that we want to solve. So now we've spoken about the ways to do it. let's get down into mathematically how to update the weights. I was asked initially how to set the weights, and here is how we do. Initially, since we don't really know what to set the weights, we'll just set it randomly, arbitrarily, whatever you want, as long as it's acceptable or not too far off. We shouldn't be using large 5-digit numbers as well. We'll just try to keep it either simply 0 for everything, or we'll just set it randomly 0.6, 0.3, 1, 1.2, smaller values, but randomly. The step 2 is calculation of the error, which is simply the multiplication of all the inputs with the weights through the hidden layers, again passing through from left to right, from the inputs to through the hidden layers and towards the outputs. When we get the prediction, we calculate the error simply as the difference between the predicted value that the neural network gave us from the actual value that we already know. When we have this error, we represent it again as a function or problem. Now, for those who have understood the basics of differentiation, will find this easy, but I'll try to keep it as remotely down as possible, is that we differentiate this error that we receive with respect to the weights and the bias respectively for each node. Now, this bias term is just added so that as we go through the weights, we'll try to just shift the bias as well, as you can see. And now we'll try to just focus on the weights, since those are the more important issues. So once we've calculated the differentiation of E, the error, with respect to W, excuse me. Hello, I'm muted. Just a second. Yeah, sorry about that. So when we calculate this error, we represent it as dW, which is the term for the partial derivative of E with respect to the weights W. And as simply, we update the parameters of each node as follows. The new weight will be the original weight subtracted by the multiplication value of the learning rate and the partial derivative we just received. This will cause the new weights for us to be obtained. This is done the same for the learning rate as well, with the bias as well. We do this again with the same new updated values of the weights and bias that we receive, and we keep on doing this over and over from step 2. And we repeat this entire process until the error obtained is as low as possible. So now, I'll try to take in some questions, since I know this might have been really over the head and a lot of math, but please be assured this is a really important topic, and I'll try my best to clear each and every doubt as possible. So there are a few questions that I'll try to solve. First in the chat, learning rate. What does learning rate mean? Okay, as I mentioned, learning rate is simply a value of the step that we want to take. If we set a learning rate of say 0.5, then 0.5 is the step value. It is how far we want to leap It is how big a step we want to take. That is simply the learning rate. It has a different bunch of annotations, but the most simply way to put it is the rate at which a neural network learns. Suppose there are two local minimum optimum and our model has reached one of the local optimum, but there is also a global optimum. What happens next? Yeah. The thing here is, just a second. Yeah. Sorry about that. Yeah. So the two local there could be multiple local optimum, and there might be different issues as to how we get to the global optimum, which is what we're trying to achieve. Now, the different local optimums are different for the nodes, and what we try to do is essentially figure out how to move about to get to the global optimum. This I hope Rishabh will explain when we get to the process of backpropagation. But for now, let's just try to keep it as simple as possible and just assume that there's a simple optimum, which is the local is the global, and we just work from there. How to gradient descent optimize the errors. This is the slide. This just details all the steps of the way the changes occur from the errors that translate into the changes that we must implement on the hidden layers and their connections. I hope that answers it. Difference between learning rate and bias. Bias is simply a constant added along with the inputs to keep the computations as standard as possible within a specified format, whereas learning rate on a whole is also a common rate that just signifies how fast a neural network will learn through the process of its training. Before that, I'll also take a few questions that have come in from the YouTube live. For a two-class problem, output unit is only one. If n is the number of inputs, do you mean to say hidden units must be between 1 and n? Well, it could be. The number of hidden units, as I've mentioned before, depends entirely upon the problem we're trying to solve. For this case, it's not specifically so. Another question is, how will I decide the nodes of the hidden layers? Well, as I've mentioned, the nodes in the hidden layers depend upon the way we tackle the problem. If it's a complex problem, we need to add more layers and therefore more nodes. It again all depends on the complexity of the given problem. I'm sorry if my voice is not entirely correct. I seem to be having some network issues. Please bear with me. Thank you. Okay. Do you have any control over the hidden layers? Yes, absolutely. While we leave the hidden layers to perform the computations of their own, ultimately it is our job to optimize the weights at which they provide the computations. So while they perform the calculations on their own, we do have almost all access and the control that we have that we can exercise over hidden layers. Will a neural network with several layers constitute deep learning environment, or is deep learning more? Well, the thing here is deep learning is a field and neural network is a structure that we implement in deep learning to avoid complex situations being left unsolved. We try to use neural networks within the field, the domain of deep learning, so as to clearly understand that complex problems can be solved as we move on further in this world. So I hope that answers it, as I am sure there are a few who might be confused between deep learning and neural networks. It is not the same. Deep learning is the field where neural networks are implemented. Hope that clears it up. Yeah. Please explain the definition of gradient descent. Okay. See, the gradient descent is an optimization algorithm. If you want me to get into the hard and fast definition, it is simply that it optimizes the error and then it alters the weights in order to reduce the error as much as possible. Now, I didn't want to give this definition because it's a little high level and I'm trying to keep it as simple as possible. How does the algorithm calculate the partial derivative of the weights and bias? I have an example to show you after this slide, and I hope I will be able to clear that up. Is Adam optimization a good option always? Now, to answer that, I will have to explain what Adam optimization is, again, which is outside right now, at least the scope of the syllabus. To your answer, I'll say, again, not always, but generally, when you're trying to predict, it is good, yes. Is there any relation between the number of layers and the nodes in each layer? Are there depends on the inputs? Yes, there are relations. Basically, the nodes, the weights of the nodes are the connections between each other nodes. So yes, the nodes are dependent. They have relations between each other in different layers. On inputs, not necessarily so. Well, you can say in a certain way that the layers are dependent upon the input layers, not just the inputs, but the way the hidden layers receive the input through the hidden layer. How to use neural network in AI? Well, this question seems a little ambiguous. So I'll just try to explain that AI is just a broader domain, and the use of neural networks is, as I hope you'll be able to see when Rishabh shows you the programs. And we have already mentioned that we'll dive deep into that. So I'll just go into an example here. Yeah, here's a small example, and before 11, I'd try to explain this as well as take in a few more questions if you have. Let's say that we have just these two nodes, right? We'll just try to keep it as simple as possible for the sake of calculations and for all of us trying to understand. Let's say that the input is 0.6 and the weight initially is 0.4. And 0.8 highlighted in yellow is the actual value that we want this very small network of two nodes to predict. So now we see in iteration 1 that the error, as we count, is just the difference between the prediction and the actual squared. This is a way of calculating error by mean squared, but let's just, for simplicity's sake, keep this as a standard for just understanding how the weights are changed. So here we see that the error gets calculated as 0.3136, which is 0.6 into 0.4, subtracted via 0.8 and then whole squared. So now when we calculate the difference, the partial derivative dw, now there are different ways to do it. And just for, again, simplicity's sake, I've just shown the difference. All I want to do here is not show you the partial differentiation or the partial derivative, but my main motto here is to explain to you how the weight gets updated. So now, when the partial derivative with respect to weight was calculated, we take from the previous formula that we've seen, is that the new weight is the old weight subtracted from the learning rate into the partial derivative. So now when we have received the new weight, we use that as the same input as 0.6, but our new weight now is 0.428 as we calculated here. We do the same process over again, and now we see that the error has significantly reduced by just a change in weight. And now again, we calculate the same process all over again with the new weight, as you can see here, and we can perform another computation and many more if we want our error to go down over and over again. So I hope that this was not just how to calculate, it was not about the math behind it. I hope it explained to you how the change in weight reflected the change in error, which is what the gradient descent algorithm is used for. So I have another question here. Gradient descent is one of the many optimization algorithms. It usually is more efficient than a grid search, but doesn't always follow the line. So do you really have all the gradients? If not, then how do you calculate gradient descent? And if so, why not just pick one where gradient descent is 0? Okay, for the first part of the question, we don't have the gradients, right? We calculate it as we go further and further into it. We wouldn't know. That is why we implement the hidden layers of the neural network to perform all those computations for us. And so if you ask that why not just pick one where the gradient is 0, well, that's because it's practically impossible to do. There will be data where things are more complex that you may imagine. Having gradient as 0 is an ideal thing that is not practical to be having. And since we've mentioned that neural networks work really, really well with complex data, this complex data is almost certainly not going to have parameters that will leave our gradient to 0 so that we are already optimized within the first iteration of the training process. I hope that answers the question that person had. Is there a question? Any prerequisite for practical like software? Well, the prerequisite, as we've mentioned, is basics of Python programming. And in order to show you that, we'll not dive deep into the software requirements, and we'll just show you within just simple matrices and multiplication in the code, as Vrishab will do, that for now you don't need any prerequisite softwares than to just have a system where you can run Python coding. So a few questions. Can we assume any value as learning rate? Not exactly. You may, it is often considered to take something as 0.001 or 0.005 as a good learning rate. Taking any learning rate randomly would be a really problematic thing, since as we've discussed, the problems of having larger learning rate having as many issues as having a smaller learning rate as well. Okay, another question. How does the increased number of hidden layers reduce the error? Then what is the iteration for? Well, the thing is, as we'll see, how multiple layers reduce, alter the weights in order to reduce the error. That I hope will be answered in the few slides that Vrishab is about to take after a short break right now, after I've answered this question. The iterations for, again, you'll see how it all implements. For now, if you're just curious, I hope your curiosity will be satisfied by the upcoming topic that Vrishab is about to take, which is an extremely important aspect of deep learning. And I hope your answer gets solved there. So yeah, I'm so sorry. It was determined to give you all a short break at 11, and so it's 11 now. I'll just try to end it here if there are no other questions. Yeah, so if there, let's take a short break here now. I hope everyone is doing well with all the information that we've imparted now. We'll just stop this screen share for now. Okay, everyone. This is Abhishek here again. Hope everyone's back. And before we continue, there are a lot of questions that have come in. So let's address those before we move on. Here's a question. Obviously, GD is naive and slower than SGD. Yeah, basically, yes. We don't, again, go much into detail in this seminar as to what those terms correlate with each other. But to answer your question, yes, but there are ways where simplicity works best. There's another question. I'm sorry, I accidentally dismissed this question. Please forgive me. The question is, bias was not added in this question, right? Why? My main objective again was to show you how the change in weights affect the change in error. I did not add the bias term calculation here simply because it was a very minimal change, and I just wanted to show you the basics. If you want to check it out, I could just tell you that the weight, the bias value would change from, if it was 1 to maybe 0.5, 0.956 or something. It's a very minimal thing, and generally bias term is just for keeping the computations constant. And here, in this case especially, it wouldn't have made that much of a difference. So I choose to keep it as simple as possible and show that the gradient descent works with weights and the error, and exclusively that, so that it's as clear as possible to each of the attendee here, regardless of how much information or knowledge they have in this field. So that was my point. I hope that answered it. What is underfitting and overfitting in neural networks? Okay, this is a really good topic that we can take up. Underfitting is when the neural network is, in simple terms, not well trained at all. It is underfitting the data points from the input, and it cannot accurately make proper predictions. So the accuracy would be something about 30%, 20%, very low. This is when the neural networks fail to understand the relationships between the inputs and how they map to the outputs. This is what underfitting is. Overfitting is, as the term suggests, quite the opposite, where instead of generalizing the term in order to predict with new data that it has not seen, the neural network ends up learning the entire input. By that, I mean it essentially, in human words, mugs up the data. It does not learn. It takes in everything. So while it may do good on the data it has seen, maybe like an accuracy of 90%, it will not do well on data it has not seen yet. It could be like 20% or 30% of things. So here's what, excuse me, just a second. Yeah, so, sorry about that. So in simple terms, I'll try not to go much into detail about what causes underfitting and overfitting. Just that these terms relate to when the neural network is not properly trained. In underfitting, it does not learn well in the first place. And in overfitting, it, in specific terms, it also understands the wrong instances of a data that it should not learn. In terms, it won't be as good when it needs to understand data it has not yet seen. Another question is performance in terms of, okay, performance in terms of accuracy. When you speak about performance of a neural network, it's almost always the percentage of how many right predictions it can give. And you always aim for more than 85% above accuracy. That is your a good performance. What is the basic difference between this, which is more applicable in the neural network? I'm not sure I understand this question. Whoever's whoever has this query, could you please reiterate in what sense you mean difference? What different between what are you asking the difference between? Again, another question is, how do I stop data overfitting from a neural network? Again, we won't go into much detail about overfitting and underfitting because these relate to the tuning and optimization of the parameters, and that goes a little more advanced. But to stop overfitting, to answer your question, I'll just say to look at your input layers and your the learning rate, as well as the way in which, if you have augmented your data. Do we use dropout technique in deep learning model? Yes, we do. Often we do, but dropout is again something we won't touch upon in this seminar. So we just try to keep it as simple as possible. Please clear those things by examples. Again, I'm not sure which question, which aspect or which topic would you want me to take up. If you could just let me know, I will be more than happy to take up your request. I'll just wait for another few minutes if you guys have any other more questions or any other queries that you may want me to take up. Explain any deep learning tech with implementation. Well, if time permits, we'll try to show you. Me and Rishabh have been working on quite a few things, as we may not be able to show you exactly how it works and what's happening. If time permits, we'll try to show you what we've done on our own so far, with hopefully the output, so that it drives home the true essence of how to get into this and how it actually works. Hopefully we can get into that. Will BERT be discussed here? No. For as much as I love to dive into natural language processing and its specific terms, unfortunately, we won't be discussing transformer models here. This is because we're just keeping the intro. And if we try to go into the specific domains of maybe natural language processing or machine vision or generating other arts, it would become too overwhelming for all the people who are new to this domain and are trying to just grasp at the very basics. But I will be happy to discuss it further with you. You can just email me, and also my email and Vrishabh's as well will be given to you at the end of this meeting. Please do contact us. Feel free. We are always here. Any website. Well, actually, let me just show you something that I really love to do. This is a TensorFlow neural network playground. Now, we won't go into TensorFlow, but I hope the screen share is visible. Please let me know if it's not. Otherwise, I'll just continue. Here, you can just tinker with all the different data sets. Is it not visible, the screen? Just a second. Is it now visible? Could someone please let me know? Yeah, so you can see this website, right? The TensorFlow playground. Okay, Sankaran, I have seen your question and I'll get back to you on that. Just let me be with it. So here you can see this is a really good way of understanding how neural network works. You can try all these different activations. You can try regression classification problems. You can take different kinds of data. And you can even add in additional layers to see how many layers, how many neurons, and how it works. And you can see the different inputs, the different outputs, the way in which you want to do. It is a really good tool, and I often use to get a deeper insight as to how these hidden layers have these connections. Because honestly, visualizing for yourself would be a really good way to understand how to go about it rather than me explaining to you. So here you can just tinker with it. You can just play with it. You can see how this data, when I start to train it, start slowly training here. You can see the weights moving in. You can see, you can implement so much with this. It's a very good tool, and you can see how the training is occurring based on these different points. And I'd recommend you all to try this out. It really gives a good level of understanding of neural networks and a good way of visualizing or representing in your head how it actually would work. You can see all these different layers, how they are working through all these connections, right? So just let me sorry about that. Okay. How to use this with IoT? Well, honestly, I have not dived much into the collaboration of deep learning with IoT systems, but there are different ways. For example, if you can use a machine learning system to predict the growth of plants using a smart garden technology with IoT, or you can use predicting if an office is bound to smoke or not based on faulty equipment, based on the equipment that are connected to IoT. There are a few ways, and the possibilities are endless in this growing world. And maybe you can come up with something unique as well. Can neural networks be used in app development? Well, sure. Let me give you an example Rishabh has already mentioned. You scanner, right? It is an application that takes in images and then scans it. But also there are other applications such as Google Lens that can take in images and then take in the data present in it, for example text, and convert it into actual textual format. So that is all done by neural networks. So of course neural networks are surely really helpful in app development. Sorry if my audio is lacking. Okay. Just a second, please. Is my voice clear now? I hope it is clear now. Okay, there was one question that I moved over. It was by Sankaran. While executing Seaborn from 64-bit to 32-bit, it displays cannot cast array from Dept. Well, you'll have to understand the concept of programming for this. Uh, for now, I'll just say that is out of the scope of exactly what I want to tell you, since Seaborn would require me to go into that package of visualization much in depth. And if the same problem persists, just try to look up the documentation for Seaborn. If the problem still persists, you can email me personally, and I'm sure we can find a solution for that. The hands-on session will start after an important topic, like I've mentioned. Vrishabh will be handling that. I highly suggest you guys to just understand that, since even if you just take that topic with yourselves from this seminar, it would be a huge success for us in able to drive home the importance of this domain and what uses where. There was a question I missed, unfortunately. Thank you for bringing that to my attention. Hypertuning means. Hypertuning of parameters basically means to alter or to change different parameters or aspects of the neural network. You have all understood now that a neural network consists of a lot of different components, all small components. While they may not work well together, in combination with all of its components, they work together in brilliant harmony. So hypertuning is just trying to adjust those values, those weights, those layers, somewhere or the other, just to get a good accuracy level that we want. That is what we mean by hypertuning. And training the error is one step. The next step is the hypertuning, where we, after the training, we determine what went wrong or right. And then we try to generalize a way of the neural network to, tune it as per its according to our limits. Yes, for those asking, we will be having a hands-on session again. Rishabh will be taking that. I'm sorry. There is. So if there are no more questions for now, I'm glad that people have had such brilliant responses. We really appreciate all the support that you guys have been giving us. And for now, let's move on to the, as I say, the most important topic of this seminar. And for that, I'll hand it over to Rishabh. Over and out. Rishabh, all yours.
Thank you, Abhishek. Am I audible? Just let me make that clear.
Yes, you're audible.
Okay. Thank you, Abhishek, for like giving such a good explanation on what a gradient is, how gradient descent actually works, and what is error. And I remember one question had to be answered by me here was about the local optimum and global optimum. I will explain that while I explain the last theoretical concept of this webinar. After that, we are all for programming, and please keep your text editors or notebooks or IDs, whichever you like. I personally like Sublime, so you can keep anything you like ready, and we'll get to it after understanding backpropagation. Let me just share the screen. Okay, this. So backpropagation. So recently, like a while ago, Abhishek mentioned about how we calculate gradient and we fix the weight for just two nodes. I mean, one input layer and one output layer. But in real life, you'll probably very rarely be, I guess it's next to zero, that you'll be using one input layer and one output layer. You'll have a huge hidden layers, the stacking of hidden layers, which you saw earlier. And many models have up to like 100 or 150 layers that there are. So here we have to fix all the weights. But how do we do such a huge task? I mean, it does not seem simple that fixing all the weights as it sounds. So, but the concept would be is very clear. So it's like when you saw the feed forward in hidden layers is like the input layers give an output to each hidden nodes, and each hidden nodes go and output to the next layers. But here it's the same thing, but from right to left. The error which is calculated at the output layer is propagated to the previous layer, which again which calculates its own error and propagates to the previous one. So, but why is this important? I mean, why is backpropagation termed as the one of the most fundamental concepts? I mean, the way backpropagation works is it fine tunes each weight so well that, and here I'll be answering the part of the local optimum and global optimum. So please listen to it. The backpropagation works and fine tuned in such a way that it does not, the weights do not stick at one point. They do keep moving on. It's not a saddle at one place and like, okay, this is where I think the optimal point is, I won't move from here. It would probably, when the next iteration starts, it will probably go back to the top of the canyon and then come down. So at the end, by the number of epochs, the number of times you train the neural network, by the number of images that you give, it could eventually find out where the global optimum is. And it is very, very rare that a neural network would be stuck at local optimum. I mean, eventually, when you have a lot of training data, the probability of reaching the global optimum is higher than reaching the local optimum. So that is why backpropagation is deemed as the most fundamental concept. And I am going to show how it's done. It's going to be very simple. It's going to be as simple as just doing multiplications, additions, and subtractions. So do not worry about a small math here. And just let's move on with the final concept. So first you have to understand how backpropagation works for higher, like hidden layers and all. So it's simple. Like if you take the weights of between some n and n plus 1 layer, let's say between the input layer and hidden layer. So the weights between those layers are fine-tuned by multiplying, by subtracting those weights with the product of alpha, which is the learning rate, into the delta, that is the gradient of n plus 1th layer. That for this example would be the hidden layer. So if I check the weights between input and hidden layer, it would be W01 minus whatever alpha learning rate which I have into gradient of W of 1, layer of 1. That would be the hidden layer. Now to get a more clear understanding, let's see an example. So here I'm just taking a very small example with only one node, no bias, to make it understandable how it works. So 1.0 into 0.3 would return the value 0.3. Now that multiplied by 0.5 is 0.15. That is a predicted value. So our neural network predicted that, okay, 0.15 is the answer. I'd just like to make clear that 0.3 and 0.5 are just some arbitrary weights which I took. They do not have any sense as much. I mean, they're just simply random values which I took. Now, the neural network, what I wanted it to predict was 0.3. So first, I will calculate the error, which I am using the formula is predicted minus actual per square. Let me just take 1 second. Yeah. So wait, where is my cursor? So I'm just going to take predicted minus actual, the whole square, which should be 0.15 minus 0.3 whole square, 0.0225. The error seems small because our difference wasn't that huge. Normally, when you do for a big models, the difference would be much higher. The layer output, that gradient for layer output is just the difference between the weight, the actual minus the predicted minus actual, which is minus 0.15. That means my previous calculation, which happened between hidden and output layer, was only off by 0.15, and I had to move in that direction. At layer hidden, that for this hidden layer also we'll have to calculate. But here the question arises is, how do we know which layer has to be scrutinized more for producing more output? As you know that weights matter a lot in determining how much they contribute to the output. So in the same way, I would want to know which node which has a higher weight would have contributed more to the error. Uh, so I multiply the weight between the hidden layer and the output layer, which is 0.5, into the error which was caused by it, that is minus 0.15. So let's say if I had another hidden layer with weight of 0.1, so it would be 0.1 into minus 0.15. So minus 0.75. So we have calculated the delta for all the layers. So now we move on to the actual back propagation. We now fine tune the weights. So we just go back to the earlier formula which we had. So for the hidden layer and the output layer, we got to know that the delta layer output, which is the n+1th layer, is minus 0.15. For the sake of example, I am taking the learning rate as 0.1, and my previous weight was 0.5. So when I subtract 0.5 minus 0.1 into minus 0.15, I am going to get output as 0.65. So this is going to be my new weight between hidden and output, hidden layer and output layer. And for the same, we do it for input and hidden layer. So the previous weight was 0.3 minus the learning rate stays the same into the gradient of layer n+1, that is hidden layer here. So minus 0.15, which we calculated in the previous line, which is equal to 1.05. So you must have seen, no, this would seem very different than the way we are calculating gradient from the formula Abhishek showed, that we had to do partial derivative and all. I remember someone even asking a question, how does the system compute partial derivative? Actually, it does not. It does not actually do the differentiation which we do. There is a different way of actually tackling the gradient method. That is what this is. We backpropagate the error based on the weights. That's how we know which weights to scrutinize more. This is one of the simplest way to explain, and this is what we see each like framework that we have or each model that we do, they use. They calculate the gradient for each layer based on its next layer and the weight it contributed, so that each hidden node has a different weight, and then we change the weights according to that. So this is why it's like this. Now if I run this iteration again, let's say this is the where they reached a local optima. When I run the iteration again, the weights are going to change, the error is going to be different, the gradient is going to be different. So it will not start at the local optimum again, it would probably start from somewhere else. It would eventually reach down to the global optimum which is there. So that is why backpropagation, the neural network learning and backpropagation has been so with gradient descent has been so highly fundamental requirement for a neural network to learn properly. So here we finish all the theory concepts. I will be answering few questions regarding the values, I guess. After that, we'll move on to the programming. Okay, so how 0.025 came? Okay, so you see the actual value of the predicted value, which was 0.15 from the calculations, minus 0.3, which is minus 0.15. Now I take the whole square of it. So predicted minus actual whole square, which is minus 0.15 the whole square, which will become, if you use a calculator, 0.0225. Okay, then so can neural networks, what is the main task of backpropagation? So the main task of backpropagation is to fine tune the weights, and do not let the weights saddle at a single point in the whole gradient descent part. Like the whole canyon, it should not stick at one place and start again from there. It should eventually find out where the global optimum is, and that's what gradient descent does in this part of backpropagation. While we finish by the end of you finish backpropagation, it would be all calculated. Okay, The minus 0.75 value, I didn't understand its significance. Can you please explain? Okay, I will. 1 second. So what happened is, as you can see that my output layer predicted output like had an gradient of minus 0.5. Now that means this had to be changed by 0.15. Now that we got to know that the relation between hidden and output had a small change of has predicted it wrong by minus 0.15. No, but this hidden node has not contributed to this answer entirely. I mean, the previous input layer had also contributed it. But how much should we change this weight? I mean, the weight between the input and hidden layer, we should know that also. That depends on how stronger has this node contributed. So that is why the error is minus 0.15 here, multiplied by 0.5, which we have, that is minus 0.15. So you can see the formula as stated, the weight between hidden and output into the gradient of output layer. So weight between n and n plus 1th layer multiplied by layer of n plus 1. So gradient of n plus 1. Let's say if I have another hidden node here, the same formula would be used, and you can check it out. I hope you have answered your question there. Yes, backpropagation is a way to adjust weights in a neural network. That helps fine-tune them for better learning and better predictions next time. What is the basic relation between neural network and backpropagation? Well, for a neural network to learn and converge down to the lowest global optimum, we need to fine-tune them some way. The weights have to be, we need them to learn in some particular manner. This learning process is what we call backpropagation. Taking the error from right to the left is what we call backpropagation. Is the error rate for each layer the same for the entire nodes? No, the error rate, actually the error, if you're talking about this, which I'm pointing out, this is same for the entire network. This error is for the error caused by the network and rather than by the node. The gradient is the error caused by the node, how off it was from the value it should have been. Can you explain the second part of the calculation? By this, do you mean the part of backpropagation of fine-tuning the weights? If yes, please reply in the chats. Okay. The fine-tuning here, you saw that, okay, there were hidden and output nodes. So for hidden, the weight between hidden and output, was initially 0.5. Now I have to change it based on the error it caused. That is the gradient of the output layer. That is minus 0.5, which we calculated in the previous slide. I am going to multiply it with the learning rate. You earlier, Abhishek, mentioned how important learning rate is because it determines how fast or slow does a model learn. So for the sake of example, I'm going to multiply with 0.1 with minus 0.15. When you multiply this, the change which I'm doing is sorry. I'm sorry. This was supposed to be a bit different. It was supposed to be 515. I'm sorry for the error here, but okay. 0.1 into minus 0.15, which we add. So 0.5 plus 0.015 is 0.515. I'm sorry for the mathematical error I caused here. Please, I guess it will be same goes for this. I'm sorry for that, but okay. The rest is the same. I hope you understood what I was trying to say. Is backpropagation same like backtracking? No, actually, I mean, in essence, what backtracking means in algorithms is like we go a step back and see if we did it correct or not. We do that, but here we don't just see if we did correct or not. We also see how well should we change so that we get the correct answer next time. Backtracking does not change anything in between. Here in backpropagation, we propagate the error back. We are changing the errors based on it. Then what is the basic difference between neural network and backpropagation? I have answered that neural networks use backpropagation to reach a local optimum. and global optimum, and do not let the weight saddle at one point. How to implement attention mechanism with encoder decoder in order to increase validation. Again, this is out of the scope of this webinar, but we will share our email, and please feel free to contact us uh, to get more clear understanding. Is there any other better algorithm than backpropagation? Backpropagation is not really an algorithm, it's a methodology. It's like the gradient could be as mentioned, gradient descent is a kind of optimizer. You could probably use an RM optimizer too, and the procedure will still be same. You do change, you propagate the error back, and the weights are fine tuned. Okay, how you got a learning speed? By learning speed, I assume you mean learning rate. For here, I just took an example. Okay, so wait, is the final answer depicts that error has been removed? No, actually, the error has not been removed. At the one iteration of backpropagation, the error has not been removed, but the error has been reduced. By remove, it would mean that the error is 0, which is fairly very difficult to get and probably not possible, as you still have a very small, might be a minor, but still there'll be some error. But here the error has been reduced to a smaller value. Please share the editor link to download and to run program. The codes will be downloaded. I will show what are the places that you can use for programming. Please just hold on. If there are no more questions, I will move on to programming. Is that fine? Are there any more questions? Please explain the coding session Google Colab so that all can participate doing parallel around. The coding session Google Colab. Okay, I will be showing on Sublime, but you can all use Google Colab. For the coding session, first, initially, what I'll be showing is 6 different codes for you. How do you make neural network from scratch on your own? Like, you're not going to use any framework from TensorFlow or Keras, but you're going to learn how can you make a neural network from scratch, like creating the nodes, the weights, analyzing it. Can you tell me the final error? Okay, I have not calculated the final error. I mean, if you do the iterations a couple of times with different inputs or so, you will be able to find the final error. Can you send the same codes? Yes, the codes will be shared at the end of the session. Python IDE will be okay. Any IDE or probably Google Colab or Notebook is fine, as long as you can run Python codes in them. Any kind of, yes, any Python editor is fine. Okay, so I guess I've answered most of the questions. Without any further ado, I shall move on to the coding part of this. Sorry. So time to put it all together. Let me share my screen. Any version specific Python, any version is fine, as long as you have it installed and it works. Okay, so what I have, one second, let me share my screen. Okay, sorry, not this. First, let's take it simple. This is a very small code, but let me tell you what it actually does. This code is very much likely is just simply going to take one input node and give the output to one out. Like there's one output node. I have a weight of input of 8.5 and weight of 0.1. We know from the perceptron concept that the output will be 8.5 into 0.1. Now, this is what this code does. First, for those who already know who already understand programming, Python programming, would know that I've just initialized weight variable of 0.1 and input as 8.5. Now I'm going to pass this input and weight into the neural network. The neural network is just a function that I created with which takes a certain input and a certain weight. And as a perceptron, it's just going to multiply. This is just a single input and single output node. So this is very simple. And as we can do the math, it is 0.1 into 8.5, which is 0.85. If this is clear, this is the smallest neural network that could exist probably. If this seems clear to everyone, I would like to move on to a bigger model with like multiple inputs and a single output. So let me just do that. Okay. So the code is bigger than previous one as we will be taking a bigger model. For the first code, you need not actually implement it as long as you understand what it is. Probably from this part, you could implement it. And if you need more time to write, I'm sorry, I will go a little slow. If you need some more time to write, I will wait a couple of minutes after I finish explaining so that you can type the code and see it in action yourself. Or maybe even I can run it alongside. One second, let me just open my prompt. I'll stop screen sharing for a second. Just give me one. Oh. Okay, I will share my whole screen. Okay, I hope everyone can see the prompt that I have opened. Let me go back to the first input, as I assume that many of you had asked. So I'll just simply, one second, sorry. I'm just gonna run this Python one input. So as you can see that the output is 0.8555, 85 and many zeros. That at the end, the number of zeros and one is because of the floating property of Python. So that can be played around using round, or maybe just using round function or some other way. Okay, if you need some time, I'll probably wait for a minute before you guys write this. I'll be opening the chat here so that you all can see. I'll get to know what are the doubts if someone has any. Why isn't it opening? Yes, you can use Jupyter for this. I mean, for the later on, some of the codes, like as Abhishek mentioned, that if the time permits, we'll show something that we have worked on prior. Those will be in Jupyter notebooks. I'll even, if you guys require, I'll even share the link to those to GitHub later on. What is the length of weights and inputs are not same? Okay, this question is related to multiple input. So here I'll show that this line, let me first initially explain what this output is, what is this code for. Just let me get that. Okay. Let me get that annotation now. So I have 3 input nodes here and 1 output node. So there is a weight here, here, here. So this part, the weights is equal to 0.1, 0.2, 0. So I'll be initializing from top to bottom. So that is 0.1, 0.2, 0. And the inputs are 8.5, 0.65, and 1.2. So now we know that for us normal perceptron, again, the same way how we did for single input, we would perform the same operations here. We would multiply 8.5 into 0.1, 0.65 into 0.2, and 1.2 into 0 and add them all. But how does it happen in the code? Let's see that part. So again, as previous, we pass it into a neural network function. Now this neural network, in the previous code, we just simply multiplied inputs into weight. But now we have multiple weights. So we are going to calculate a weighted sum. Abhishek mentioned about this when he was explaining the concepts of what a perceptron does. A weighted sum is just sum of all the products of input with the like respective weights, inputs with the respective weights. So in this W sum, which is weighted sum, this line assert is where we check if the number of inputs is same as number of weights or not. So assert means if the value which I have passed, if it is true, it lets the code continue. It's just going to be it's just a different way of try and catch. It's just a way of try and catch. It's like I am asserting that, okay, if len of A and len of B is same, then you move forward. If it is not true, then I exit that. So assert is a way for me to check if the number of inputs is same as number of weights. I hope I have answered the question, what if the length is different? Then after that, I would need to calculate what is the output. For that, I have the variable output equal to 0. One second. Can I run code on online compiler? Yes, you can. Can we rewrite it as if len A equal to B? So yes, you can, but what you would have to do is, if you write it as len of A equal to len of B, you're gonna put the exit condition here and import like probably you'll want to put sys.exit 0 here or something like that. So but instead of that, you could just simply like take assert as a function which is already there, which people widely use when you want to do some small checks like this, and rather than using if and then sys.exit, as you'll also be able to see where the assertion error happened. So output is 0 because initially I won't know what the output is. So so then I have to multiply each input value with each of its respective weights. Here I'll also emphasize on the point of the data structures concept, how it helps you. Now this is a list. Okay, normally you would say that probably I'll create 3 variables for input and 3 variables for weight and multiply them and add. But your neural network is going to be very dynamic. You'll probably want to change. So we use a list here, which is a data structure. And here I would call every row as a vector and multiple rows with columns as a 2D list as a matrix. So here we are performing vector into vector multiplication element wise. In general case, if len A is always equals to len B, if there are any exception, please clarify. Okay, normally, yes, the length of input will be equal to len of weights, but the exception would probably be a human error. While writing the code, you would have probably written an extra value or not written the accurate amount. So, or else maybe you would have resized the weights as something else, which would lead into not like for the neural network to crash. Now we wouldn't want that. We would want to know it beforehand. That's why we use assertion here. So as I was saying, we'll be using a vector multiplication. So what happens in the vector multiplication is vector element multiplication is, let's say here I have 3 elements, 0, 1, 2, 0, 1, 2 for the sake of simplicity. So in element multiplication, 0 gets multiplied with 0, 1 gets multiplied with 1, 2 gets multiplied with 2. So my final answer is 0, 1 square, which is 1 into 1 is 1, and 2 into 2 is 4. Wait, another question. Suppose I use 3 input, 2 weight, automatically they consider third weight 0. No, that does not happen. When you use 2 inputs and 3 weights, it'll actually show an error. I will run that part of the code and I'll show you after I finish explaining this. Please be patient. So now you saw what vector element multiplication was. Now for our output, we'll have to add all of this. So 0 plus 1 plus 4, which is equal to 5. So here what happens is for each element in weight and input, we multiply both of them. So first 1.1 into 8.5 is added and multiplied and added to the output. Then these two will be added and multiplied and added to the output. These two will be multiplied and added to the output. This output is returned, which becomes a prediction value. Now, if I make sense so far, I will show you what the output will look like. And I hope you all have been typing the codes if you feel like it. So I am gonna write it as 1 second. Show. Wait. Oh, sorry. The annotations. Yes, I'm gonna write this as Python multiple inputs. So you see this gave 0.8000. That's again because of the floating feature of Python, which actually takes everything as double and shows all that. Here, someone asked what if the weights are 3. So I've just reduced one weight and I'm gonna run. So you see there has been an assertion error here. So now I know where the error happened. Len of A equal to len of B. That means they both were not equal. And that's where the code crashed. So that means I wouldn't be predicting anything and it'll tell me to fix that part by itself. Where will all the codes available? They will be shared through you using through a Google Drive link. So after the session, the PPT and all the codes will be shared there. If this part is clear, I shall move on to the next code, that is getting multiple outputs. Okay, someone again asked assert. Okay, assert is just a way of checking if the values are same or not. So what I did there was, I'm just checking if len of A equal to len of B, which is my input list and weights list. I'm just checking if they both are same or not. If they both are same, the code continues. If they are not, then there is an error occurs, assertion error to be specific. Okay, let's go a bit different. Now, so far you saw one input, one output, multiple inputs, multiple outputs. Let's see single input with multiple outputs. So again, here I do not use input as a list because I only have one input. I do not need more. Len of A equal. Yes, len. I have in the function I have renamed the inputs. Input is like A and weight is B. Here, I guess in the next codes it will be better to understand what those are, because I've written the naming conventions are better here. So here I have only one input node, so there is no need for a list and it's just a number, 0.65. But I have multiple weights, so I'll be keeping it as a list of 0.3, 0.2 and 0.9. So again, I have a function neural network, input weights, and I'll be calling it. Now here we see that, okay, for this first output node, it is going to be 0.5 in 65 into 0.3. Please bear with my handwriting. It's normally like that. So here it will be 0.2 into 0.65, and here it will be 0.9 into 0.65. So what is happening here is we have a vector of weights, and we are multiplying each element with one single number 5. So it is 0 into 5, 1 into 5, 2 into 5, making it 0, 5 and 10. Okay, so that is what this function element mul does. That is element multiplication with each vector. So my input is a number and my weights is a vector.
Please show previous code and show what was A and B. In your multiple input program, you said len A is equal to len B, but generally, but in output, it's not the case. Can you please show previous code and what is? When I show the assert part here, you will probably understand what it is. If you still have a doubt, you can ask again. So here we have a number, right? Now this is a number, this is a vector, but our output has to be a vector because we have three outputs. We have our input as a number because it's only one input. So first we create a list of the size of output. So here in multiple input, we saw that we just initially kept output as 0, but here we'll keep three outputs. We need three variables for output, so that's why creating a list. The len of vector for this case will be 3. So the len of vector for this case is 3, so there'll be a list with 3 zeros. 0, 0, 0, 0.0 to be exact. Now the assert which I'm doing here is len of output equal to len of vector. I am checking this output list with this weight list. The assert in multiple input was between the number of inputs and number of weights. But here I'll be checking by the number of weights between the number of output nodes that there are. If the output nodes are less or more, then it will show an assertion error. I hope that was clear what I was trying to say. If please reply in the chat if the problem still persists. Okay. The code in NN that we generally use in ML, how is it different from deep in NN? So I code in NN that we generally use in ML. Okay, is by this I guess you mean how you normally use frameworks like TensorFlow, and how is it deep learning? Is that what you want to ask? Whoever asked that? Yes, logically speaking, the length will be same, but when you check for actually, when you actually go, sometimes there might be some problems. I mean, okay, the core might have crash in between, or there might be a parallel processing happening, or something like that. That is okay. No need for checking for assert, but better be safe than sorry, right? But let's move on. Now here, what we have to do is multiply each vector element with its number. So we access each element and multiply it with 0.65. That is what happens, and we return the output. So output is a list, and that is how it will be shown. To show it is for each output node, we could probably print it as like the 0th element is for the 0th output, first element is for the first output, and the second element is for the second output. Okay. If to show it in code, I will show it like Python multiple. Okay. So as you can see that 0.15, 0.13, and 0.585 is there. Now once someone else also asked a question. How to identify the number of output neurons? Well, the number of output neurons, as you see here, was, I'll have to close this so that everyone sees. Number of output neurons, as you can see here, is determined by the number of weights we have. We're just going to simply assume if we have 3 weights, there are 3 output nodes. If there are 4 weights, there are 4 output nodes. Now, if the weights are provided in 2D format, which we'll see next, you can see how we actually determine the number of output nodes. I hope I have answered that question. Answer live. Done. Okay. Please, whoever asked this question, the code in NN, could you please reiterate and ask it? So, because I'm not sure what you want to ask there exactly. Until then, if no one has any questions on the current code, I shall move on to the next code. Someone has hypertuning means. So,
Is this the real life application of machine learning? This is not real life application. This is how underlying deep learning works. I will also show you how the real life application of machine learning, actually deep learning here, or the concept works. But first, before implementing that, you need to understand what it does at the foundation level. Even if you use frameworks which are like Python packages like TensorFlow, Keras, or PyTorch, FastAI, or any other package, they all implement something of this sort in the back. Now, to understand how that code works, we need to understand how it works in the background. That is what I'll be showing here, so that you'll be able to like implement your own neural network on your own. Maybe input be accepted during run by. Yes, the input can be accepted during run by user. You just have to use like probably change this variable and put it like one second. You can't use this variable as this is a function. Input is equal to input. This would work, but let's not do that. Let's keep standard values for now. For the error, probably you would have missed a line of code somewhere or the other. If you could contact me after the session, I'm more than happy to help you. What can we predict from the output? Well, this is just a simple understanding of how the network works. For the next example, I'll show you what kind of input it is and what kind of output we are getting. Output per inside MLE function. Okay, so here the output first has to be the same length as that of the weights. If you have three weights, there will be like three output nodes. If you have four weights, there will be four output nodes. We do this because we only have one input node. So number of weights correspond to the number of output nodes that there are. And we just, for each output, like for the first element of the output will represent the first output node. So that for that we have to multiply the respective weight 0.3 into 0.65. And that is what happens in the whole list. Okay, I hope I've answered that. How can we convert my text dataset into vectors so that it can be taken as input to the neural? Okay, you have a text dataset that is part of NLP, which, if time permits, we'll show LSTM code with tokenizers and all written by Abhishek when he was working on one of his problems. Probably you can see that how that happens and how it will happen. Okay, so that was a question from YouTube viewer. Also consider problem with more than, oh yes, that we will consider that. That is the next code which I'll be showing, which is multiple inputs and multiple outputs. So if no one has any other questions, I will move on with the next code. First, let me just clear all this out. How the weights of the nodes are decided here. Actually, the weights of nodes are not decided. I have randomly entered three values. If you want, you could use some other value if you want, like maybe 1, 10, any value that you want. I just randomly used here. So far, we are not training the weights. We are just understanding how it happens in the back, how multiple nodes and outputs are taken. So, okay, now, so if it all said and done, I don't think there are any more questions. I shall move on with multiple input and multiple output. This seems like a bigger code than before, right? Because the model is bigger. The more bigger the model becomes, the more features you add, the bigger the code is going to be. So what's happening here is 3 inputs and 3 outputs. So here there are multiple inputs and multiple outputs. So there's a weight between this and this. Okay. Now you might ask, how do we represent the weights? Now each of it has to be a vector. Okay, now that we had established before. For each output node, we had created a vector from all the input nodes when we did for the multiple input part. So let's first name all of these input and output nodes. Let's name it this as I0, I1, I2, O0, O1, O2. Okay, so when you see here the weights which I have initialized, each column represents the input node, that is O0, OY2, and each row represent output node. So this 0.1 which I have is the weight between I of 0 and O of 0. The second 0.1 which I have is the weight between I of 1 and O of 0. So my three weights, this between I of 1 and O of 0, and I2 is, and I2, the minus 0.3 is the weight between I2 and O0. Same goes, the second 0.1 is the weight between I0 and O1, and so on. Is weight a 2D array? Yes, the weight is a 2D array. It could actually, the weight has to be here 2D array because you have multiple inputs and multiple outputs. So for each input and output, I have to represent a weight that here is only possible using 2D array. When actually implementing, when you go more dive deep into deep learning, you would see that the weights would probably end up having more dimensions than only 2D arrays. And again, next is input, which is a vector here again, because I have like more than one input, like one input nodes. So here we again pass it to neural network input weights. Then the function, with new function I'll be introducing here is vector matmul. This is vector into matrix multiplication. Can we optimize this code by removing WSUM and adding the code? Let me get that to that part first. Let me slowly take this. I will answer that question. So here in the vector matrix multiplication, what happens is, first again we have to check if the number of vectors, that is the number of inputs we have, is equivalent to the len of matrix. Now here it is important again as the first part when we check multiple input and output, is that the like what number of input nodes should be equal to the number of weights. Like, so that is what we do here. So when we check len of matrix, we are checking if they have 3 or not. So for each input we should have one column. Now we are going to create an output 0 list of length of vector, assuming that they are both same here. This can be changed as the number of output nodes, which can later on be 4 or 5. For I in range len, but here if you change the output nodes as 4 or 5, you will also have to change this, because that if you change output node as 4, another row is going to be added into the weights part. So let's take the next line of code for I in J, for I in range of len of vector. So for each input, I'm going to do a weighted sum. So for each vector, that is for each output node, I'm going to do a weighted sum with respect to its inputs. So I pass each input, as each node is connected to all the inputs, with a matrix of I, that is the zeroth row for O0. Then I call the vector weighted sum. This is same as what we did in multiple input parts. So I won't be going into this function. I'll just tell that for each output node. So I'll have output of, for length 3 here, each weighted sum returns one value for each of this. Now this weighted sum is going to take all the inputs and all the inputs and its respective weights for the output part. So I hope this part is clear, and that okay, can we WSUM adding line of code vector multiplication? Oh yes, you can do that. I mean that is probably okay. You could say that a function would have a bit of overhead, but it's to make it simple here, to because we have already done a function of WSUM. I wouldn't want to make it complicated. I'll just have to say that it's a weighted sum. So I can use the same part of code repeatedly, modularity. This is where OOPS helps you a lot to understand why we are doing functions. We are not using activation. We will be using activation function later on. I will show a code and how you can implement one of the activation functions which are widely used in your own Python code, and you will be running that. So I shall run this code as like, okay, wait. So you can see it is again a list of values, because each representing one output node. So 0.555 is for O0 and O1 and O2 respectively. I am confused. We want B0. What's a first row full drive? Then by weighted sum B of I. 1 second. Let me just minimize this. Okay. We want B0. Okay, by B0, I guess you mean matrix, the weight of zeroth output. Then why did we do I? Okay, see, the value of I will range from 0 to len of vector. That for here, which is 3, it is actually passing through a list of 0, 1, 2. So I value will be first 0, then 1, then 2. So this I will be replaced by 0 first. So vector into 0th row. Then it will become 1 vector into the first row. Then it will become 2 vector into the second row. I hope I answered your doubt there. It is not 1. Okay, but in W sum. Wait, what? Oh, okay, you're asking that. Okay. So here in W sum, rather, I'm not passing the whole matrix. So I do not need to specify B0. I'm only passing the first row of the matrix to W sum. So it's actually a vector into vector element multiplication. What we did in multiple input was a vector into vector element wise multiplication. That is what we'll be performing here. If you notice, I've actually just simply reused the same code which was there in multiple input. I've not done a single change or single line change in the same code, because I know that here in this function, I would need to do a vector into vector multiplication element wise. So this part passes only the first 0th row, that is this. Then it will pass only the first row, that is this, and so on. PI represents weight and AI represents input. AI represents input and BI represents the weight. But here, BI is not the whole weight matrix. It is the weight vector, as I'm passing only a vector here. Let me clear it a bit here so that you. Okay. So what this line of code does is, this part, when I write matrix of I, instead of passing the whole matrix, it's only going to pass this row first. Then it'll pass only this row. Then it'll pass only this row. So when only this row is passed, I have a vector here, because I don't have a 2D matrix. I only have a list of 0.1, 0.1, minus 0.3. This is multiplied with my input. Okay, kindly parallelly work any activation and add bias. For bias, I will be showing a TensorFlow code which many of had requested in the responses, that you will be able to simply understand. Here, I wouldn't want to complicate things by adding bias, as the code would be a bit different and difficult to time consuming too. We want like first input to be multiplied with first row matrix, right? We want all the inputs to be multiplied with all its respective weights. Like, okay, let me just again clear this. When you remember in the multiple input was, I multiplied this input with its weight, this input with its weight, and this input with its respective weight to get one output. So that is what same thing that I'm going to be doing here. That is what I'll be doing here. I'll be first input vector, which is named as vector, is going to be same. Now each of this, and I'm going to pass matrix of I. Let's say for the simplicity, I'm just passing this first row. So what I'm passing to this W sum function is what is being passed here in the first iteration is, let me write that, 0.1, 0.1, and minus 0.3 with, that is our A, and our B is 0. Sorry. This is our B, and our A, that is our input, is 8.5, 0.65, 1.2. So this is our B and this is our A. So we do a simple element multiplication between them. for that is why we are doing A of I, because I want, this is my I0, I1, I2, this is my O0, O0 and O0. This is the weight between I0, O0, I1, O0, I2, O0. So I'm going to multiply this with its respective weight and add them all. I hope that part is clear now. Any more doubts? Please ask. Okay. The lunch break will be provided in a while. At probably in a while after I do one last gradient descent. After I do that, we will break for a lunch and come back by 1:45. 45 minutes break. So please bear with me for one last code. One last code for now. We do have to do backpropagation, which we will do after lunch, and as there will be time, we will be showing codes with TensorFlow, Keras, and a lot of applications which a lot of you wanted. Okay. So if there are no more doubts now, I hope there are no more doubts. Are there any doubts from the YouTube part? Okay, there aren't. So let's go to gradient descent. Wait, for I in range, optimize, remove W sum in vector matrix. Okay, wait 1 second. Okay, so for the code, it is, what is L? Could you tell me what does L mean? Is L the number of, sorry, so it is A of I into A of I. If you do that, then it's gonna be wrong. Because it'll just multiply only diagonal elements. That is not the right way of doing it. If you want it within for loops, let me just show you how we can do that. One second, let me just clear all this. I will be sharing my email ID later. You can contact me if you have any errors regarding that. Please tell what. So there was another question on YouTube. So please tell, what do we do when the output sum is 1? Well, if the output, by this I guess you mean when the sum of the weighted sum between the input and that respective weights is 1, well then it is gonna be that is what is the answer. There is no more ahead of it. Probably when we do gradient descent, like if and the output is 1, we'll gradient descent, we'll see how do we actually check with the true values and see if it gives a correct answer or not. It will give error. What gives error? Could you be very specific? Okay, so someone wanted to know how can we do it for like range, right? Okay, so let me show you how we can do it. I'll just comment this part out so that I don't mess with my own code. So I know that 0 has been initialized, but by force of habit, I am going to initialize it here too. So after the vector, I am going to, I know that for if there are going to be 3 rows. Now for each, I can probably take either matrix of 0 or maybe even vector itself. Then what I'm going to do is output of I plus equal to, then my vector has to stay will be of j, because this will be looping through it. Vector j into a of first, I will be selecting the first row, that is, sorry, matrix, because as it is for the first output node, matrix of I, then for the respective weight. So here, now if you want, I can run this. So it still runs, it's still the same answer. So those of you who are having error, if you could be more specific about it, like that. Okay, there's another question. So suppose another question from YouTube. Suppose we want to obtain the output such that all the sum of output is 1. Then how do we proceed? Okay, so you here want to someone wants, if you want to like have it specific output as 1, we will need to provide it as an actual output, as we'll want the neural network to train. Now you wouldn't want to initialize the weights yourself so that the output is 1, because if you do that, I mean, why are we even doing neural network? We want it to learn, right? That is the whole point we do all this. So in the next code which you see for the gradient descent, I show you how we for two layers, how we can take the true value and change the weights according to it, so that you can get the outputs for it the way you want. Now just be patient regarding that. I will answer those questions. You will get the answer to those questions. Another question is, what is len of matrix and len of vector? Well, len of matrix is just the number of inputs that I have. Now, vector is, as I passed here in vector matrix multiplication input, I'll just have the len of vector will determine number of inputs that I have. Now, len of matrix, as it's a 2D array, it will, what for now here, it will return 3 into 3. Now as it's same, I can just simply use len of matrix. But if my like, what do you say, number of output nodes are different from the number of input nodes, so it might be like I just have 2 rows. To be more specific or more better, more accurate, would be len of matrix of 0, because each row will have number of weights from each input. As I had mentioned earlier, this is from I0 for O0, I1 for O0, and I2 for O0. So len of matrix 0, that is the first row, will return 3. So that is same as number of inputs. So wait, you wrote a code which is, yeah, if A is your matrix and B is your vector, then it is correct. And the range you'll need to enter len of vector and len of vector again. How to do motion detection using webcam in Python? Okay, that is a talk we can have on mail later on, because that is something I really like doing. I'll share my email. We can talk about it, and it's a bit different from neural networks. We'll go more on computer vision. Len of matrix of 0 is more efficient, right? I wouldn't say efficient. Efficient is not the right word to use. It'll be more accurate. But here I just took it len of matrix because I knew that they both are going to be same. But if I'm going to actually change the weights dynamically, len of matrix of 0 will be the more accurate method to assert. Okay, are there any more questions regarding this? Or else we can move on to gradient descent. Can I just see any, like, I'll wait for another minute for any other questions. The code will be shared at the end of the session, as I mentioned earlier. Explain GD, gradient descent. Okay, if while I'll be showing the code, I'll explain gradient descent and how does it work here in the code. And apart from, if anyone has any code right now on any questions on this particular code, I will wait and I will reply to those before I move on. Now, doesn't seem like anyone has any codes. Any more codes? Questions? Any more questions? We already initiated as 0. Oh yeah, yes, for the output, yes, we did. But I have a force of habit that I would like to make sure that the value is 0 before doing it. It's just a force of habit. It's not necessary to put that. Len matrix gives number of rows. Yes, len matrix does give number of rows. Here, as the number of rows and columns were same, I did not think like apt to use matrix of 0. But if you are going to use a dynamic way to do it, you will have to use a matrix of 0 to be more accurate.
Purpose of line 12. The purpose of line 12 is to initialize a vector with of size of the number of output nodes. Now here, to be more accurate, again, let me just say this. So far, my len of vector has been same as the len of matrix because I have the same number of input and number of output. So I need not bother about the much nitty-gritty details. But if you want to be more accurate, it has to be len of matrix. So this will give a list of 3 values each for one output node, O of 0, O of 1, and O of 2. Len of matrix of 0 gives yes, the len of matrix of 0 gives number of columns which should be equal to the number of inputs we have, because each column represents the weights between our input and output. So we have a question from YouTube viewers that suppose we have given output, then if we want the respective input, then it can be obtained or not. Also give some light on backpropagation. Okay, wait, so you want to produce input from the given output. Okay, this, like, I don't know what you want to try to do with this. I mean, for particular input is how you might, I guess, if I'm not sure if I understand right or wrong, but if I guess you're trying to ask how to backtrack to get the right inputs for the output. I assume that is the question. And if yes, I do not see a point there, because at the end of the day, we want a neural network to give an output rather than want to take an input or give an input. We want it to give any kind of input we want, and we like any image or text, and we want an output from it for what it understood. Now, so the input is, I don't see why we would do that, but if you have any idea specifically that you want to talk about, you can mail me later on. Also give some light on backpropagation. Yes, we will give more light on backpropagation when we go for the code, and there you will understand how backpropagation works in code, and if time permits, I'll show you more regarding that. Okay, more accurate would be O equal to O of len of matrix 0, because if row and column are the same, then what will be the output? If the row and column aren't same, that's why I've written len of matrix. Len of matrix of 0 will actually return the number of inputs that is equivalent to len of vector. So that is why I have this code. If I use len of matrix of 0, that is the number of columns, that is number of input nodes. So that is why I'm using len of matrix here. What will be the output for len of 0? It will be actually 3, because my len of matrix returns the number of rows that exist. So here the number of rows is 3, so it will be a list of 3 zeros. Anything else? Or we move on? I mean, I don't think in 15 minutes I'll be able to explain gradient descent entirely and answering all the questions. Len matrix never return the column. No, len matrix does not return the column under any conditions. Len matrix first returns the row. Len of matrix of 0 returns the column, because a matrix of 0 would mean you're just passing the vector, the first row, and you're finding the number of columns of first row. Any more questions? I don't see anything in Q&A. Okay. Some long ago someone had asked what hypertuning means. I'll actually show in the code what would be what hypertuning would mean. You will see there, and probably would answer your question at the same time. If there are no more doubts, I will move on to gradient descent. Okay. Now this is the code for gradient descent. Much bigger, much badder than before, because this does more stuff than what our previous codes were doing. Our previous codes never learned anything. We told it what its weight was. Now we would want to change that. We would want the neural network to learn. Give me a sec, let me have some water. Okay. Len vector, len vector returns the number of input nodes you have. So, like as the same, it should be the same as len of matrix of 0. So, well, the model here is I'm still gonna keep it simple. 3 inputs and 3 outputs. It's the same as the previous one. In the backpropagation code, we'll introduce the hidden layers. So be patient about this. Okay. It is the same as before this. The namings are I0, I1, I2, O0, O1, O2. Okay. Well, here there isn't much of a difference in the number of functions that we have. We have the same weighted sum which we used before. We have the same vector matrix multiplication that we saw in the previous code again, and the neural network. The calculation part output does not change because it is still the same. It's like one each. You could split this into one output node having 3 inputs, and like that there are 3 small subnetworks there. So our prediction methodology hasn't changed. What has changed is how will we predict it. So wait, here I missed a line. I just saw that. I'm sorry. Neural network of. So now the weights and the input part is exactly same. I did not change a single weight that there is and the input, and the representation is still the same. Like each row is for each output node and each column is for each input node with the respective output nodes, weights between the input and the output nodes. What I introduce new here is true. Now this true list which you see is what the actual output I want for O of 0, which is 0.1, 1, and 0.1. Is len of error and delta related to anything, or we assume any len? I will tell about that when I get there. Please be a bit patient. Like, I mean, I'll just say true, then alpha, then I'll come down to that. Yes, for now I've just you can't just simply assume any length to make it a clear. I will talk more about it when I reach there. So now you know what true is. Now true is the actual output we want. So when we have true, we can know what is the error. We can know how wrong it was and how off it was from the actual output we required. Now these again true are just simply taken as arbitrary values. They do not hold any significance to the model for any particular problem. Now then alpha. Our alpha here is our learning rate. Again, the learning rate, as previously talked about and mentioned, there is no right way or perfect way to determine what is the learning rate. I mean, that, okay, if you follow these certain 6 steps, you'll find out the learning rate. There's no right way to do that. It's just, I would say, from a personal experience, a small change in learning rate also differs a lot in accuracy, as I faced in a problem which I was solving. And I will actually be showing that problem too. So you'll get to see more about it there. Now coming to the question, what is error and delta? Now for each output node, I would want to calculate the error. So that is what I do here. Now this I wrote it as 3 zeros because I knew that there were 3 output nodes. But for better understanding, you can write it as 0 into len of matrix and delta is equal to 0 into len of matrix. As we would want, we would want error for each output node, and also the gradient. Delta here is the gradient. The gradient for each output node again. So len of matrix will return the number of rows, as we already know, and I will be initializing those many values. Actually, how do we find alpha in real life? So far, I have the learning rate has always been for me like a trial and error. I mean, all the things that I've tried, I mean, the first learning rate, which I always try, does not turn out to be good. Sometimes it does, luckily. I mean, but then there is again other parameters to look into. Can you share this recording session video after the session? The video would be on YouTube, so I guess it'll be probably easier to see there as it's shared. Now for the alpha part, which I was saying, as I mentioned that we would be seeing some hypertuning parameters here. Alpha is one of them. By hypertuning, I mean is something that we change, if some value that we change affects the output in general. Now weights are not in our control because we'll be fine tuning them, but alpha or other parameters like the number of layers or number of nodes in the layers, that change, number of nodes in the hidden layers, that are hyperparameters. We can change that. There are more other hyperparameters which I'm not mentioning because that would be too much to take in if someone knew. But we can always go into there, or we can always learn about it later on. So moving on with the code, we saw that, okay, the error and delta have been calculated, stored, and then we have a prediction. Okay, done. Then we return the predicted values. Now this predicted value is going to be an array because we have list, because we have 3 output nodes. So for O0, O1, O2. So, output for gradient descent, we will see after I explain this code. Could you, if you would please hold on. Okay. So now first we'll have to calculate the error caused by error for each of the output nodes. So for that, each element of prediction is for each output node, and we know what is the true value for every specific output node. We just subtract them and whole square. The same delta of I is prediction minus true. That is the change, the amount, how much it was way off, and that's the gradient actually. So how much it was way off. So I just subtract prediction minus true. Does Python automatically make a prediction list based on the input it got after return? Because we have yes, actually the function neural network will be returning the list, as we earlier saw that, okay, this prediction actually returns from vector matrix multiplication, which is the output. Now, if you all know matrices very well, you would understand that, okay, if I write a vector, can be returned as one row, and for this case, 1 row 3 columns, which I multiply by 3 row 3 column. So as these both are same, 1 and 3, a vector of 1 comma 3 is returned. Okay, makes sense? I hope that makes a bit more sense. And this is the other reason why I actually wrote len of matrix in the previous codes, because, and rather than matrix of 0, it's because I would like to first check the number of columns and the number of columns of matrix vector and the number of rows of matrix, because I won't be able to do the dot product without it. Okay. So moving on, let me just clear some of this. I hope everyone understood how the model looks, so that, because I'll be clearing it now. Okay, this part's clear. So now here we calculated all the errors and the deltas. So first, what we are going to introduce a new function, outer product. Now I won't jump into this now. I'll keep this on hold. I'll move on to the next part. The next part is for, we had seen when Abhishek had showed for the calculation of gradient, is that we have to calculate the delta or the amount of change for each hidden unit, because it totally depends on the weight, because the weight determines how much they contributed to the output, and if they contributed more to the output, they should also take more of the error, right? I mean, it's like 10 people do, they all fight, and no, not fight, I mean, they all do the same work. So if someone did most of the work, he should get more recognition, and someone who did less of the work will get less recognition. That's how we see, right? But not always the case. If it's a team, everyone worked hard. But here, weights are not like that. Weights are very selfish, because if I did more work, I am going to need more error, because he wants to be better at it. because that weight matters a lot. So for that, we introduce a new function outer prod, which is output. First, we have two, in which we pass on the input and the delta. Now, the input I know is the number of inputs is 3, and the number of delta is 3. So for each input and output, I need to create a new weighted delta matrix. So it will be of the size 3 into 3, which is equivalent to our initial weight size. I hope this part is clear, what I was trying to say. So that is what we do in this line. The out is equal to 0, len of b. That is for each row, and for each output we create a new row, and for each input we create a new column. Gradient descent is used to reduce error in output or weight or input. Gradient descent is used to reduce error in the output by fine tuning the weights. Now the output totally depends on the weights, right? Not the input. Actually it depends on the input, but intermediate computations are based on the weights. If your input, you can't just for one fixed input, you can't determine the weights that will give good output. That means for one particular image of cat, the model will be able to determine that if it's a cat or not. For one particular image of dog, it will be able to determine. If I give another image of dog, it won't be able to determine if it's a dog or not. We wouldn't want that. So we only want to fine tune the weights so that for any input, we can get the right output. So what happens here is we just simply multiply each input. We simply multiply the input with their respective delta. So when we do that, that is the amount of amount of gradient, or amount of gradient that is required, or the amount of error that they should take in so that they should fine tune more. One second, let me just rephrase this. You could say this outer product as the amount of delta or the amount of gradient each weight or each input impacted for the output. So this determines how much value should it change with. And the next part is pretty simple. I had the initial weights W, right? I'm just going to subtract it with the delta weights. Nothing else. That's what it does. It does for each element. For each element in the new weight matrix, it's going to just subtract with the learning rate and their respective delta. So out is holding what? Please clarify once. Out holds the delta or the gradient by the amount of change that we have to do on that particular weight so that we get a better output next time. I mean, again, as we have higher input, if the one which has higher input, that means, okay, I need to decrease the weight a bit more because that contributed to the output a lot. And if one which has lower weight, that means the delta for it should be much more less. This is another thing that we have to look into, because let's say let's split that. I have 1, okay. Let's say this value is 10 and this value is 1. And my output was supposed to be somewhere 5, or maybe let's make it 2. Now this contributed, or let's say, and this was also 10, this was also 2. Now this contributed to a lot of error because the value just became 102, and 100 was because of this. Now we would want to reduce this a lot, like by a very huge margin. And for that, we'll have to know how huge was it. For that is why we multiplied input into the weight. We find out that, okay, this was 100. This is very, very bad. I wouldn't want the 100 to be so huge. I would want to make it less. Probably I would want to make it like minus, probably minus 1 point something, or minus 0.000 something, so that when it's added with, or maybe even 0 actually, when for this as 10 into 0 will become 0 and 1 into 2, 2. So I get the actual output 2. For this, I need to know how off was this, and that is how I'm going to multiply here. I hope that was understood. If it's not, I'll be more than happy to reiterate in a different way and explain it. Is it clear what out does? Kindly, okay. So I have two input nodes, each of them with the weight and one output. This value, let's say the input is 10, the input is 2. This has a weight 1, this has a weight 10. And my actual output was supposed to be 2, what I wanted. Now we know what the prediction was supposed to be. What is prediction will be 100 plus 2, which is 102. So this is way off. The error is going to be very, very huge. So that is where first we have to calculate how much gradient each, how much change should be there for each weight. For that, we multiply the input with the delta it cost. Now the delta was the prediction minus 2, that was 100 here. Now we are going to multiply the delta with 10. So multiply delta with 10 for this node. So the change is supposed to be 1000, and the delta for this is going to be 20. The change for this is supposed to be 20. Okay. So if you want explanation using code, okay, first let me finish this. So this 1000 is my gradient. 10 into 100. It's 1000 because my 102, the predicted minus 2 is equal to 100. Now that 100 into 10 is going to be 1000. For this node, for this input node, 100 into 10 is 1000 because the weight is 10. Understood how it was 1000? Okay, the same for this is changed, and that is what we do. In the out, we want to know for each weight what is the change that I have to do, because every weight there will be a different change. So I create a new matrix, same as the size of the initial weight, and then I just simply multiply the inputs with the respective deltas. When I do that, I got our weighted delta here, which I'm going to be multiplying with alpha, the learning rate, to control how much actually change I have to do, because here the 1000 is going to be very huge. So I am going to be multiply by 0.1 and make it 100. So how 20? Oh, it's going to be 2 into the, sorry, did I do into, oh, I'm sorry, it's not 20, it's 200. It's 2 into 100, so 200. Make sense? Okay, 2, not 20, my bad there. I multiplied 2 into 10, but it's 2 into 100, 200. So when I multiply with the learning rate 0.1, this 1000 becomes 100, and this 200 becomes 20. So now my change is quite less, and it'll be learning slowly. Now I would want that, because the 1000 might overshoot and make this weight as very, very small, like in negative minus 990. Now I wouldn't want that. Minus 990 would be like, my answer would go right off in the negative, and there'll be a lot of difference in the error, and the error will increase. So that is what we do here. This is how gradient descent works. This is where now, for by the end of this code here, when we see, we have actually fine-tuned the weights for one iteration. Now, if you put this whole code again in a loop and have more input data, the weights will be fine-tuned for each input data every time. Like for the first input data, random weights, we fine-tune them. Second input data, we use the fine-tuned weights, find the error, and then again we fine-tune those weights to get much better accuracy if there was any error so far. The same goes on for each training set. So far, we have only seen one input iteration, and there's one output. So here I have explained gradient descent. So we are using previous to make error. Yeah, we are using previous weights to make less. Error less. So when I have fine-tuned the weights here, and when I run this code again for new input, my error should be less. But sometimes it could be increasing also at first, because it has not seen the previous data, that data before. It's still learning. So over the time, by seeing more inputs, it will actually eventually it would reduce the error, or it should. Okay. Here, I guess we'll take a break for lunch. We'll break for lunch. Um, we will come back at 1:45. I will show backpropagation, then we go for TensorFlow and Keras, what many people wanted. And if someone actually wants to code side by side for TensorFlow and Keras, please download it based on your requirements. I would suggest download only TensorFlow CPU for now, not the GPU version, as GPU would require a lot of dependencies. So like this download TensorFlow CPU, as the size of the package is quite less than GPU one, and it'll be easier for to implement on small laptops, as we won't be doing extensive programming there. It'll be just simple codes. Online TensorFlow aware, we have to download it. If you do not want to download it, you can actually use Google Colab. Let me just show you. 1 second. You could just simply use Google Colab. The reason I'm not explaining in Colab is it would take up a bit more of bandwidth than it normally does. For me, it would be a bit problem. Then there might be there might be problems in the audio connection and all. So you can just go to Google Collaboratory, create your own drive. If you do not want to use Google Colab, you can use Kaggle. You can create notebooks on Kaggle too, so that would be helpful and easy to access also. So Google Lab, see, the collab is going to take a bit of time to open for me. So rather, yeah. But okay, I guess you all understand what I want to say here. We shall meet again at 1:45 for backpropagation and examples on TensorFlow, Keras, and live problems. So you can use Kaggle notebooks also. I might be able to show that first before we break for lunch. Kaggle, just go to Kaggle, create an account, and create a notebook. So which TensorFlow module to download? I am using 1.15 on my system. I do not use 2 because there are a lot of eager execution issues there. I won't go more into that, but 1.15 is pretty good to download. You can just download a CPU one rather than the GPU one. I have a GPU installed, but I also have a GPU, and for that installation, you'll need to install CUDNN, which was written by one of the lead developers at NVIDIA. It is a package for allowing frameworks like TensorFlow and PyTorch to communicate with GPUs to do all the computations, CUDNN. You can look more about it. It's very, very good. And there is also CUDA, which we need another installations. So that installation is going to take up a lot of time. It's going to be a lot of work for now. So rather, I'll share a link later on probably where you can see how to do and do that. Later on, you can try codes on your own on your GPU if you have one, or else you can use GPUs on Kaggle or GPUs and TPUs on Google Colab, which are for free. So we'll break for lunch. Meet you. You have been wonderful, guys, for asking so many questions. Very interactive. Even the YouTube viewers, which I am not, I am trying to answer the questions which you have as and when I get to know about them. I would like to, please come back at 1:45, 1:45, and we'll go with backpropagation and more about it. Kaggle account and notebook will do, right? Yes, make a Kaggle account, create a notebook, and most of the packages like TF and PyTorch are already installed on the Keras. I would suggest not using GPU again on Kaggle, as the quota is only for 30 hours a week. Now you wouldn't want to use that up if you plan to deep more like today itself, or learn more about it tomorrow. So just use this normal CPU one, it's more than enough. Are there any more questions? Are we calculating error only once, not iterative? Oh yes, sorry, I missed this question. Yeah, here we are calculating error only once. I have not written the code for several times. I'll leave, that would be a task for you guys. Actually, I felt that would be something you guys would should do and should try doing and will love doing, because that is That is the main part. I wouldn't want to show everything, just give it right off that in the platinum plate, like gold plate. That is a challenge for you guys, how you would actually play around with the code and make it work for multiple iterations to get better outputs. So here I've been calculating error once. If you want to calculate error multiple times, a basic hint is just put all of this in a for loop, but you have to do some changes in the inputs also, and a little bit changes of here and there that I guess you will figure out when you do a trial and error. This is a very important thing, which very important question that you asked, and do it. So after the session, we'll get, yes, after the MCQ you answer, you will get the certificates. What delta is calculated? The delta is the amount of change. Okay, delta is the gradient, the amount of change and the direction that I have to change the weights so that my weights are fine-tuned more to get less error. Who is coordinator? Extra loop will make the code calculate error more, right? Yes, the extra loop will make calculate error more, but you'll have to change the inputs. You can't keep giving the same input again. You will have to add more inputs and all. Sir, any TensorFlow Online? Yes, you can use Google Colab or Kaggle notebooks for using TensorFlow Online rather than downloading right now. We will share the email to you, like probably mail it. Right. No, I'll just share me and Abhishek's email right now. I guess, Abhishek, can you please let me just confirm Abhishek's email for us. Wait a sec. Yeah, so that seems to be it. This is it. You can contact us on either of this email. Another question? When do we stop error calculation? Okay, the error calculation will basically depends on the number of times you run the iterations. If you want to run the iterations for 10 times, your weights will be fine-tuned 10 times. And probably you could stop fine-tuning your weights when you have reached a reasonable amount of accuracy or loss. I mean, when the error is very small, has become very, very small and negligible, or you have reached a pretty good amount of accuracy. Now, if so, that is like normally depends on how well do you want accuracy. We will break for lunch now. Meet you guys again. I'm sorry for taking a bit more time because of the questions. We will meet back at 1:45 or as I've taken more time, 12 o'clock. They will be shared after the session, the PPTs and all. So here, I will be taking any more questions after the lunch break. We will come back on, we will probably resume by 155 or 2. The YouTube link is shared in the WhatsApp group. You could probably access that or just search on YouTube that it's there. Like if you just search introduction to deep learning, you'll get it from JAIN University.
college. I was graduated from Istiqlal High School in Afghanistan. First of all, I want to become independent. I want to see how things goes in India. And I like to study computer science. As you know better that Bangalore is the city of computer science. For that I prefer India. And India develop our minds. We don't study just like books, or that we are studying in practical. We are studying in outside in big companies. We are working with them. For that reasons I prefer India. As I had searched best college in India, I found JAIN University among one of the best university in India. And JAIN University is good in ranking, and the JAIN University degree is valuable in all countries like USA, UK, London. In every country we can get job in very big companies. Teachers are friendly and supportive too, and they are always ready for helping us. The environment system in JAIN University is so good. We are international students because they provide, like we are in like Indian bias. We can go every place, we can speak with everyone, and we are so safe in this country. I am so happy that today I am in India. I like computer science. Today I am studying my computer science in Bangalore in JAIN University. JAIN University, I like everything. Like I came 2 months before in JAIN University. Every day they are provide us bus. We can study until night in library. We can take so many books from library. We have so many labs like physics lab, chemistry lab, programming lab. In JAIN University, everything is good for us, and they provide for us laundry. They just want to we study. We are not working in hostel. They provide for us Afghani food in hostel. For every countries they provide their food. For that I am so happy in JAIN University. If you want to be successful in life and looking for the right exposure to brush up your skills, and if you want to be powerful, then try JAIN University.
And I'm a first-year student studying in JAIN University at the School of Sciences in JC Road. I've come here from Bataan, and I came to JAIN University through the SII, that is the Study in India Scholarship. I'm very grateful that I got selected through the scholarship and that I got admitted here in this amazing university, JAIN University.
Hi, my name is Ugen Ongchu, and I'm pursuing professional forensic science in JAIN University School of Science. Buddha Mahavirikana, it is considered that during those days, especially people in the country, they take bath, they usually enjoy by taking their own meals together with family. All of them will be together.
There are a lot of good things about JAIN University, but the main thing that I would like to speak about today is about how enormous the campus is. The campus is enormous, the facilities are equally great. I, being a science student, it is imperative for me that I have good labs, good facilities. And in terms of all the facilities, I think JAIN is very, very satisfying, and it gives me immense pleasure to be studying here.
Most thing I like about JAIN University, especially, it's very systematic. everything out here works systematically. What I like here is we don't get lost out here. Though I came from Bhutan first time, it's my first experience to come abroad from Bhutan, but I didn't get lost. Like, I was done all systematically. So JAIN University, I think this is the best thing that I experienced out here.
If you survive in India, you can survive in anywhere in the world, because India is basically the land of opportunities. And specifically JAIN, because the representative of JAIN who came to Bhutan, and he gave an amazing presentation about the university. There were lots of facilities. Not only were the facilities good, the food, nutritious food, the hostel, the people, and it was really alluring not only for me, but I'm sure all the other Bhutanese to want to come here. And also JAIN has a really good ranking in the colleges, private colleges in India.
JAIN University, it's a variety of courses. It's not placed in one part of Bangalore, it's all over the Bangalore. So, like, we have management, Center of Management, School of Science, engineering courses. On top of that, JAIN University, it has international students, lots of international students. So, when I Google it, I found it's one of the top ranked in India.
Everyone is just so polite and so helpful, and I'm not exaggerating when I say this. We have many tourists coming in Bhutan, and any tourist, just ask them, how is Bhutan? They'll give you a big thumbs up and they'll say, Bhutan is great, the people are wonderful there. When you go to Bhutan, you don't feel like you're away from home. You feel like you have another home. You'll find yourself a new family, a new home in Bhutan.
Basically, I'm from Odisha, and I was there till my 10th grade. Then I shifted to Hyderabad for a couple of years for my 11th and 12th. And then, I found out about JAIN University, about how it's among the top universities all around India. So that's how I chose mechanical as my bachelor's, and I completed my 4 years of engineering here. Journey in JAIN was a roller coaster ride, to be honest. There was a lot of ups, and there was a time where I hit a rock bottom too. But I had the support of my teachers and my mentors and everybody. So they supported me throughout, and they kept me going. No matter what, they were always behind my back. When you talk about JAIN, right, so the first thing which comes into my mind is the studies, then the cultural activities and the sports. All three things are equally well balanced, and it's really helpful for a student. So when you talk about academics, you have the curriculum, which is completely adjusted to your schedule, and you have the professors who has done the PhD and MTech in various different fields, and you get a lot of ideas from them. And then when I talk about culture and sports, the college pretty well promotes each and every single thing. No matter what, they will support you. No matter what, they are behind you, and they are. The best part that I like about is, we have various n number of seminars, n number of workshops that are being held in the campus. So make sure that you take part in it, and of course, your mentors are always there behind you to support you, and they actually give you a good platform to use so that you can come up on the stage and you can give your various ideas, and you can present your skills. When we talk about global leaders, everything comes within. No matter what, if you're a sports captain head or a cultural secretary, you have to take charge of the whole entire unit. So that's how JAIN helps students to come up and show their leadership skills and emerge them. Before I mentioned that they organize various social fests, various cultural fests, various workshops, and there's a sport fest too. So what happens in that is all the responsibilities are given to the students. When we talk about opportunities given by JAIN, I'm talking about the social activities or the sports activities or the workshops that being held in and around the campus. Each and every single responsibility is shared by each and every single student. So one such case happened in my third year, where we were supposed to organize an event, and it's a technical paper event where I was in charge of leading the whole team, and calling the vice president of the university, or calling the chairman, or calling the guest lecturers over there. It was all on my shoulders, and I distributed each and every single thing to my teammates. So that's how, as a group, we came up, and the event was a huge success. I would definitely recommend JAIN, as in my previous interview also I was talking about the three pillars about the cultural, the academics, and the sports. The JAIN appreciates each and every single thing, and of course the teachers teachers and mentors are always behind your back, and they support you no matter what.
Hi everyone, I am Krishna. I am from Ballari. I am pursuing second year BTech in JAIN University. JAIN is the only university among Karnataka which is offering metallurgical degree in UG, except NIT Surathkal and IIT Madras. So that made me the reason to choose JAIN. As well as we know that JAIN is one of the reputed university in India, and it is the 5th most ranked university in South India. So metallurgist not only works in industries, it also works in the petrochemical industries, polymer designs, microscopy, mineral processing, and ore dressings. And no one replaces the metallurgy, and no other engineers will replace it by the metallurgist. I am particularly interested in extractive metallurgy, where we can study the extraction of different metals throughout the periodic table. Or research is the only field which helps us to gain more knowledge on that particular subject, or to invent any other new things, or to improve the theory which is already given by many of the professors. After my examination, I am going for internship in JSW Vijayanagara Works in Ballari. How the steel is produced, and what are the ores to be used, and what is the temperature, and how it is worked, and what are the composition of steel, how the different type of steels can be produced, what are the difference between alloy steels and main steel. To gain the practical knowledge and to understand the importance of types of steel and how the composition difference, so that we are looking for the practical. JAIN faculties are always very helpful to the students. They support the thoughts, and they're like actually friends of the students. They support and they respect the thoughts of each and every student. They teach us 100 times if you ask. Without any hesitation, they are ready to help us. Recently, they are conducting the skill development programs, which is for each semester. After that, they are going to be test talent of the students, and they are providing the 6 level certificates so that students can improve his skills as well as he can gain the knowledge on the particular material. JAIN is not only meant for classroom programs. They have a memorandum of understanding with IIT Madras, NITs, and IBM, ISE Bangalore. Actually, a few days before we had a visit for the ISE Bangalore as well as IBM in Yashwantpur. There we actually learned how the old dressing is prepared and what are the different experiments like flotation, mineralogy, material characterization, tabling, and actually they tell us how the practically it works, as well as along with the theory subjects they also provide us with the practical knowledge which enhances to improve the particular subject. JAIN University has all the facilities and they have the faculties from like all the doctorates who are come from very representative of IIT campus and NITs. The faculties are also from outside India and they are very helpful for the students in understanding the concept very well so that each and every student can gain the particular knowledge on particular subject. JAIN is the best campus for choosing metallurgy in Karnataka.
This is Darshan Venkatesh. I studied in Department of Civil Engineering and graduated from JAIN University in the year 2019. JAIN deemed to be university being one of the most renowned institutions in the city, they have been providing quality education since decades. The placement cell here is dedicated and committed to provide various job opportunities to the graduating batches, and they also conduct special programs for us to improve our aptitudes, communication skills, and they also conduct various personality development programs. And many renowned and good companies visit our campus during the placement drive. And my time here at JAIN deemed to be university was wonderful, and they also have an incubation center which help us honing up our entrepreneurial skills. With this help, I have started my own firm. It's all because of JAIN deemed to be university, and I'll always be thankful for them. Thank you, JAIN.
Hello everyone, welcome to yet another video from Robotherapy. This one is about SetJU Sports. So please don't forget to like, share and subscribe. Also guys, please just don't go watch it on Instagram. Also watch it on YouTube. So please don't forget to like, share and subscribe. Also guys, please just don't go watch it on Instagram. Also watch it on YouTube.
In School of Computer Science and Engineering, we have been offered with the options to choose the domains which we are interested in. Being specific about my domain, cloud computing is current trend in the industry.
It offers an eclectic mix of educational as well as co-curricular activities. The facilities provided by the college such as AC rooms, projectors and online learning materials on Kraken help make the learning environment here an ideal one.
The School of Engineering and Technology has a vibrant campus offering us top-notch sports, cultural and placement facilities. Unlike other engineering courses, our specialization offers vast hands-on experience and in-depth learning in latest and emerging technologies.
The BTech in Mobile Application Cloud Technology has started in the year 2016, and right now the candidates who have enrolled in 2016 are in the final year of their engineering. Currently in the phase 1 of their placement cycle, we have had around 60% of the candidates placed.
We follow an application-based learning program where projects are encouraged and industry experience is imparted through various workshops and seminars.
School of Computer Science and Engineering have been organized many technical seminars by VMware certified professionals and other industry experts to improve our expertise.
We are provided with the training for certification courses like Amazon Web Services, Google Web Specialist and Certified Ethical Hacking. The labs are equipped with Apple computers and high-speed LAN connection to ease our practical learning.
The curriculum for mobile application and cloud technology includes the following courses like iOS application development, Android application development, cross-platform app development and web application development, which every application developer engineer has to know at his fingertips.
With the best faculties and lab experiences curated perfectly with specific outcomes in the field of cloud technology and mobile application with subjects like Android, mobile architecture, iOS, RDBMS, etc.
Cultural and sports facilities are outstanding. They motivate us to take part and explore the inner talent in us. Infinity is the main techno-cultural fest which invites diverse cultures to have an exposure.
We have a dedicated placement team with the main aim of providing the best opportunities to the students.
Many companies such as Capgemini, Infosys and TCS and many companies from Japan have visited our campus and picked the best of students.
Being part of cultural club and sports team is always a memorable part of one's life, alongside having expertise in academics.
With the students from different countries, it's always been a wide range of cultural diversity and share of knowledge.
We have been accommodated in the hostel provided by the college with 2 and 4 sharing room services. Also a common eating place called the mess with wide variety of food which cater to the students coming from all the states of India and around the globe.
Hello, welcome back, guys. I hope you all have had a good lunch. Not too much that you sleep off in this session, because we will be doing a lot of interesting things in this session by showing you some of the real time stuff that we have done. So before we left, after we left for the lunch in the previous session, someone asked a question: does backpropagation learning, does backpropagation used based on gradient descent along error surface? Okay, wait, backpropagation, gradient descent is an optimizer. It's an optimizer to reduce the error. Now there are different types of optimizers that you could use, as mentioned earlier by Abhishek, like Adam, RMS prop, and all. These are the very complex optimizers that we use. Many people still prefer a normal gradient descent today because it's easy to use and easy to implement. I mean, there is not much of a big hassle there. But when you use TensorFlow or like other frameworks like that, PyTorch, using Adam and RMS becomes as easy as just typing their name, because everything is taken care by the framework. So so what I wanted to say was gradient descent is just an optimizer used for backpropagation. You could use another optimizer for backpropagation too, and based on the optimizer, your weights will change. The speed at the value by which the weights will change depends again on the optimizer alone. Okay, so we were at gradient descent, and we had to go back to backpropagation. I guess I didn't show how the gradient descent runs. So I will do that first, then I will show backpropagation. Okay. Wait. Is the screen visible now? I'll just open the chat here. Yes. Okay. So I hadn't run gradient descent. So let me just instead of doing it like this, I shall do it this. Okay, this should do it. So now you see initially my weights were 0.1, 0.1, minus 0.3 and so on. Now the weights have been updated to minus 0.2867, 0.116 and so on to get better accuracy next time when I run the code for a different or the same or the different input. And so this is what the change gradient descent does. But now let's look at backpropagation. Now backpropagation, I will be showing gradient descent, but here the model will be much more bigger and I am going to introduce activation function here. So first, the first line or the second line rather is import numpy as np. Now, what a numpy is an open source package in Python for mathematical functions. Like numpy is actually the better word to use is faster mathematical operations. It has inside the package you have matrix vector multiplication, dot product between matrices, a cross product, and you also have sine, tan h, exponential, and lot more other uh, stuff of mathematics that you could use in the code while you're doing not differentiation and integration, but other formulas or other variables that you use like pi, exponential, and the square part, the power, that is factorial. Maybe I don't know if factorial is there or not. I guess it should be there. I've never seen it. Probably factorial is easy to write. So numpy is that. I'll be using numpy here to reduce all the extra code that I used to write before. Now, before I had to write my own function for doing for a vector matrix multiplication or matrix multiplication, but now it'll just be one simple function with numpy and everything will be done inside it. So is numpy library like math module or no? Numpy library is not really like math module. Math module gives function like randoms and other stuff also, but numpy is better than that. I would say I would personally prefer numpy over math, but for normal cases math module is fine. But for numpy is just a higher version of math module, you could say. I mean, math you don't have like doing all this would mean taking a list, but numpy uses arrays and different float operations like int32 float and int types like float 32, float 64, int32, int64 based on the kind of data we have. And numpy operations are very simple. Now, when you see, you can actually do one comparison between a numpy array and a value, which so that all the values in the numpy array are compared with that particular value. Let's see this. Now, say if let me just turn on the annotation once again. Okay. So let's say if I have a numpy array, I'm just going to represent it as a normal array as 1, 2, 3, 4, and blah, blah, and so on. But for now, just 4 numbers. I want to see if 1, 2, 3, 4 is greater than 0. So what this is going to do is 1 is going to be compared with 0. And as it is not, it's going to return, it's going to return 1 and 1 and 1 and 1. Okay. Because it's going to just simply compare each element. Actually, I'll take another example. Greater than 2. It's going to compare 1 with 2. As 1 is less than 2, it's going to return 0. 2 is going to compare with 2. It's less than or equal to, so it's going to return 0. 3 greater, 4 greater. But now, this is only possible when you use numpy array. When you use an actual list, normal array list, you cannot actually do this because it will return error because you're comparing a list with integer. But this is possible in NumPy, and that's what good thing about NumPy, which makes it so like what you call modular and easy to use. So for that, I guess this is all you have to know about what NumPy is. Mostly when you're practicing on your own, when you do a trial and error practice methods, the NumPy docs, you will probably go to NumPy docs, you'll get a lot of more information there. If I start talking about a lot about NumPy, I guess the session will end only with NumPy. What time? The feedback link will be shared after this entire session. Yes, a NumPy array, not list. In NumPy, we call it an array rather than a normal Python list. NumPy array greater than 2 will actually give an answer and not an error. It will give a proper answer. It will compare each element with the number 2 and return the Boolean value 0 or 1. We're moving on. Two new functions, def relu and relu to derive. Now, relu is the activation function. Wait, so one second. np dot, no, actually you initialize a NumPy array as np dot array 1, 2, 3 and greater than 2. This will give an output. This will definitely give an output. So, okay. So what I was saying about relu is an activation function, or else it's called as rectified linear unit. Now, this is a very, very simple and standard activation function, which you'll probably use a lot when you are making a model. It simply states that if the value is greater than 0, that is, if the value is greater than 0, then let the value stay itself. If it's less than or equal to 0, it will become 0. So that means if I give -3 value to relu, it is going to be converted to 0. If I give 1 value to 0 or 1 value to relu, it'll stay as 1. If I give 3 to relu, it'll still stay as 3. But if I give -100, it's going to become 0. So anything greater than 0 is kept as itself, and anything less than 0 is converted to 0, less than or equal to 0. So wait, two more questions. Is array a keyword? No, actually array is a function in NumPy to create an NumPy array. Relu means rectified linear unit. Now this sounds simple, right? The relu activation function is pretty decent. So when, let's say if I term function f of x as relu, then there are two kinds of output. Either it's x if x is greater than 0, or else it's 0 else. That means otherwise if it's less than or equal to 0, then it is 0. Now relu to derivative is just f dash of x. So here it will be derivative of x, which is 1 if x is greater than 0, and derivative of 0 is 0. I'll later on explain why we are actually doing relu deriv when I'm explaining the part of the codes. So this is as far as relu goes. If anyone has any doubts, please ask them related to relu. Relu has fixed condition greater than 0, or we can optimize. Relu is this condition. When it's greater than 0, it is 1, like the value itself. If it's if it's less than or equal to 0, then the value is 0. If you use something else, then the activation function would be different, not relu exactly. We will see how, where, and when we apply relu. Another activation function. Yeah, there are a lot of other activation functions like tanedge, softmax. Like softmax is used probably for classification. Tanedge is again sort of like relu, but in exponent the tanedge formula of e power minus x plus e power x by the same thing. So that if you search online, you will probably get a lot of activation functions. But relu is very simple to use and understand. So for that we'll be using it. The higher activation functions, only if you understand what they do, it's more than enough, because when you actually program, you will already have it inbuilt, and you just have to call that function and not worry about anything else. X part 2, we are not calculating X part 2. Like as I said earlier, let's say if my X is this 0, let's say my X is 0, 1, no, 0, minus 1, 3, minus 2. So when I compare X greater than 0, it's going to return. So 0 is not greater than 0, it's going to be 0. Minus 1 is greater than 0, no, so it'll stay 0. This, as 3 is greater than 0, it will return a Boolean value of 1. Minus 2 is greater than 0, no, so it's 0. Now I want the actual values of X. So when I multiply this with X, 0 is multiplied by 0, returning 0. 0 with minus 1, 0. 1 with 3, 0. 0 and minus 2, 0. So this is how how ReLU will actually return only those values which are greater than 0, and rest all is truncated to 0. Is ReLU a user-defined function? Yes, here ReLU is a user-defined function, but when you use frameworks, you can just as much as simply just mention the word ReLU as a parameter, and it will be applied. Okay. Why only a question from a YouTube viewer? Why only ReLU? Well, here I am just using ReLU as it's easy to explain and understand, and you'll see where I use it in this problem. But if you want, you can actually just change the inside the function name and replace wherever I call ReLU with that function with a different operation. Like if I change this to tanh and do tanh operations, or you could probably do that and get different answers based on it. But if you change the ReLU function to tanh, you'll also have to do the tanh derivative as I did for ReLU, because you need a derivative here, which you'll understand later on. Okay. Leaky ReLU is great. Why we define ReLU here? We can simply use ReLU, right? Here we are not using a framework or any of sort right now. The next code is with framework. So that's why I am making you understand what ReLU is, so that you know what it's doing. Like rather than just simply taking it, you understand what it's doing and how is it useful in this code. Okay, leaky ReLU is good. Okay, leaky ReLU, it depends again on the problem that you want to solve, if leaky ReLU is good or not. For this particular case, I am just going to take ReLU. When we can use leaky ReLU? Well, when we can use, I personally haven't ever used leaky ReLU, because for me, just using softmax or ReLU has always given better outputs. But if you want to talk more about it, you can email me later on about that, and then we can discuss more about leaky ReLU and where we can use it. So moving on with the code. So the initial line that after that alpha is equal to 0.2 is standard. It's again the learning rate. Before I took 0.1, now I'm just going to take it as 0.2. So 1 second, let me just clear this. Now here I have initialized a value hidden size 4. So that means I have certain inputs, like for this example 3, then I have 4 hidden units or 4 hidden nodes, and I have 1 output node. This is my model. So this is all connected to so on. And these are all connected to 1. Okay, so that's the case. So when I write np.random.random 3 comma hidden size, that is 3 comma 4, that means a 2D array of this size is going to be created by this function, and it'll just be random weights. And for for normalizing it, I'll be just multiplying it with 2 and subtracting -1. This step is optional. You can just remove -1 and 2 also and keep those random weights, but it totally depends on you later on. And the same, this is 3 comma 4 because I have 3 input nodes and 4 hidden nodes, which will be one particular sub weight, so 3 comma 4. But then I have 4 hidden nodes and 1 output node. So this second line is going to be 4 comma 1. So it will be a matrix of 4 comma 1. How it will create 2D array? Why random dot random? Okay, so the random dot NumPy is a major package which has many classes. One of them being random. Now this random class has a function called random. Now this random function takes either a normal value. If I say 1, it'll just return the random, like if I give it as 3 comma 4, it's going to return a 2D array of 3 comma 4. If I return it right is at 1 comma 2, if it's returned as 1 comma 2 here, then it's going to return a 2D array of 1. It'll actually return 1 row and 2 columns. As I've written 3 comma 4, it's going to return 3 rows and 4 columns. That's the inbuilt function. It takes care of everything. Rather in previous, when I actually had to write all the weights myself and randoms. So here NumPy takes care of it. No initialization of 2D array. No, actually I am assigning the 2D arrays as random values, which will be taken care by this function mp.random.random. Okay, the same way how I initialized for the weights between input and hidden layer. The same way I'm gonna create weights between hidden and output layer. So my output layer, as it has only one node, my size is going to be 4 comma 1. So hidden size is 4, so 4 comma 1. It'll just create 4 rows, each one with a value. So I have another question. Why 2 is multiplied and 1 subtracted? Well, I have just simply to make the random weights, as the random weights could be as small, I just multiplied by 2 and subtracted my 1, maybe to normalize it. This step is optional. You can remove this step if you want. You can just simply keep np.random.random weights without having to worry about multiplying by 2 and subtracting 1. In output layer, along with softmax, what other activation functions can be used? You can use relu, softmax, tanh, and there's one more, leaky relu. Based on what you need. Softmax is normally used when you want to classify, and sigmoid. Sorry, yeah, thank you, Abhishek. And sigmoid function. That was the word I was missing. Softmax could be used. Softmax and sigmoid could probably be used for classification, whereas relu is mainly used for when you want values rather than just 0 or 1 or discrete values. When you want continuous values, that is. Would you repeat this? What do you want me to repeat exactly? Yes, random is a function inside which I have to pass the size, which will be a tuple. So it will be random of tuple 3 comma 4. Someone asked me to repeat, but could you exactly tell me what do I need to repeat, like the random function or how the weights are being initialized? No reply. Okay, then I'll just move on. So we saw that these weights are initialized. Oh, backpropagation summarize. So as I said earlier, backpropagation is just a method for us to propagate the error, from the output to the input layers from right to left, so that the weights are fine-tuned and they give better prediction next time. Can we write anything else except yeah, you can write anything in place of np, or you can just type it as n, or maybe even your name if you want. But numpy as np is a very standard way to use, because a lot of people use this, and a lot of codes, open source codes, you will see that. And if you ever want to contribute or work with someone, this is the standard naming convention they'll probably use. Can you repeat about relu to deriv? Okay. So as I told, that relu is just a function which returns x if x greater than 0, or else 0 if x is less than or equal to 0. So now derivative of this function f dash of x will be derivative of x, which is 1, if x is greater than 0. Derivative of 0 is 0. 0 if x is less than or equal to 0. So that is why if this will just simply return, if the value, if it's greater than 0, it'll return 1, and if it's less than or equal to 0, it'll return 0. That is what ReLU to derive does. Why do we do this? You'll get to know as we move forward. So let's go ahead. Let me just clear some of this. Number 5, how can we move? What if we want to initialize a 2D array with number 5? Okay, so if you want that by number 5, you mean you want 5 hidden nodes, then it's as simple as modifying this as 5. Hidden size is 5, so our np.random gets array elements as 5. You mean number of inputs as 5? If you mean wait, we initialize a 2D array as random. Wait, someone asked hidden size represents the number of nodes I want in the hidden layer. There's only one here, and so I'll be representing as 4 only. We initiated array, so using random function. We created a 2D array of size 3, 4. That means there are 3 rows and 4 columns, and 4, 1 between hidden layer and output layer. So I have 4 rows and 1 column. Yeah, there can be multiple hidden layers if you want, but then that will just mean more initialization of weights, and that will be just, you'll have to change the code the way you want it. If you understand this, it would be, you'll probably understand how to do it for multiple hidden layers also. Oh, so you want to initialize the weight with 3 into 4 with 5. Okay, now now I get it. So each weight has to be 5. So my rather than answering that, I would say, why would you want to do that? I mean, like initializing weights with all weights equally would probably not be a good idea, because I personally don't feel that initializing them with same are a good idea. Same with the number 5. If you want, you could probably do it with 0, but normally people do it with random, or rather, I would say that truncated normal, like from a normal distribution they take it, so that weights are evenly equalized before. So if you give every weight equal importance at the start, it'll just be a lot of work. I mean, you're just assuming that all of the inputs are important, but with random you're not assuming anything. You're just simply taking stuff from here and then you're letting the neural network work. Let it just be there. But if you want it to be initialized with 5, you would rather not use a random function. You would use a np.array function with a parameter passed. So initially weights are blank, right? No, they are not blank. I mean, when I run this code and I print weights, if I print weights of 0, 1 here, you'll actually see some values. If you want, let me just do this part. Okay, you see, they are not blank. They are just randomly distributed from a normal distribution. In DL, we have to practice experiment changes in number of hidden layers, learning data. Yes, you will need to experiment a lot with the number of hidden layers, learning rate, optimization function depends a bit, but I guess if you stick to one is also not a problem. For getting better accuracy, you will, or less error, you will have to do a lot of hypertuning. That is what we call hypertuning, experimenting with these parameters that are changeable. Okay, so this is, I hope you understood what the random weights are doing. What if the random weights are far more deviated? Then it should be form and loss only. Initially, it doesn't matter if the random weights are far more or not, because we are either way going asking the neural network to learn. So if it's very far, it gives a lot of error. Not a problem, because the error is going to be reduced over through the iterations. Can we use negative values for weights? Yes, you can use negative values, because sometimes some hidden nodes would reduce that, sometimes some input values will like, okay, because of this, the output value will be reduced. Please repeat random.random. Random is just a class in NumPy, and random is a function. Random is a class in NumPy, and the second random is a function in that random class, which we are calling here. Can ReLU? I have a question from YouTube too. Can ReLU be used for machine learning, machine translation models? Why ReLU only? Okay, for the machine translation models, I would not be going for that topic here. You could mail me regarding that. I will love to talk to you about it. And why ReLU only? Again, I'm using ReLU just for an example here, because it's easy to understand, and that will make it clear. But you can obviously, if you want, feel free to change the the activation function if you know anything, if you know any other one. What is the role of ReLU to derive? You will get to know what's the role of ReLU to derive while we go on along the way. Okay, so why -1 used in random functions? I have previously answered that. I'm just using it, but it's not necessarily to use -1. You can skip that part if you want to. Okay. The arguments. Oh, the arguments are just that I'm passing a tuple of the number of rows and number of columns I want. The 3 is the number of rows, and hidden size, which is 4, is the number of columns. What change does your 2, dozen, 9, 13, and 14? So the every random value which will be generated my NumPy, I'm just multiplying by 2, and each value is then again being subtracted by 1. I'm just doing this for the sake of normalizing it, but it's not always necessary. Okay, I'll just move on now. So what is NP? We will see about NP dot dot. Please hold on. Let me just go on with the flow. After normalizing, also the array will still be of size 3 into 4. Normalizing is just changing the values into in a certain range. What is the role of random? The role of random is to generate random values based on the size I give, the number of random values I want based on the size I give. Okay, so here I'm just going to be taking an input as 101. So my input values are 101, and I'm expecting an output of 1. So my actual value is 1. Wait, why we true function? Could you please reiterate the question? By normalizing, what I meant was the values will be in a particular range. I do not change the size of the array as in such. If you want, I'll actually even show what would it look without the part of -2, -1, and multiplication by 2. Okay, so print weights. Okay, this, and I'm just gonna put another. So you see the value is still the array is still 3 into 4, but I've just normalized it so that I can, have it in a particular range, here it being like between 0 and 1, so that it's good. I mean, normalizing is always good, it's never a problem. But if you do not want to normalize, it is totally up to you. Okay, this being said and done. So first, what we did in the previous codes was, we always used to write the function and do everything. But here NumPy made everything very, very easy. So first I'm going to just initialize layer 0 as my input. So this is my layer 0 and it's been initialized as the input which I have. That is not necessary, but you could do it if you want. You can just simply use input instead of layer 0, but for better understanding of the layers, I've used that. Then layer 1 will be the multiplication of the weights between layer 0 and layer 1, that is between the input layer and the hidden layer, multiplied with the inputs, the vector matrix vector into vector multiplication, as we saw earlier. Weighted sum, as we saw earlier. So that is what np.dot does. np.dot is the standard mathematical dot function that we see. What would this into this do? This in mathematics dot product, what would be happen that everything is multiplied to itself, element wise multiplication, and they'll all be summed over. Summation summed over. That is what np.dot does. Before we wrote a function for vector matrix multiplication and then doing the weighted sum inside it, but now we don't have to do that. And the NumPy package has a function called dot which takes care of it very flawlessly. And then the output which we have, that is the value of each hidden layer, that is passed into ReLU. Because here, for this particular problem, I do not want any hidden nodes to have a negative value. So that is why I'm using ReLU here. Because I don't want that, okay, that should be any negative value for hidden nodes. Weight can be negative, but the computations need not be negative if I want such. So here, I do not want any negative, so that's why I'm using ReLU. And when I pass the ReLU, I get an activated hidden layer. So that means I've done the computation for each hidden node and I've passed it into the ReLU and I've solved it out. So that makes my hidden layer activated with in a particular range of only 0 and till anything greater than 0. What difference does it make if you don't use activation function? Well, if I don't use activation function here, I'll have negative values for the hidden nodes. But I don't want that for this particular case. I want them all to be either 0 or positive. Does multiplying by 2 and subtracting by 1 increase the dynamic range of random output from 0 to 1? Oh, yes. This was a question from YouTube. Yes, by multiplying by 2 and subtracting by 1, yes, I'm fixing the range, the dynamic range by in a particular 0, like -1 to 1 here for this particular case for normalizing that is why I did that. But it's not very much necessary. You can feel free to drop that. But again, having normalization is good, and what harm is there in doing it? Layer 1 represents hidden nodes. Yes, layer 1 is the hidden nodes that are there in my here being 4. So the size of the layer 1 after doing all the calculations will be a vector of size 4. No, a layer 1 will actually hold value for each hidden node. If you want to see the output for that too, let's take it step by step. There's no harm. We can do that. Print layer 1. You see, layer 1 returned 4 values for each hidden node. -0, -0 is 0 actually. 0, 0, 0.6 and 0. NumPy will take care of that -0 itself. We do not have to worry about that. Repeat what? Could you be specific about that? Yeah, so dot product is actually adding, doing a weighted sum for each row, right? So what we did previously was took every vector that there was and did like every row and did a dot product between the input and the weights corresponding weights for it. So that is where this dot product does this. So when I my layer 0 is what? One second, let me just do this. My layer 0 is one row with 3 columns, right? This is multiplied by 3 rows with 4 columns. So now what will be the product of this? 1 comma 4, because my this is being multiplied with each row present in my weight. So that is why it's 1 comma 4. Someone asked me, okay, what does layer 2 error mean? Layer 2 error, I've just initialized it as a variable when I have to find the error of the final output, like predicate minus true, the whole square. So isn't dot product matrix multiplication? Yes, dot product is matrix multiplication in this scenario. And normally, they are very, what do you call, extensive functions where the operation would very much change based on the input you give. If you give a vector into vector, it'll still do the same thing what it's been doing. It won't throw an error there. So you could use dot product for between np dot dot for a vector into vector and vector into matrix. When you actually experiment it all out, you will figure it out. Experiment will make you learn more rather than me, saying more about it. So moving on, as we saw here, the hidden layer, we have passed it into the ReLU, and we have all values either 0 or greater than it. Let's calculate layer 2 values. Wait, what is the value of t? Okay, you have gone ahead. I'll tell what does t mean later on, but let's just see what layer 2 does. Now layer 2 is multiplication of hidden layers, hidden nodes, that is multiplied by their respective weights, and that is what I'm doing here. Np dot dot layer 1 weights 1. So my layer 1 size is like 1 comma 4. I'm just going to be multiplying it with 4 comma 1, giving me a 1 comma 1 output, which is the size of my output node in a 2D array. Okay, another question. Instead of true equal to 1, can we assign another value? Yes, you can. Here I just assumed that I just wanted the actual output to be 1. You can take any arbitrary value if you want. I mean, you can take it 10 if you need, but that's it. Layer 2 is the output node. Yes, layer 2 is the output node, and that is what been happening here. So far, this is here when this line is done. Layer 2 is calculated. We have got a prediction. A layer 2 value is our prediction, the predicted value for our whole model. So initially in the previous codes, we did so many functions, we called so many stuff to get a prediction. But here it was as simple as writing 3 lines of codes for even including a hidden layer there. Now we have to calculate the error. So the error is going to be a layer 2 minus the true value, the whole square. And I'm just going to sum it all up, because if I have multiple output nodes, I have to add all the error. Here, as I have only one, it's not going to make a huge difference. ReLU function work, a question again. I am using ReLU as an activation function to keep the values in the range of either 0 or greater than 0. I do not want my hidden nodes or the hidden perceptrons to have a negative value. True size depends on layer 2 size, right? Yes, true size depends on layer 2 size. If your layer 2 has 2 output nodes, then your true should also have 2 values, because you would need a true value for each of the output nodes. So far we have calculated the error. Now it's time to calculate the delta. In the previous codes, I had calculated the delta by subtracting the predicted minus true. I'm just going to do the reverse here because I am doing a addition sign. This is totally up to you if you want to reverse and do it. Like, still negative of negative is going to be the same. As there the negative sign changed, here I changed the negative sign in the gradient descent calculation. So that's what happened. So no big deal. So true minus layer 2 is still correct. is this quote as the efficient way to implement gradient descent? Yes, we are implementing gradient descent here as a way to fine tune the weights. And it's rather than efficient, I would say it's an easier way to write and a better way to write the code using a mathematical package. So after we have calculated layer 2 delta, now it's time to calculate layer 1 delta. That would be the delta gradient for each of the hidden nodes. So as I had shown before, that it was like during the slides, I had shown that delta for backpropagation for weights, sorry, my bad. So delta for layer n is equal to the weights between n comma n plus 1 into delta of layer n plus 1. Now our n is our hidden layer, which is 1, and our n plus 1 is our output layer, which is 2. So layer of 1 delta, like layer 1 delta, is equal to layer 2 delta into the weights. Now the dot t here represents transpose. So we are transposing the matrix. So initially when it was 4 comma 1, and it's going to get transposed to 1 comma 4. Now I hope everyone knows what transpose of a matrix is. Now why transpose is a really good question. I'll tell you why now. Now layer 2 delta, the size of layer 2 delta is going to be 1 comma 1, right? And our weight 1 2 size was 4 comma 1. When I try to multiply 1 comma 1 with 4 comma 1, it will fail. It will fail because 1 and 4 are not same, so I cannot multiply these two matrices. So to make this possible, I'm just doing a transpose of this. So this becomes 1 comma 1 multiplied by 1 comma 4, right? Thus giving me answer as 1 comma 4, which is what I want. What is the value of alpha? Value of alpha I had shown above, it was 0.2. Like as in here, it is 0.2. The dot is syntax of transpose. Not that dot is actually equivalent to np dot. I mean, if I need to show this much more clear, writing this is similar to np dot dot layer 2 delta comma weights 1 2 dot t. So instead of using np dot dot, I've just used the numpy array, which also has the function dot. Okay. Do we need to do transpose in all cases, or depends on the nodes? You need to transpose in all cases. About it. You will have to do, because the size will vary from every place to every place. Now, as you're going back, you'll have to look at it backwards. So every row becomes a column and every column becomes a row. So that's the perspective that you see normally, right? That's what we are doing here, and that's why we do transpose. Now, let me explain why we do transpose again. Let me just clear some of this. Okay, so our layer 2 delta size is 1 comma 2 here, and weights 1 comma 2 sizes 4 comma 1. Now I won't be able to multiply this because the sizes do not match. So I'll have to transpose this, so that when I transpose it, I get 1 comma 1 into 1 comma 4, where we'll be able to do the matrix multiplication and get as the output as 1 comma 4, which is what we need, because 1 comma 4 represents the number of hidden layers. Like the number for each element in 1 comma 4 would represent each hidden unit in the hidden layer. That NP line will also transpose, but you earlier said dot is simply to multiply matrices, then how it is see, what NP dot does is it just multiplies matrices, but I also mentioned later on, after that is the dot function is there is a lot of modularity here. That dot function has many different kinds of function. It allows multiplication between matrices, vectors, and matrices. So that isn't a problem. So instead of writing NP dot, I'm just writing layer 2 dot, and weights 1 comma 2 dot returns the transpose matrix of weights 1 comma 2, which was earlier 4 comma 1 becomes 1 comma 4. I get returned that weights matrix, which is multiplied with layer 2 delta. And dot t performs the matrix transpose rather than the dot function. By dot t, this performs the transpose. This performs the multiplication. What if we can multiply after transpose? That just means that your weights are not initialized properly, or there is some problem in your weight matrix. Because if they are all correct, there should never be a problem in multiplying after transpose. So, okay, now here I'll tell you why we needed ReLU to derive. Before we went for lunch, I told you when I was explaining a bit of backprop, I told that all the nodes are very selfish. They do not like someone who contributed a lot to the output would want more like importance, and that means be more fine-tuned. So here, when I had used ReLU to derive, some of the nodes, let's say this node had become 0. These 3 nodes had become 0, right? When we actually calculated the output. So these nodes would be like, why should I take the error up? I mean, if there was some error caused in the output, they'll say my value was 0. I didn't contribute anything to the error. Then why should my weights be fine-tuned? I didn't take part in that wrong answer at all. So they'll be like, I don't want any part of the error. So that is why we use ReLU to derive. So any value in the layer 1, which was returned as which was greater than 0, will face the delta, and anything which was less than or equal to 0 will not face the delta. It'll just say that I don't want the delta at all. For me, the delta is 0, and anything which contributed or which was greater than 0 will have some amount of delta with it. Okay, I hope that part makes sense, and why we are using ReLU to derive. We are just using it to control that only the hidden nodes which contributed in the final output are like fine-tuned, and not the nodes which did not contribute anything. Now, the last part, that is fine-tuning the weights. Here I am using the I'm using the equation as plus, because I had mentioned earlier I'm doing true minus layer 2. So as I change the negative sign, I have written it as plus here. Now to change the weights of 0 and 1, I'm going to multiply layer 0 with the delta, which I had done previously in gradient descent. So I'm just going to multiply the input size which I have as right now 1, 3 into the layer 2 delta, which will be 3, 4. Yeah. Wait, I have okay. 1, 3 and 3, 4, which will return in 1, wait, sorry, I did something wrong here. Yes, I did do something wrong. My layer 1 delta is layer 2 delta, that is 1, 1 into 1, 4, which is 1, 4. So my weights 1 will be layer 1, that is 1, 3, which I'm transposing as 3, 1 into 1, 4, which will return as 3, 4. This is the whole matrix weight matrix for the delta, which has to be added or rather subtracted from the initial weights which we had. And we are multiplying with, obviously, with alpha, that is our learning rate 0.2. The same thing, the same step goes for weights 1, 2, layer 1 dot t dot layer 2 delta. So let's say if I had another hidden layer here, assume I'm not writing the whole code, but say if I had another hidden layer between 2 and 3, so it will just be as alpha into layer 2 dot t dot layer 3 delta. So this is as simple as go. So if you add more hidden layers, if you want to add every place, you'll just have to increase one line, nothing else. With this, you have created a whole neural network from scratch with a hidden layer in between. And if I'll answer a few more questions, then we'll go on to TensorFlow. If there are 10 hidden layers, we'll write 10 lines of code. Can't we make it inside loop? Yes, you can make it inside loop if you want. If when you have more hidden layers, that is this is just for the sake of example that I've shown with variables for more simplicity. But if you want to make a complex model, you could do this. But you'll later on see when I show you TensorFlow codes and Keras codes, you'll see that how this all can be reduced to smaller stuff. So I'll take a few more questions on this code before I move on with TensorFlow. Okay, so the ReLU to deriv is just derivative of the ReLU function. Now the ReLU just changed all the values which kept all the values which were greater than 0 as itself and less than or equal to 0 as 0. And ReLU to deriv just told which were greater than 0 as 1 and which were less than or equal to 0 as 0. What is the role of delta dot dot? The layer 1 layer in the layer 2 delta dot dot is just multiplying the delta with each weight so that we get to know how much is the gradient and how much do we have to change it. If you had one more hidden layers, you will have to do a few more changes, as in create more weights, do the multiplication after this line for the value for the new layer, change this to layer 3 and so on. The delta has to be calculated for the same. Okay, so if anyone who has got an error, I guess I missed this part. Just type this here. That should fix all the errors that you have. For classification at the output layer, rather than using a ReLU, you can use a softmax function, which probably you'll see now when I show a TensorFlow code. Okay, so if all said and done here, I hope no more doubts. I changed this to array because some of them were getting error here. I am sorry, I must have missed this while typing here. I have written it from somewhere else. So that the .t part works. For that to work, it should be a NumPy array, and that's why I've written as np.array. So anyone who is getting any other errors, please mail me regarding send me the code. Or else I'll share the code later on. You can probably cross verify it yourself. Okay, so let's just okay, so this is my Jupyter notebook. I will be first showing you MNIST digit classification in TensorFlow. I will not be running any of the code here because like the code uses a lot of GPU and that would take a bit of time for training. So most of it is pre-trained. So I'll show you what it does, how does it do. So the first line is just importing the data. Now, for those of you who don't know what MNIST is, it is just we term it as really good standard data sets which are used when we are learning first. Normally, most of the tutorials you see, they'll first use a MNIST digit classification or maybe fashion MNIST for fashion dataset. This dataset is normally cleaned, like there is no discrepancies in the dataset. Do we have to type all this code inside TensorFlow? If you want, you can type side by side while I'm seeing, but I would really suggest you experiment it along way. But if you guys want to type it, I'll wait and I'll let you see this on your notebooks which you are using. I mean, it would be better, like it's just one small MNIST code, so I don't have a problem if you all type this. This is only the code. When you run the code, this is just the GPU outputs that I get. But these two lines are the only code that happens. So moving on, as I was saying, MNIST is just a form of data set which is there, and TensorFlow has it inbuilt. So I'm just going to call the function input data. And here I'd like to say that if anyone is using TensorFlow 2.0, I guess this won't work. This is written in TensorFlow 1.15. So there, so input data is there. Then I'm just gonna read the data sets. The data set is just gonna be simply read, and they'll be one-hot encoded. By one-hot encoding, I mean is that if I have multiple classes, that is, what is it? Here it's as it's a digit recognition. I have 10 classes. Let me change the colors. I have 10 classes, 0, 1, 2, 3, 4, 5, 6. I have 10 classes. So for each class, for representing the classes, I'll represent as an array of 10 digits. If it's class 0, my first element will be 1 and rest all will be 0. If it is of class 2, it will be 0, 0, 1 and then rest all 0. Similarly, I do this for all kind of input which has, and this one parameter takes care of it all. I do not have to do it manually. And by reshape is just to not change the type of data it is. This would normally be 24 into 24, like normally MNIST is very small data set of size 24 into 24. That is a 2D array of 24 into 24, and it's grayscale, so it's only either black and white. So now moving forward, like, okay, so this line, what I do here is I import TensorFlow. Then these are my parameters. My learning rate, I have set it as 0.001. Training epochs. Epochs are the number of times you want the neural network to learn on the complete data set. Like say if I have the whole data set of 100 images, I want the same neural network to run those 100 images, fine-tune themselves 20 times. Can we import TensorFlow in Python editor? Yes, you can import TensorFlow in Python editor if you have installed. If you don't have the package installed, it'll throw an error. Now, batch size is something I wouldn't want to get into right now because explaining that would be a lot. But just to make it clear, small gist would be batch size just determines after how many images do we train together, and we fine tune the weights together. TensorFlow.examples.tutorials, no module found. If you have an error of no module found, TensorFlow.example.tutorials, either you don't have a TensorFlow installed or you have a different version than me. And my input here, number of inputs, which initially in the examples which I had shown earlier was 3 or like 3 or 4 based on what I needed. But here, as I have a array, like 2D array of 24 into 24, which multiplies into 784. So number of input nodes that I have is 784. And number of classes, that is my output, number of outputs that I have, that will be 10 because I have either from 0 to 1 and I've hot encoded it. How to upgrade the version of TensorFlow? You can just use a Conda. If you use Conda, you can use a Conda upgrade command or a pip upgrade command. If you need any more queries like that, you could probably mail me for that. I'll be more than happy to help you. Now, the number of hidden layers. I'm here, the hidden layer, I'm just going to say that I only have one hidden layer with 256 hidden nodes. So I'll have, let me draw and show it. So I'm going to have, this is my input, 784 of these. And now my hidden layers are going to be 256. So they're all going to be connected to each other. Then I'm going to have 10 output nodes. Now there are interconnections too. They are just all dot, dot, dot. So to initialize weights, let's understand how do we do that in TensorFlow. TensorFlow has different naming conventions like constants and variables. So the variables here are different. Variables are those which are which are later on assigned when we initialize the whole TensorFlow model. So when I say here tensor tf dot variable, it just means that okay, this weight is of size n inputs and n hidden layer. So 784 into 256, and this is going to be initialized when I run the entire code. And then I have output of weights tf random and hidden layer, and so my output weight is going to be 256 into 10. Now here I'm going to actually use bias because as I'm going to be predicting classes, I will need bias to take a bit control over the model. And for bias is simply the number of nodes that there are. So as there are 256 hidden layers, I'm just going to have 256 biases. And if there are 10 output classes, I'm going to have 10 biases for those. So now, as I've mentioned, and here also again, I'm using TensorFlow random normal. So that means it's gonna generate random values and it's gonna normalize it itself. So I do not have to worry about normalizing, by which I did earlier, multiplying by 2 and subtracting 1. Here, the function takes care of everything. Simple, right? I mean, we did so much before, and now it's just writing this random normal, and it does everything on its own. What next is, this is a graph. Now I want to tell what kind of input do I have. Now my x input, like the input which I have, it's going to be of size 28, 28, 1. 28 being the number of rows, 28 being the number of columns, the second 28, and 1 is the number of channels that I have. I'm sorry, earlier when I said the kind of data MNIST is 24 into 24, it's actually 28 into 28, my bad. Please correct that if you have ever written somewhere. So here it's actually, I have one channel. As you see, every image has either a black and white channel or an RGB channel. So if it's black and white, there's only one. And when it's RGB, it is 3. So when x is equal to this, the none part here is what is the batch size that I wanted to say. So here I do not specify as 128 or something. It'll just I just write none. So TensorFlow automatically understands that okay, there is some particular batch size which I'll have to understand on my own. So TensorFlow does that for you, and you do not have to explicitly do it. So much of the work got easier, right? So the same thing goes for the number of output, none, and n classes. This is just the type of data that I'm going to pass, float, as I'm the data could be normalized, and output as float, because at the end of the day, it's all going to be passed into a activation function. So float does not matter to me. Now, my input was initially a 2D array. Now I don't want a 2D array because my neural network takes a single array, as we saw earlier, always. We want a vector. That is what this line of code does. It's going to reshape it to -1 and number of inputs. -1 determines that I just want one row, and number of inputs is the number of columns that there are. Okay, so we will just take a bit fast track here because we would want to finish it. We'll see. So now we saw that we have initialized it to TF layer 1. Now what we did, the matrix multiplication is much more easier here. I just took X flat and weights hidden layer. I multiplied it. And as I have to add the biases, TF.add bias. Now the activation function used over hidden layer again here is relu. I have again used relu as an activation function. And logits is what I would call layer 2 here. The layer 2, I'm naming it as logits here. No, not much difference. So the logits here is again multiplication of layer 1 and the respective weights, adding with biases. Now here, this is our cost function. Now this is where the whole error calculation and probably how it'll determine how much does the how much of the delta will be. It all happens here. This is a very standard code. Probably there's nothing you can change here apart from changing the type of function you want. I'm using a softmax cross entropy with logits because my activation function for the last logits is softmax because I want it to be in a particular range. So it'll only be from 0. It'll either be only one of the 10 elements will be 1 and rest all will be 0. That's what softmax does. And its cross entropy means it's just going to check between the classes, which class came out correct. So I'm going to pass the logits, that is my predicted value, with my labels, which is the actual value, which I already know. Now, this is my optimizer. I am using a gradient descent optimizer with a learning rate, which I've said, and I've told what I want to do. I want to minimize cost. So that is what will be done here. So this gradient descent can be changed up to, if gradient descent can be changed up to Adam optimizer if you want. What is the function about hidden layer over there? The hidden layer function is relu. What is the function? Okay, you are asking the function of the hidden layer. I just added a hidden layer so that my predictions are better than normal because I would want them to be better, and having just 2 layers does not make it very well. So you could say that I sort of experimented with it. You cannot use relu instead of softmax here because what relu does it will just change the values either from 0 to 1. But what I want is the values, like out of the 10 values that I have, only one of them has to be 1, rest all should be 0. And softmax makes that possible. When you see it online, you'll understand what softmax actually does. Is this code same dealing with image dataset? Yes, this code is very similar to when you're dealing with image datasets online. You will see more about it. Okay, so next, this line, you remember all the variables that we wrote for hidden, like the weights and biases? This line is what initializes them. Then in TensorFlow, we have something as called a session. We need to start a neural session here. And that is when we first we run the init, that is initializers. The weights are initialized and randomly. And we are going to run it for 30 epochs as so. We're going to take a batch. As I told earlier, batch is just number of images I'm going to be feeding into the data set at the same time. If I guess there are 1,000 images or 1,000 plus images in the MNST dataset. I'm just calculating the number of batches that there are. For each batch, I'll be running it. So when I do ses.run optimizer, now you saw that these X and Y were placeholders. By placeholders, it means that these values will be initialized by when the session is running. So that is what I have initialized here. And when the ses.run optimizer is running, it runs this optimizer and it callbacks the cost. We know that the cost requires logits. So the logits is again some calculations. In that we need layer one. It does this and then it comes back again. So TensorFlow takes care of it all in the backend. It sees you have to just simply call the optimizer function, which is as much as this line, and it'll take care of the rest of the calculations and backpropagation. You do not have to write any separate code for backpropagation here. So such a great use for TensorFlow, right? I mean, so simple. So with this, we'll probably end our TensorFlow this, as we are running a bit low on time. Next I will show you something very, very interesting. So one second. I'll close this. I'm gonna close this too. Let me show you something very, very much, which should probably get you more interested in this machine learning field. So yeah, where is it? My extras. So now, Udacity has a course on self-driving car. Now the course is paid, but the problems that we usually give is openly available on GitHub. You could probably check there. If you search Udacity car ND, you will get all the examples that you need. So what I'm going to show here is that, okay, now I have behavioral cloning. Oh yeah, sorry. What is the difference in training image data with TensorFlow and training done through CNN? TensorFlow is a framework and CNN is a kind of neural network model you use. You can use CNN in TensorFlow too. That's not a problem. But here, for a lot of people who had mentioned responses that they would like to see applications like self-driving car, this is one of those. Now, I've already trained this whole model. I won't go much into the details of the code. It's for you guys to experiment. To just say it, okay, there is a question from YouTube too. Okay, difference between backpropagation and feed-forward algorithm. So feed forward is just moving from left to right, and backpropagation is just moving from right to left. Not much difference at all there. Feed forward is when you have weights, when you take the inputs, calculate the weights, and you predict the output. Backpropagation is where, using the output, you fine tune the weights. So it's just moving, as the name suggests, going back. Okay, so you see this is a simulator. I've already got a lot of data for it, and I've already trained a model. I can show you what kind of model I've trained. It's a actual TensorFlow, it's a NVIDIA's self-driving architecture. I just implemented this. A small note on CNN, which is there, so to make a bit clear. CNN is just a kind of neural network which reuses weight. So it's just simply, rather than having one weight for each pixel, it reuses weights for a certain number of pixels and nothing. So that makes our model much more better. What is the function of placeholder? The function of placeholder is to create variables which you can initialize when the session is running. When you want to call the optimizer, you want to initialize the X and Y values. Instead of always changing it, it's better to keep it as a placeholder, because whatever value you keep in that placeholder in the session.run, that value is being transferred to the placeholder. How the time series is analyzed is something I would not like to take here, as much as I would want to talk about it. That is a question. That is a topic for us to discuss over mail. Flatten is just converting a 2D like 2D layer, or the 2 or 3D array which we have into a 1D array. That is what flatten does. So let me just show you. So now I have this track. I'm going to go into autonomous mode. Now I have my code running here. So I'm just going to go into autonomous mode. Wait, why isn't the... Okay, sorry. There was a bit lag in the system because of some... Okay. Now this car is running on its own. You can see the mode is autonomous. This car is running on its own. If you want to be sure about it, when I press the button W, it's going to go manual. And now I'm not pressing anything. I've just trained it on determining what should be the throttle and the steering value. That's it, nothing more. Now the throttle isn't much. If you want the simulator, it's publicly available on GitHub in Udacity's repository. It is very interesting thing to do actually, because you learn about how much data is required, what kind of data you'll have to do. I had to do the same because I had to train this a lot of times to get different kinds of data. So that's what makes it much more fun. I mean, right? See, after so much hard work, when you see that the car is actually driving itself, that's very good. I mean, you feel happy about it. And obviously, I can't put this as an actual car because it's not. It's just trained for this one particular track. I have to generalize it, and I have to do a lot of training there. But that's a story for another time. So this, okay, what is a better framework for beginners? TensorFlow or PyTorch? Actually, there are much more better frameworks which are like API calls for these, like Keras for TensorFlow and FastAI for PyTorch. You could look into both of them, and I would say that a lot of people find FastAI very easy. That is a really good choice, but I personally like Keras and not FastAI. It's based on the person exactly. There's no better framework for that. Both of them are really good. It totally depends on you whose methodology do you like of implementing. Okay. What is the function of kernel over here? How to use it? Backpropagation criteria. That is something more about CNN, which we do not want to go right now, as we want to end it. Like take it in mind. If Abhishek wants to take it, he might talk a bit about CNN. Like what is nano degree program? It's just a Udacity paid program, but I have not taken it. You can probably just, so for these notebooks, you can search them on GitHub. GitHub link for this. On GitHub, just search for Udacity repository and car-ND behavioral cloning. What type of graphic design generate over here in this car animation? I guess by this you mean what kind of simulation this is. Actually, this is developed by Udacity itself, and they have it all on the GitHub repository. So yeah, that's there. But with this, I guess there are no more questions. If Abhishek wants to take CNN, please feel free to. And by this part, I have ended like my whole programming and hands-on session. You guys have been really great. Thank you for the really good response. Love to teach you all.
Thanks, Rishabh. Before we end, just like Rishabh showed us about CNN, and since many of you have been asking about CNNs and RNNs, I'll just speak about it in brief. Just let me share my screen to show something. So is the Jupyter notebook that I've opened visible to all? I hope it is. So before going into all of this, you guys have been asking about CNN, right? Well, I'll just brief on it about say 3 to 4 lines. CNN is a convolutional neural network. till now we've seen that neural networks have been taking inputs as just simple vectors. But in convolutional neural networks, you can take whole images in the form of volumes. You can take different sizes of images and then convert it in the way that a neural network would understand pictures as pixels that we all can see better as human beings. CNN, there's something we've always followed, is that there's something called no free lunch. This just means that there is no single neural network that can solve all collective problems on its own. Just like there are different architectures for different problems and how they tackle those problems independently and differently from each other. Hence, we use CNN models so that images can be recognized through pixel values. And there are a lot of pixel values that come from even a small image. So we take sizes of those as volumes and we feed it into the neural network. This neural network pools all those pixels together to form representations of the features in the images. For example, if an image has a dog or a cat, the defining factor of those objects would be its characteristics. For example, a cat would have whiskers, but a dog would not. We try to teach the neural network through those characteristics, the difference between the cats and dogs, so that it understands how to differentiate between the two. Unfortunately, we won't have time to dive much more into CNN. So if you guys would like us to cover more, please let us know and email both of us. I'm sure the email has been given. And if not, we'll again send you our emails, mine as well as Rishabh's. We can have a hearty discussion on that. Also, a lot of people asked about RNNs. RNNs also, again, I'll just very briefly mention, are called recurrent neural networks. Their specialty is that they can have a certain memory state, in the sense that throughout all the computations, they can have certain memory. They can choose to either correct it or remember it, or sometimes even forget as well. This allows us to understand sequences much more better, because the neural network has an understanding of memory like we do. So I'll just show you an example of implementation of RNNs. I won't go much into detail about this entire code, just that I've implemented NumPy and TensorFlow. And the collections, you can see here, the collections is a text file in which I have all the different texts. Now this code here simply generates poems for us. The texts are also poems on which we'll train the neural network. These are the different, like Rishabh mentioned, we like to use Keras because it makes it so easy for us to understand and implement all these different aspects of a neural network. We just go into very minimal details of what's actually going on here. Simply, we just convert the words, all of these words you can see, into numerical representations. Since no neural network will be able to understand text like we do, all neural networks understands are numbers. So the best way for the neural network, for us to make it understand, is that we simply represent those words as numbers. And this entire process is just called word embeddings, where we just embed the words as separate numbers that determine what the word indicates. For example, you can see I is represented as 1, the is represented as 2, and so forth. You can see a whole bunch of different numbers and their assigned words. Now, let's not get into too much of this, since it will take a lot of time to explain, and it's highly beyond the scope of our webinar right now. So as you can see, I've just created a model, and it's just so easy. With about only these many lines, you can just start to build a model and then train it as well. So I've trained the model on 20 epochs or iterations right now. And as you can see the plot here, that gives the plot between the number of iterations and the accuracy. You can see that there's a good 83% accuracy that I'm receiving in just 20 epochs. That barely took me 5 to 10 minutes to train. So now you can see is when on its own, I give it a word it, and then it has generated an entire poem starting with the word it. I can also set the number of words that it wants us to generate in the entire thing. And here you can see that the neural network understands through memory how to create sequences and therefore predict the next word or characters given the previous ones. Question from YouTube, just a second. In brain tumor detection, how can we use feature extraction techniques? Well, I haven't looked into much, but MRI images show different temporal spaces in the MRI scans. So the features you look for are the ones that are bloated, where you see a lot of discrepancies from the ones that do have tumors. And there you will be able to see the difference of how features can help in the extraction of that. So now, how to show feature extraction? Well, that is a really big a topic to tackle on and is a part of CNN. And it requires us to go into a lot of detail about poolings as well. So we'll try not to go into much detail right now. Sorry about that. It's just that it's a little beyond the scope of what we're trying to tackle right now. For this, what is the package to be used? Like Rishabh said, and again, like I have used, you can see that I've used TensorFlow and Keras. You can also use PyTorch and FastAI, and it'll give you the same options and availabilities as well. What will you suggest how to properly gather data for training? Well, it depends. You can find a lot of different data sets on Kaggle. There are also a lot of inbuilt data sets in Keras that you can directly import through the examples. So there's that. Yeah, you can also look into the Google dataset that has open sourced more than 1 million datasets for you to use freely. And there are a lot of options. Feedback link. Yeah, feedback link will be sent to you very shortly. I'll just check if there are any more questions. What is Jupyter? Jupyter Notebook is an environment that allows us to run code blocks by block. So it's just an easy way for me to run all my deep learning code, and I'd highly recommend it since it gives us a lot of leverage as to how the graphs can be used. And by using it in a block process, we have a lot of advantages, and it makes it easy for us to visualize as well. Does neural network work to use on any algorithm of a program like Python or JS for games implementation? From this question, what I will gather is that you're asking of games development using neural networks. For that, yes, almost any online games you have has an AI board that you practice on. So those use deep learning as well. And for games and for problems that change environments, such as games, we use reinforcement learning. So that is a really big usage of neural networks as well. What is the difference between backpropagation and full stack development over the deep learning strategy? Full stack development is not something we associate with deep learning. Deep learning is always towards the back end of things and not explicitly so as well. Backpropagation is just an aspect of optimizing the neural network to do better. While full stack development is just the front end, the app development, things like that. So there's not much relation, but you can bring both together in order to create a full app developed by you. So can you please give a few good problem statements based on this domain for final year computer science students? Well, I have a few ideas, but let's see how well they are in order to tackle as specifically final year projects. You can mail us and we can have a good discussion on this. I hope we can speak about that after this seminar. Another few questions are coming in. As you say more about Kaggle, can you explain how to participate in Kaggle hackathons? I would suggest just creating a Kaggle account and going through their learn sections where they teach you exactly how to go about more than the neural training. They teach you about how to use Kaggle and their notebooks and their kernel. So once you understand that, you'll be able to understand how to upload and download notebooks for you to use on the website. Once you've understood that, you can just pick a competition that's ongoing and you can register and you'll know exactly what to do. Kaggle is such a good place for all the data sets that you'll just understand on your own once you get right into it. The TensorFlow code just went over my head. Any suggestion on how to understand it? For now, yes. The reason why we did not want to dive much deep into TensorFlow was that it is really difficult, and to understand the depths of TensorFlow, you need to understand a lot of terminologies that are associated with it. The graphs, the tensors, the placeholders, variables, and so on, which do not translate into the actual terminologies used with the same terms. So in order to understand it, we have some materials that we ourselves follow. Would be happy to share it with you and see if that helps you understand more over it. What will you suggest how to gather data for training if I want to gather it by my own? Again, I would suggest you to look into either the Kaggle data sets. They have all the data. You also have Google data set open source. But if you're trying to gather it on your own, that may be a little difficult because to do that manually is a lot of time consuming process. It takes a lot of effort and you yourself may not be knowing full well the complications of getting data that are not compatible with each other. You might think that you're collecting the correct data, but it might not be so in the case of the training of neural networks. That's why we always suggest to take in data that's already open sourced and freely available to use. I'm sure whatever you're looking for, there's a data set for you that exactly fulfills your needs. DL algorithms are used to detect brain tumor in early stages. Like I said, it is used. The learning algorithms take into account false positives in order to deal with brain tumors to figure out if the temporal spaces that are generated in the MRI scans when fed into the neural networks have something to do with the tumors or not. So it is used in that way, but there are multiple ways in which you can approach that. If you have MRI images or if you have CSV files, stuff like that. Same question again. I hope I answered that to your satisfaction. What about tech landscape technology used by deep learning process? Tech landscape process, I'm not sure what you mean by that. If you could reiterate your question and ask again, I'd be happy to get right into it. Are there any other questions that are there in the QA session? What is data.lower? Whoever's asking me, data.lower, I'm simply opening all the data that I have in my txt file into a variable called data. And then I'm simply converting the entire data into lowercase so that there is no difference between uppercase and lowercase letters, and the neural network understands text as it should be. That's just it. So can we build a model to predict COVID-19 patients by providing data set of positive patients? Yeah, exactly. Kaggle has an ongoing competition of this exactly, where the competition is to create a model that predicts the problems created by COVID and the spread pattern. So if you go into Kaggle, you'll just find it right up there at the homepage. You can't miss it. What is the basic advantages of CNN over RNN? Well, the thing is, CNN are used for images while RNN are used for text. So in essence, you cannot use RNNs for images, or you cannot use CNNs for text. So that is the difference. There's no advantage or disadvantage, because different network structures or architectures are used for different problems. So there's no advantage over. It's just that CNN works better for images, and that's why we use it, while RNN works much better for text. So that's why we use that. Are there any more questions? Handwriting method, which tech good for RNN? See, handwriting, to check handwriting, I think that is the problem that is tackled well by CNN. And I'm not sure what to repeat for RNN, since we've not gone much into detail about it, and as hope we would sometime in the future. And the thing is that handwriting recognition is just how to change to, well, in CNN, you just, in Keras, if you go, you'll have the options to change the max pooling of different layers. It's, I haven't looked into how fast AI does it, but I know that you can change this attributes of the pooling through the Keras with just a single line of code. So if you're just implementing max pooling, you'll get the option to alter it however you want. How to use CNN in IoT? Well, for those IoT devices that take into account images as their data, CNNs can be used in any form in order to predict some values, change the tech of that, and so forth. I myself do not know much about applications of deep learning in IoT, but I'm sure, like always, there are a lot of things, and if you look into it, you'll just find tons and tons of examples. For the CNN change in pool, if change means accuracy vary, that does not have to be true. When you are looking into a complex structure of a neural network such as CNNs and RNNs, just changing a single thing that will not guarantee you that your accuracy goes high on its own. There are, as you can see, a lot of different things that goes into it. It's your data, it's your inputs, layers, your hidden layers, the activation functions, the way you create the network, the way you optimize the network. There are so many small things, and to approach them all will have to be the way in order to get a good accuracy. It's not that, unfortunately, that changing a simple thing will allow us to get high means of accuracy. It highly depends on a lot of factors. Another question. What is the advantages and disadvantages over C and over RM? I've tried to explain it in the same way as I have spoken about CNN and RNN. There's no advantages or disadvantages, just that it is used better in some situations particularly, while the other struggles a lot, because honestly it is not made for that kind of problem. CNNs were made to in order to take in images. RNNs were designed in such a way to understand sequences. So it is obvious that CNNs will not understand texts because they're designed so just to take images and not generalized for everything else. The same is for RNNs. They'll struggle heavily when images are tried to fed into it, since they are not designed for such a thing. How to implement cloud computing by initializing deep learning criteria? This is a really big discussion going on about with the advancements in cloud computing and deep learning. And this discussion can go on forever, since there's nothing now limiting us to deep learning constraints or cloud computing. So in my vague answer would be that anything goes, as long as you've got the tools for it. You can take on everything. Yeah, I'll just type in my email again in the chat if there has been any error. This is on the chat. You can see the email. I've put it up, and I see the feedback forms have been put in. With that, we'll just. Can you please arrange workshop on web development? For this, you would have to ask our coordinators. With this, I think we've come to an end of our webinar. Thank you for all the opportunities and for all the questions. We've been humbled by all the responses. Thank you.
Thank you, Abhishek and Rishabh. That was a wonderful session. So now I request participants, it's time for giving your feedback and taking the test. We have shared a link in YouTube. We have shared the link in WhatsApp and Telegram groups. Please access feedback and say test through the link, and we will resume back by 4:15 for vote of thanks here. Okay, so you can please fill the feedback and give the test now. Thank you all. So good evening all. I hope you have completed your feedback and test. So shall we resume back to the session? Yeah. We request participants to come back to Zoom again. Please come back. Please resume back to Zoom. Now I call Rakshali. Please take over.
Thank you, Rishabh and Abhishek, for the wonderful session. And now I would like to call Prashant sir for the vote of thanks. Over to you, sir.
Yes. Good evening, everyone. Myself, Dr. Prasant, Assistant Professor from the Department of CSE, JAIN University. So actually, I planned to give a keynotes on deep learning, but due to network issue, I couldn't do that. I'm extremely sorry for that. Now come back to the vote of thanks. On behalf of the School of Computer Science Engineering, JAIN University, I would like to extend a heartily vote of thanks to everyone present here. First of all, I would like to thank our beloved chairman, Dr. Chandra Rachan sir, for providing the motivational infrastructure that made this event possible. I would like to thank our director, sir, Dr. Hari Prasad, and Dean Students, Bhattacharya, sir, FTP, FET, JAIN University, for encouraging the faculties and students to excel in both academic and co-curricular activities. And thanks to our Dean, sir, Dr. Kuldeep Sharma, for his support in all coordination of this event. I would like to take this opportunity to thank specially for CSI, Computer Society of India, and our department CSI coordinators, Professor Hari Prasad sir and Madhumala ma'am. I would like to thank today's speakers, Vishab and Abhishek, my students, for spending their valuable time with all of us to provide the insights, importance, and scope of the deep learning. I also extend my thanks to Dr. Narayan Samidar, HOD of CSE, and Arun sir, HOD in charge of ISE, for giving this excellent opportunity. I thank workshop coordinator, Professor Deepa ma'am, to conduct this workshop successfully. Thank you to all the faculties and students of the Department of CSE and ISE for their support in making this event possible. Finally, I thank all the participants for being a part of workshop and make this event a great success. Thank you all.
Thank you, sir. I thank all the participants, management, HOD, sir, and all the organizing committee members, student volunteers, and back support for making this workshop successful. And we are getting suggestions on few workshop. Definitely, we'll take it up, and we are going to arrange on those topics. So let us meet in the upcoming workshop. So we'll keep posting about our upcoming workshop. So thank you one and all. So this is Professor Deepa signing off for today. Thank you.